morning, colleagues, and welcome to the second day. My name is Marco Carugi. I'm a consultant for Huawei Technology. I've been invited to moderate this part of this second day of the workshop. Actually, my role in ITUT since long time is a rapporteur in study group 15, beyond study 20, where I'm dealing with the requirements and architecture for future networks, including IML. So somehow this is related to the activity we are doing here, in the sense that a lot of the work which has been initiated and progress inside ITUT in the past few years, from the first focus group on machine learning for 5G, as well later a focus group on autonomous networks, which has just ended months ago. And a lot of these result product have been brought in study group 13, including question 20, which this product has produced some result. Maybe the first one, which has been mentioned, I think, by Vision yesterday, also is Y3172. Now, more recently, the architecture for autonomous network, which will be presented by Dr. Harvey later today. So, to be brief, we have 3 parts for session 3. This session is called Open Source AI Standards, so the role that AI can play to also integrate open source standards and all the related aspects, but obviously there are various speeches here in these 3 parts which deal with different aspects. So without having introduction, I think the speaker, you will listen directly from the speaker. So we have, as usual, like yesterday, 20 minutes plus maximum 5 minutes for any question. So we stay in time. And we will have a brief break. So we started with this list order as Vishnu presented yesterday. And then we follow with after the 10 minutes break with other 2 presentations. And then we will have in the afternoon, we start again at 2 o'clock. I will remind you later these other 2 presentations about this session. Then after the break, which will be a 30 minutes break, we will talk about Green AI and CG, and in this session we have 3 speakers in this order. And then right after that, we will follow with Dr. Leon Wang, chair of Group IN, which will lead the panel. Then we hope around 5:30, Leon, 5:30, Dr. Jamusi will come for concluding remarks. I believe Thomas and Vishnu will be there too. So without waiting more, I hope you had a nice day yesterday. Very interesting workshop. I hope today this interest and this valuable content will continue. So I call Antonio as the first speaker, my colleague from Huawei.
So yes, as you can see, my presentation is about the benchmark dataset to assess large language model telecommunication knowledge. As Marco said, I'm Antonio Domenico, senior researcher at Huawei Technology. I'm based in Paris. And actually with Marco, we work together at ITUT study group 13. I'm also leading one activity in IEEE. It's ETI on generative AI, in particular, the activity related to dataset and competition. And I'm co-leading the network energy efficiency work stream in NGMN network. Let's start with actually the technical presentation. First of all, I would like to briefly introduce the current status of large language model. As you can see, this is a bit the trend of large language model in terms of size. It's smaller models, from the nano ones, Mamba 2, up to Cloud 3 or Epus and so on. You miss here the latest GPT-4 version, but you can see how big are becoming, what is the trend in terms of sizes. And this trend of sizes reflect also trend in computational requirement, obviously. What we can observe is that every 4 to 6 months, the computational requirement of large language model double. I think it was Jacob say today we are beyond more, let's say, trend in terms of computational capacity. And this you can see clearly from large language model deployment and so on. One other interesting thing is about the training cost. Obviously, larger model means larger cost. Okay, more or less, you can think that training a large language model of 10 million parameter costs around $1 million. So you can make the math and see how much these people are spending for a large language model. Another very interesting trend is about the gap between open source model and private model. Okay, this gap is filling up. They are closing. Open source model, they are getting closer in terms of performance to the private one. More or less, there is a gap of 1 year performance, but it's shrinking, this gap. So this is a very interesting performance trend. Another thing is about this chinchilla scaling law, let's say, observation. No? This was an observation in this chinchilla paper. Basically, these guys in this paper, they said, let's say, they highlight a trend for the optimal training. Basically, they said that there was the need for 20 test token per parameter. Okay, so for instance, if you want to train a 70 billion model, basically you need 1.4 tera token of information for the optimal training. Okay, so beside this general presentation of a large language model trend, obviously from our perspective, from our industry perspective, we are interested to understand how large language model can be used in telecom. This analysis came from McKinsey a few months ago, and here you can see what the people in our ecosystem think about the potential impact of generative AI from a CapEx perspective and benefit perspective. You can see that basically the most interesting, let's say, use case or business domain are related to customer service. So improving the quality of let's say, customer service from IT company, marketing and sales to generate customer-specific content, network, then IT and support function. So you can see the percentage customer service and marketing and sales, they have basically the same expected impact, 35%. Then network 15%, IT 10%, and 5%. The other percentage, 85, 45, 62, 55, and 10, represent let's say, the ratio of business leader working on that specific domain. Okay, for instance, 85% of the people interviewed in the survey are actually working for customer service based on generative AI, and they expect that this use case will represent 35% of, let's say, of the overall impact in terms of LLM. Okay. So from our perspective, let's say, just if you want to find something a bit more technical, you can see how you can use LLM, let's say, to improve current generation of telecommunication network, not only, let's say, from a business perspective, but actually from a technological perspective. In this paper, which has been accepted in IEEE Communication Magazine. So basically, we present how to use large language model for network modeling, for troubleshooting, different use case, let's say. Because from our perspective, the idea is to use large language model to pay the weight of our network automation, which is actually one of the biggest topic on this workshop, right? And so we think that large language model can fill the gap between the different, let's say, people who are working in this domain. In particular, you have the customer, the users, let's say, the researcher and the engineer, which actually deploy the product developed by the researchers. Okay. Here I want to show you one example that we have analyzed in this magazine paper. So using large language model for telecom network modeling. Okay. In particular, this is related to model the energy consumption of the station. What we have done is that we have considered a scenario with a 90 single carrier base station. Okay, pretty small network, let's say, with limited capability in terms of energy saving. We consider only simple shutdown. This is a cell discontinuous transmission. Basically, the base station where there is no data to transmit, shut down the power amplifier to save energy. Okay, and then reactivate when there is new traffic arriving in the buffer and so on. So this is a very popular, let's say, kind of energy saving feature, which work in a very in a dynamic time domain scale. Okay. So what we have asked to this large language model, we have provided the data related to this 90 base station. We have asked to select the relevant feature among the list of a list of 12 features to understand what is the power consumption, how to characterize the power consumption of this base station, depending on the, let's say, on the traffic profile, but in particular depending on this considering this energy saving feature. We have asked the LLM to provide a mathematical formula which can characterize this energy consumption, and also a script to basically feed this model with the analytical formula and allow us to draw, to analyze, etc., the energy consumption. Okay. So basically, what we have observed is that the large language model actually managed to understand the most relevant feature among those that we provided. It came up with a formula that made sense, but was not, let's say, the most accurate one from an expert engineer or researcher perspective. And obviously the script that actually work. We know that from a coding perspective, they are quite efficient. Okay. And what we have done, we compared this LLM capabilities with the naive model, which basically just assume that future estimation is equivalent to past observation, and with our expert design machine learning model, so use a neural network to characterize the energy consumption of the station with the proper feature. Okay, and you can see here the energy consumption trend, let's say, come up with by this model with respect to the different hour of the day in which the load of this base station change, so the energy consumption change accordingly. So you can see that there is the naive approach that performed the worst. The true and the LLM, so the LLM, the based LLM are a bit different, especially at the end of the day and during the morning. Then there is the expert design machine learning, which fit very well with the true data. And then there is this large language model with context, which basically is an improved version of the first model generated by the LLM, because we have provided additional information together with the query to the LLM to allow the large language model to understand better what was the problem. Okay, in this way, you can observe that the average error, the mean absolute percentage error on the LLM went from 7.8% to 3%, which is very close to what we get with our best model, let's say our best machine learning model. This for us was quite interesting because obviously we took several months to design this, while with LLM maybe this took 1 week for understanding. Yeah. So. Yeah, that's what I've seen. Okay. Thank you, Thomas. Okay. Okay. So in terms of just let me check. Yes, we are in this page. So beyond, let's say, from this research perspective, we are also analyzing this in ITU, obviously, and ITU. We are understanding what are the use case for LLM, understanding what are the requirements from a network perspective to deploy LLM, and also to assess this LLM. Okay, this work is carried out in the study group 13. We have just started during the last meeting a technical report, work on a technical report which is called Requirement Methodology for Deploying Assessing Generative AI Model in Telecom Network. And also in the correspondent group, the Marco and Vishnu are the co-convener on CG dataset for AI ML network. Okay, so obviously, if you are interested on this topic, you can read this document to come and collaborate with us on this. Okay, now we have seen what are the potential of the LLM from some use case. One big issue from us is to understand how how to evaluate large language model in the telecom domain, especially because we have understood quickly that there is a need to go from, let's say, a general purpose large language model to large language model specialized in our domain, okay, which is very technical, has specific requirement in terms of capabilities. And one of these requirements is related to the understanding of the telecom specific knowledge. Okay, so what we have done is we constructed a data set, okay, for the automatic evaluation of large language model, and this data set is actually generated by large language models with human in the loop to be sure that actually this was let's say a comprehensive data set which makes sense without typos and so on. So what we have done, we have extracted a certain number of documents from different scenarios, let's say research publication, standard, lexicon, and so on. We have given this document to a first LLM after a cleaning process. This first LLM is called generator. Okay, this LLM generate question, multiple choice question, like this one that you can see here. So there is a question and potential option. There is the correct answer and the explanation. Okay, then there is a validator, another LLM that actually check whether this multiple choice question is correct or not. Then there is a post-processing phase in which we have filled the acronyms, we have reshuffled the order and so on. We have checked this question, whether they make sense, or at least part of them from the sampling process to understand if everything was as we expect. We have clustered them to avoid then question that was were a repetition. And then we have the final data set, which is composed by 10,000 questions, which is available on internet. Okay, so it's public. That's why it's an open data set, and you can play with it. Okay, you can check if your given model, how it works, and also improve it. So the overall, let's say, process of generating this data set, and also first evaluation of some of the model, so in particular GPT and Llama. So it's described in this paper that we submitted on wireless communication, and it's also available on internet. Yes. So from what we observed when we analyzed this, so first of all, that GPT-4 consistently outperformed GPT 3.5, which is something that we expect, and around 7% of improvement across the different categories. Then what we see is that they perform very well in terms of lexicon. If you tell them what is a PlayStation, they are capable to tell you. If you say what is a BS, an acronym, it's perfect, basically. Okay, but when you ask questions related to standard, they are actually the performance so and so. That's what I'm telling you. We need specialized model. When you make very complex questions, the performance are around 64%. Okay. And actually, another thing which is interesting, that the LLM and actually active professionals, so the average engineer on this question perform more or less the same. So again, there is okay, they are not working perfectly, but actually are working quite better than humans. So yes, the key message is this one. We need LLM specialized on telecom domain. Okay, so how we can do that? From a research perspective, we know that there are several ways to improve LLM. Okay, you have prompt engineering, you have fine tuning. What you are focusing on is retrieval augmented generation. Okay, which basically is a way to give the LLM additional context, additional information to answer to a given question, exploiting a data set of available data. Okay, so basically there is a framework that understand the query, look inside the corpus of document, what are the most relevant documents related to that query, okay, and extract from this document that he has selected additional information that is embedded, attached to the original query, such that the LLM has this, with this additional question, context, can improve the, let's say, its capability in answering to the correct information. Okay, so This again, it's a paper that we have submitted recently to co.com and is also available on arXiv. The key point here is that using this architecture here that we have designed, we have an average improvement of 6.6% when using GPT 3.5 on a benchmark, on the baseline RAG that you can find on the internet, and of around 15% with the original GPT 3.5 without RAG, which is actually let's say pretty good score. Here what we did, we focused mainly on standard. Basically, we gave to the RAG release 18 documents, and we asked we used this document to generate the question and improving the capability of the LLM to answer it to standard question. Okay, so from a research perspective, what else are we doing? We are participating to this EETI initiative I was telling you before. So large generative AI model in telecom. So obviously this is a more academic initiative to push on a research perspective. So again, if you're interested, you can join to this group. Look, we are producing a white paper. There is a lot of professors here involved in this initiative. It's a way to interact and grow within the community. Another big thing, so I think Vishnu talked about, there is currently a challenge on specialized large language model for telecom network. Basically, in this challenge, there are two tasks, two problems. Improve the capability of V2, which is this Microsoft relatively small language model on our dataset, or using Falcon. Okay, Falcon is this model developed by the Emirates on. And then basically we also provide Amazon computational capability for the participant to work on this model. So yeah, thank you for this presentation. I hope you enjoyed, and if you have any questions,
So thank you, Antonio. This was very insightful, a lot of work behind. I was curious about the characterization of the energy consumption for the base station. So I didn't understand if it is kind of a time series prediction or if it is a...
It's an inference.
Okay.
Okay. So there is here the idea, I didn't give the detail because this is a high-level presentation. Okay. The idea is basically that you have actually cell level KPI, okay, with several features like the load of the station, the time in which for that base station in an hour symbol shutdown has been activated, then maybe the number of users, the position, also some engineering parameters like the position of the base station, the bandwidth, if it is 4G or 5G, the tilting angle. You have a lot of related information. Some of them are time dependent, let's say, and some of them are static. Some of them are relevant to the problem and others not. So what we said, okay, to the LLM, these are the information that you have. What is the energy consumption of the base station with this parameter, with this feature? So make an inference and to specifically come up with an analytical model and an equation that okay, the energy consumption of that base station is the function of this parameter with this coefficient.
Okay, and then I guess that you have the rule of shutting down that part of this base station if there is not enough.
Yeah, so for this specific case, the shutting down is represent. Let's say for each hour. Let's say the shutting down information is, for instance, at that hour, it spent 500 seconds with symbol shutdown active, okay? Or maybe 3,600 seconds fully shut down because it's in the night.
And how do you get the ground truth?
We have it.
But is it something that is feasible to have like everywhere, or that's why you need to do the inference?
In general. So in general, this depends on the base station, let's say, configuration. So this is a problem actually. 3GPP is looking at this in SA2, if I remember well, because basically there are sensors to measure the energy consumption of the base station. But these sensors are typically outside of the base station, okay? So the base station itself, it doesn't know how much it is consuming. But this information can be, let's say, sent through a private interface to the management system. At that level, you know everything on, let's say, large-scale granularity. Okay, and this is why, for instance, if you want to have, you do some optimization based on the energy consumption, there are some challenges because at the core network level, you need to take all the information from the management system, and maybe you don't want to do this optimization on an hour level. You want to do it on a different time scale. So there is a kind of an interest to understand, predict, or infer what is the energy consumption based on other parameters.
Very insightful. Very nice.
There was another question at the end.
I'll leave it open. Thanks very much for the presentation. So I'm going to challenge you now, because you'll show the comparison later on where you say, hey, we're better than ChatGPT 3.5. Fair.
With the RAG, without the RAG?
Well, with your approach. So,
Okay.
yeah. So then the question is,
Yes.
the ChatGPT is trained on publicly available text corpora, which doesn't sit behind a paywall or behind a password protected repository. So do you think the comparison is then fair?
This is public data. What we have used,
What have you trained on?
so we didn't train. There is no training here.
No training.
There is no training. So as I was saying, you can use fine tuning, you can use prompt engineering, you can use RAG to improve the performance of an LLM. Here we use RAG. So what we did is that we designed, let's say, a machine learning architecture that read documents which are publicly available. These are standard documents. You can download it from ITU, from 3GPP, FTP, or wherever they are public, and read them. And based on the query that has been asked to the LLM, find the paragraphs, let's say, which are relevant to that question, and attach it to the original question so that the LLM has additional information to that to answer to the question. So the challenge for designing proper RAG is, first of all, the dimension of the overall. I mean, you cannot give him the full document to the LLM. It's impossible. Also, you need to find which is the proper document. There is some, let's say, challenge from a memory perspective and so on.
Right. So there's a bit of manual work involved there.
No, everything is automatic, except the fact that you need to have a database, okay, from which this machine learning can extract the relevant information. So imagine again, I do a question to LLM, okay, maybe the lady on the first row can be the LLM, and then there is another colleague that go to the library, and so the LLM tell to the colleague, okay, I need to answer to this question. The colleague go to the library, find the proper book, open to the right pages, and give it to the LLM. And the LLM has the original question, the page on which the other colleague think that there is on the expected answer, and provide the LLM can provide a better answer.
Okay, thanks.
Thanks. Last one. There was a last question.
Yeah.
Please.
I think on one of the slides you showed the comparison
Mike,
between.
maybe everybody.
Thank you very much. I think on one of the slides you showed the difference between different LLMs and human behavior in answering the questions. Well, one question is, what is the sample of these humans asking the questions? Are these experts or random sample? That's one thing.
Yes, engineers.
Yeah. So we can safely assume that a big percent of them does not have the domain expertise to answer some of these questions. The main message in seeing these numbers is that even in the worst case scenarios, LLMs still outperform humans, which is a bit of a biased message because, again, if I bring experts to answer these questions, they'll probably outperform the LLMs. And now the question is, do we want the LLMs to outperform ordinary people in answering specialized questions, or do we want the LLMs to outperform experts And then you map this to network automation, and then you say, okay, do we want the LLMs to outperform experts in managing the network, or do we want the LLMs just to be a mediocre, easy way of managing the network?
So this is my vision. Huh? Someone else can tell you something different. I don't want to LLM to have specialized expert. First of all, because otherwise I will lose my job, right? So what I want is the LLM to accelerate the overall process. Okay. So what I think is that an LLM can help me in my specialized work in a domain in which I'm not an expert, but is related to my daily job. Imagine you have a new problem which you don't know. The time that takes you, I mean, to become an expert can be reduced by the LLM to, you see what I mean?
Yeah.
You have a new problem and you go from run to core, I don't know. Okay, so obviously from a human perspective, you have a limited memory capability, let's say. Okay, you can be an expert, but not an expert on anything, on any subject. So from my perspective, LLM can bootstrap our daily work, can support, accelerate the process of designing, of optimizing, etc., etc. I don't want them.
So hence, what you're saying is that LLM's role should be confined for the time being in these AI assisted scenarios led by humans. But do you really see it advancing into a position of providing full autonomy?
I think it. So there is this step, this role here. Another role is to, as I was saying before, is to fill the gap between these different, let's say, roles, different entities, like the customer. We were.
But I think you're avoiding the answer to the question. Will it get to a point where it provides full autonomy?
The LLM alone, no. Obviously, no. The LLM alone is one of the block in this autonomous loop. I don't believe the LLM can optimize, not today, the capability of planning, the decision making. This is poor from my perspective, okay? But the capability of, let's say, understanding, read.
Being a component in the closed loop, right? Okay.
Very good.
Thanks.
Thank you.
Thank you.
Late, but I started late. So the next is Dr. Leon Wong. Leon, please. He's a senior researcher at Good Mobile at the Institute of Technology. And speaking about research and collaboration, he talked about, actually has been the leader of the German focus group on autonomous network, which just concluded, and QT. Among other tasks, so now we talk about Holy Grail or autonomous access.
So a very good day again. I'm Leon. I'm from Rakuten Mobile. I work in the office network R&D for Rakuten Mobile. So I think we have a very interesting conversation just now, a bit heated up. I'll just take everyone a bit more relaxed situations. I'll just share a story today, right? So I prepared a full movie for you actually, the director's uncut version, but I think for the benefit of coffee and tea times, I'll try to give you a trailer. All right, so let's start with the movie. Okay. So once upon a time not so distant away from our time, the land far, far away, at least from Geneva, we are here today. There is this colony, all right? A colony that is inhabited by a very enthusiastic and optimistic people. So these people, they have a very, this colony, they have a very interesting vision. Basically, they want to democratize the mobile phone industry. And with such bold visions, people start to push the boundaries of innovations, where they manage to roll out what they claim is the world's first end-to-end virtualized cloud-native mobile network. It's a long word, but yeah, it's the world's first end-to-end cloud-native mobile network. So yeah, there's a lot of energy put in there to roll out this, and everything in Rakuten Mobile is basically fully virtualized and based on a very open architecture itself. So they have proved themselves to be very innovative in the industry itself. They have been leading a lot of global RAN, open RAN initiative. They have deployed a very highly advanced edge network and done this through very efficient operations through automations. Now, this other colony that we have in the Papua New Land. Now, while this colony is very busy with the current network trying to be open, trying to have edge networks, trying to have high automations, there's this one tribe in this colony, one small tribe in this colony. They are a bit different. I said they are not like others. So they have a very special mission, a mission bestowed upon by the great shaman. To find the legacy artifact, some say is the holy grail of all networks. One so powerful that the legendary say itself will forever change the way how network is run. And that brings us with this great mission, bring us to the adventure of the tribe. Adventure of autonomous networks, how this tribe try to find autonomous itself. All right. So, I mean, these are very interesting people themselves. So, but of course, luckily this tribe, they live not so distant away from our current time. The tribe took out their laptop and they tried to search for autonomous networks. So, with the power of internet, the kind of information that we have everywhere, they came to the information center, asked where is autonomous networks, right? And then which points to, hey, there's an elevator there. Why don't you check it out? So the tribe went to look closer and found that, hey, interestingly, there is multiple floors to the autonomous networks. So there's other tribes that have tried to look for autonomous networks. There IBM, the tribe of IBM that works, try to figure out the different autonomous computing models back in long time ago, that's 2005. Now, of course, we have the nice ITU on 3173 that works on the intelligence levels. We have 3GPP, we have TM-BORM as well. But now, still the questions, which floor to the Holy Grail? Right? So they figure out that in order to actually reach the Holy Grail, you need to go to level 5, right? Which is based on the 3173, it's basically full intelligence. Everything, the system, everything. Like human no longer exists, things like that, everything. So how do you reach that? So, well, it seems simple enough, like it's like level 1, 2, 3, 4, 5. Okay, let's just go up the stairs, 1, 2, 3, 4, 5. Right? How difficult can that be? Oh, they were so nice. Throw that away. To achieve level 5, the complexity is exponential. It's how this works. Then they start to go, level 5, please? In the elevator. Now, some might be laughing. So, which through that understanding of reaching level 5, they now are faced with this thing called the Mount AM. So for those that has with good memories, not by mine, some of you have seen this Mount AM before. I think we presented this in the focus group for IML5G long time ago. So what is this Mount AM? All right. So basically, this Mount AM is the different pieces that there's different puzzles that you need to unravel to basically to reach the Holy Grail. All right. So yeah, the Holy Grail, which is alongside myself. So so many pieces, so many things that they are now based upon. So they are trying to figure out how can we actually conquer this Mount AM. This is a humongous task. Seems impossible. But of course, the tribes try to take a step back, try to look at things differently. They like simple things. So they try to figure out how can they simplify this. So and that's the first lesson that they figure out when they still saw the Mount AM is that we need AI that is creative. All right. I don't know, LM can achieve autonomous network or not. Some say yes, some say no. You heard that just now. There are so many things. Evolutions, algorithm, generative AI. But we need an AI that is creative. At least that's the first thing, the first discovery that they figure out. All right. So the tribe, with that, they want the first thing that they learned is they need an AI that creative, and through that they figure out the artifact, the crystal key of concepts. All right. So now they found the crystal key of concept. First lessons through the first lesson they learned. So the crystal key of concepts basically is the concept of autonomousness. They try to simplify the whole, I would say, the effort they need to achieve to conquer this mountain. So written somewhere in the journal of I don't know, their father, or I don't know, they found a nice journal that's written somewhere about the autonomous networks. Is these three key crystal concepts. So the first concept is create, second, validate, third, apply. Sounds simple enough. Create, validate, apply. So what is autonomous networks? Autonomous network is basically something that it can evolve itself, self-evolve, and it can adapt itself to solve things that is unknown. Of course, based on the set of capabilities and abilities or building blocks they have to do that. So the first thing they need to do, the autonomous networks need to do, not the human, the autonomous needs to do is to create solutions. And then once you create solutions, you try to validate the solutions, because yeah, you cannot just create the solutions and just throw it out there, and then all the engineers will be screaming at them. This doesn't work, this doesn't work. So you need to validate before you put it out. And after you validate, the next thing, or the same thing to do is to apply it, because now you have the solutions, you have validated it. What are you gonna do with it? You apply it, and if you don't apply it, then what's the use of creating and validating it? Right? So simple. So the tribe is very happy. It's like, create, validate, apply. This is easy. It sounds same. You have managed to simplify a very complex thing to a few key concepts that we can achieve autonomous networks together. All right. With that, take a step back. Now let's go back to the colony where the tribe came from. So this colony, what they are is basically they operate networks. It's a mobile networks. So what do you do when you operate networks? There's a set of activities you need to do. You need to build. You need to plan. Sorry, not shoot before you aim, but yeah, plan, build, operate, maintain, recover when everything's on fire, and all other things. So all these activities, you can call them a use case. Pick one use case from all these domains. To manage this kind of use case, you need to have a solutions, whether is it for optimizations, recovery, or just keep constant ongoing forever loop. First, you design the solutions, then you operate solutions, then you figure out whether the solutions is meeting the target or meeting the performance that initially you aim for through the design of the requirements. If it does, then you go back to the operate, you forever do that. If it doesn't, you miss the target, you go back to the drawing board again, and you start to redesign everything again. Right? Then you go back to the same loop, you redesign new solutions, you operate it. If it hits the KPI, performance, good, you will continue to operate. And it goes on forever like this for all the different activities. All right. So this is how basically the colony operates the network. All right, then how do we transform this? How do we think, okay, so this is how the things changes, all right? So same thing that we have earlier, that you saw earlier. So you have a solution on the left, you need people, some people, very smart people, the experts that they cannot be replaced by LM to create and validate the design. Someone has to apply it, good. And then you have a bunch of people through the method of procedures, very standard procedures, they click step 1, step 2, step 3, step 4. Maybe you need one person to click one button each, and then you need 4 persons to do the same thing. Whether at the end of the day, whether that operation meets the target, good. If it doesn't meet the targets, you go back to redesign. The smart people on the left, experts, will need to redesign new solutions. Now, as the colony become a bit much more smarter, and you go into the things called the era of open loop controller. Now you don't need you don't need 4 people to operate the networks. So you just have 1 people to do it, to automations, to some scripts. The 1 person will just click on it, monitors it, click on it, still monitor it, sits in the operation center, the NOC, 24 hours a day without coffee, never sleeps. Maybe they sleep on the floor, but yeah. So you still need someone to operate it, but At least they don't need 4 people to operate it. 3 people can go on holiday for now. Then the poor guy on the left still have to redesign it when something wrong happens. Moving forward, as they advance through evolutions, now they have the closed loop controllers. Now all the people on the right, they can go on holiday. All right, they can go to the French shops. So now we have the closed loop controller. You don't need people to operate it anymore. The closed loop controller is smart enough to be able to pick up the metrics to figure out whether is it hitting the target. It is not. It has some capabilities to automate, to change its own configurations, to adapt to the known situations that they are programmed to do that. All right, if these do that, if not do this, and so forth. At least they know you don't need humans to operate, at least for now. But if there's a hit, you call back the poor team on the left. Hey, you need to come back from French Alps. You need to come back from Mont Blanc and to redesign the whole thing again. This is the colony, all right. So how can we release these people so that they can go to enjoy Chamonix, Mont Blanc, or any else, Long, I don't know. All right. So that's where we bring in the 3 concepts: create, validate, apply. So basically, we are trying to remove, let's say. Yeah, we don't want to lose our jobs. Antonio, I don't want to lose our job as well. So we want to release the people from the lab as well. And so that it can be replaced by components that can actually be automated in a sense, so that we can achieve the actual autonomy. So you have the automations of the operations, but now you have the automations of the design as well through the different components. I will go into a bit on all these different components later. But basically, now the controller itself that has been produced by the design, the autonomy engine, what you call it, that produce the controller, they are evolvable. Seems similar to closed loop controllers, but they know how to call back to the design part, and the design would be able to regenerate a new one, evolve a new controller, so that it can adapt to new situations without calling the people on the left back from Mont Blanc. All right, so in simple terms, basically we are moving from human-centric to automations. I think everyone is very familiar with this. Everyone is trying to do this. And then from automations, autonomy. Simple steps. Not so simple. So again, back to the mount and yeah, all right. So we have the key, we have some ideas how to do this now. Okay, yeah, the first block, the first piece is slightly clearer now. But with this new superpower to be able to see this, the new superpower of crystal key concepts comes with more difficulties. Greater how do you say that? Greater power comes with greater responsibility. Greater difficulties actually. With that, the tribe now has a very clear view. Not very clear, but a clearer view of Mount Yan. We see all the fogs are gone. You see a very nice view of the mountains. But the problem is, it's even worse. The track to the mountain is even more treacherous. So that's not good. Yeah, the more you go there, it's like, oh my gosh, this is way bigger than we thought, even though we know it's very big in the beginning. So the next discovery or the lesson they learned is that, hey, there's no way we can conquer this alone. All right? So they figure out, hey, we need a lot of different collaborations, the industry, the academia, open collaborations, all kinds of people around it to conquer this alone, because this tribe, they are small tribe. They cannot just conquer this big mountain themselves. Right? So with that brings us to the first nice thing of the ITU focus group on top networks. Akko is very familiar with that. So the tribe managed to convince, brought same-minded people to work together on this autonomous networks to this focus group. It was established under Secretary 13th back in 2021. The focus ran for 3 years plus, and it ended end of last year. So what the focus group do, basically, what they did is it provides a very nice open platform to perform pre-standard activities. Not standard activities, but they really perform a lot of pre-standard activities related to autonomous networks, which plays a lot of part eventually. So in summary, the focus group had 14 virtual meetings, big ones bi-monthly. A lot of help from Shaba and Thomas. We had a lot of weekly meetings every week. They came on Thursday, 113 meetings, weekly meetings. I didn't know how we managed that, but basically every week came and discussed and move things forward. We have 361 input documents. We have 300 over unique individuals, spanning from round calculations, maybe not the correct numbers, but we have like 68 countries. From there, there's about 20 members that represents the member states, 25 that represents the operating agencies, like mobile operators, 50 from scientific or industrial organizations, and then we have a good chunk of people from the academia as well. There's 5 different universities or academic people that joined the group and discuss together on the focus group on autonomous networks. So through this focus group itself, you can find information through this website. You can scan the QR code if you want. So then through this focus group, we figure out that there are actually many artifacts, or some may call enablers, that needs to be discovered to achieve autonomous networks. It's not just one, it's not just the crystal key concept, it's just not just LLM, it's not just this and that, but there is a lot of them that needs to figure out to achieve autonomous networks. So the first thing the focus group that they found, the artifacts, is the ancient scroll of use cases. It's not so ancient, but yeah, it's 2 or 3 years, I guess. So what is this use case? What is this ancient scroll? So it's a collection of use cases for autonomous networks. So it's divided into 2 categories. It captures the requirements, the interactions between the different actors for the use cases, and possible key components can derive from the use cases. So this is published as Supplement 71 in Y.3 series. You can search the IT repository for that. So a quick glimpse inside these use cases is basically talks about the network resource. Like for example, this one use case is on the network resource collocations for emergency management-based close analysis, and from there we derive the use case requirements and so forth. So the next artifact they found is the arc of AN. The architecture of AN. All right, so there is these documents that the focus group together will help figure out the architecture of autonomous network itself based on the 3 key concepts. So from these documents, we captured the requirements of the architectures. We described the different components of the architecture required to achieve the autonomous networks. We have the description of the architecture itself, and then we have some secret as well explaining the interactions between the architecture components. So it's published as Y.306. I can have a look at that in documents. Capture of this high-level framework for autonomous networks. So this is what you can find once you open up the arc itself. You can find it. So this architecture itself is based on the 3 key concepts, the 3 crystal concepts that we talk about. How we translate these key concepts into different components, like the create validate itself is embedded in the autonomy engines, where each of them is one represent one subsystem component itself. And then you have the apply part where the application subsystem will do the application. So then, of course, you have all other necessary components to make the architecture works. Right? So then the tribe reached the temple of trust, leap of faith. So to reach a end means you, like I said earlier, you need to trust the system itself, because human is not involved in the design. So how can you cross this valley itself? You need a leap of faith, which is the trust itself. So we try to look in the aspect of trust, how we can trust autonomous networks through these documents, recommendations on Y.3060. So we give the necessary study of the trust for autonomous network autonomy and intelligence itself. some concept of transport networks. So we look at that. Inside documents, you can see the overall workflow model for the trusted AN, the trustee, the trustor. Then you have some matrix described in this document to measure the trust itself. So with that, then you can take a leap of faith for autonomy. Now, other than the focus group, the tribe itself, the tribe themselves also did some collaborations with the academia and universities as well. They found this dial of destiny where they can look for the time in time, digital twin one. So they worked together with Munich, Technical University of Munich, published a paper in Network Futures. Yeah, Network Futures. It's called the Capitanias, where you can basically use data-driven algorithm to learn models for behavior of real entities. And then basically trying to use digital twins and data-driven algorithms, data-driven algorithms to do predictions, and then through the predictions, optimize provide the right configurations to the HPA to basically scale up or to scale down the Kubernetes space in different situations. All right. Then throughout that previous work, move one step further. We published another paper as well to NBXDN as well. It's called the HYPA. So basically, we are trying to figure out rather than just being proactive or reactive. The current one, the Kubernetes, is just reactive. And you have a lot of predictive model to predict. Then you try to scale up, scale down. But can we combine both of best of both worlds? These components. So we figure try to produce something that basically can be proactive and reactive at certain different point of time, depending on the situations. And then at the same time, continuously update the proactive components, the predictive models of the proactive components, so that it can adapt to the new traffic. Right? Basically, simple results that you see from here is like see my mouse. So basically, from here, at this point, the first part of graph, the predictive is still working. The gray, basically the zone here. But from here, you can see a big burst of levels, and so that's where it's beyond the predictive model already. So then it kicks in the reactive components to manage to handle this kind of burst. And then once it figures out that the reactive itself, the burst keeps going and the predictive models has been way off the prediction already. You kick in a stage, the rate part where you try to relearn the predictive models so that after the relearning and pushing out the new models, you can actually predict the network better now. So basically, that's a very simple overview of this. Okay. Yeah, trailer, not full movie. Sorry, I was moving. So, and then at the age, they found the fountain of Prune, where we work with St. Andrews. Basically, it's prunings or DNNs. So we try to figure out how we can rapidly deploy prune DNN models for the age sites. So this is part of the autonomous networks. So we combine both the structure and unstructured pruning at initializations. We try to identify which DNN layers is more the sensitivity of the DNN layers that can prune based on unstructured pruning sparsity. Then to create a plan to prune that. After that, we reinitialize and prune it again so that we have a new compressed lightweight model that can be deployed very fast. All right, so this is the system. You can have a look at the paper. It's been accepted to CC Grid as well. So a quick result of this, we try to do comparison BGG as well as ResNet, BG16 and ResNet 20, comparing to just structured pruning and unstructured pruning, as well as just the dense model of the BGG or the dense model of ResNet itself. Basically, recombing can achieve a reasonable level of accuracy, which much faster training time. The bottom part is training time itself, so you can actually train faster and reach a very good accuracy compared to other methods. So with that, because the colony loved ORAN, so we met with the captain ORAN, so AI ORAN. So we tried to figure out what AI can be incorporated to ORAN itself, adaptation, but how do you apply such kind of things to ORAN itself? Because around is, I think it's a quite interesting topic itself, and the colony is trying to push forward. So we have this non-real-time rate platform, and there's this new real-time platform, not much different from the ORAN one itself, but basically we try to see how we can integrate the AI platforms with the RF itself through REST API, so we can do more the training and inference data. Because this research part of the national project from NIC in Japan. So what we achieved here is basically one of the things we managed to do is achieve energy saving through RF channel reconfigurations. So we managed to minimize our power consumptions by deactivating the RF channel during low traffic periods. It's a quick one. So during the low traffic periods where we have less connected UEs, the energy savings kicks in, and you can see that's the energy saving. With the energy saving enabled, we use less power compared to the baseline that we don't use energy savings. So we got 25% energy savings through the AI models to the AI platform for the grid. So then this tribe met another tribe. It's called tribe Bugaton. I think those that joined the workshop yesterday, Vishnu has already provided quite an overview of the Bugaton itself. So the Bugaton is part of the focus group work itself, so it's trying to build and demonstrate the works that's done in the focus group on autonomous networks. So in simple terms, it's trying to turn concepts into working codes and POCs that can be shared with everyone. So like what we did for 2023, the problem set was like, can we take the UN, the AN use cases, the Asian scroll, the ARC, architecture, and some open codes, try and put in a knowledge base and try to annotate it and try to see whether we can have something interesting chatbot or something that we can't, something similar that we can't query, like maybe telco rack, something similar. I'm not saying it's good at telco rack, but yeah, something's trying to do something similar with the AN users and AN itself. So the next lesson that the tribe learns is that there are actually many more lessons other than just the many for architects. So you need to make friends with the mummies as well. So as we are back to the Mount AN itself, can see we have some of the blocks have been reviewed slightly, but not by just the tribe, but by other peoples as well. We have a slightly better view of the thing itself, but still there's a long way to go. Everything is still not clear. So what will we discover next? What will the tribe discover next? What's the next adventure of autonomous networks? That's the tribe that's trying to figure out. Yeah, Berkeley's almost that. Sorry.
Yeah.
Trailer. So we have this AI. We know that AI is very important. We know that AI has been accelerating a lot of the advancement of networks technology itself. And then we have these autonomous networks. And then came this AI native that we have heard a lot through the workshops and everything. So how do we? So the things that we try to figure out is like what are the relationships between all this? So we know AN needs AI. Various numbers, various techniques of AI to achieve that. Look at the create validate apply itself. You need a lot of AI to do to achieve the create, the validate, and apply. But now AI native means that you try to design things, the AI natively in the components. But to achieve high level of ANs, you need this concept of create, validate, apply to be natively in your design so that you can achieve level 5. If not, then it's very difficult. So what is the relationship between this? I still don't fully know. We're still trying to figure out. So, but could it be that the autonomous network itself, the holy grail itself, is actually a combination of autonomous networks, AI native that we need, as well as AI itself, so that we can find the right spot, not averages. So with that, that's why we are trying to have correspondent group on AI native for telco networks. Basically, we're trying to figure out what this AI native is mean for telco networks. What kind of damage is there? What kind of gap is there? How does it relate to autonomous networks? Can we achieve this? Can we bring benefits by introducing AI native to the telco network as well? We have this correspondent group that discuss all this so that we can help study group 13 to make good decisions on whether we can have the focus group that do the necessary studies on AI native for telco network itself. So we're having the next meeting on June, next Thursday itself at 9 a.m. Feel free to join. You can join the mail. You can subscribe to the mailing list for the thing, or you can just contact me for more details. And with that, that concludes my short trailer. I apologize a bit longer than expected. So to be continued, I don't know where we'll head forward to autonomous networks. There's still a lot of things to adventure, explore together. But feel free to contact me, coffee break, water break, any plain water break, that's okay as well. So thank you for having me here.
Thanks. Yeah, we are a little late, so there is really one question. I think, Dr. Harvey, later we go back to what has been done. And this linkage with future work and knowledge base integration, collaboration with other SDOs, because this multi-SDO can form group has been participated by TUT. Any question or we move on? No? Okay, we're a little late. So the next one is Dr. Golni from NIST, and she has a lot of activity being chief of wireless network division in NIST, and now she's also a NIST fellow, and she leads many projects. Today we talk about integrated sensing communications. You need to find here.
Okay, good morning, everyone. Thanks for Indiana Jones and the trailer to be continued, as our colleague mentioned. So here we're going to come back a little bit more on planet Earth and maybe go back to several decades, perhaps, into RF propagation measurements and modeling. We heard yesterday that we still need those, even to do very nifty things. So what I'm going to talk about is some of the measurements and modeling that is going on at NIST in the West, and sort of how we are providing this data to the community. And of course, you're all invited to join. The reason I focused on modeling on sensing, joint communication and sensing, because this is one of the key features that people think about for going forward for next G and 6G. And yeah, it's okay. We're gonna live with. Do you know affichage plan? I
see. Well, let's speak
Always Control L.
PC.
I'm more
Merci beaucoup. Thank you. Okay, very nice. So for those of you who are not familiar with NIST in the US, we're an NMI, National Metrology Institute, and we're composed of several laboratories. I come from the Communications Technology Laboratory. And again, our mission is to develop the measurement science in order to support advanced communications. So this particular program that I'm talking about sits in an advanced communication research program at NIST. So again, we're focused on measurements and instrumentation. So oftentimes we have to develop the instrument in order to conduct the measurement, not just off the shelf, because that's sort of our mission, to push the envelope in terms of measurements. And obviously, you know, testing, validation, contributions, and participation in standard development activities, including the ITU. I think we participated in the challenges, the AI challenges, and sort of data dissemination, because that's sort of our one of our key missions. Okay, so advanced comms in the era of ChatGPT. I think you guys are the experts here, but sort of to hone in on the concept of the need for data in order to do all the things that we need to do, and also to think about, you know, communications as not sort of as separate from computing and from sensing. Sensing brings us the data, computing, processing the data, and communication is basically sort of a part of that whole. Obviously, for joint communication and sensing, the idea is that we don't want to operate sensor networks on their own. We want to have utilize the communication infrastructure, what's available, in order to take advantage of that, so that we can understand better the environment. I'm not using the microphone. All right, so basically many challenges for joint communication and sensing, including those that you see for communications. So starting from the RF, you know, propagation models, signal processing, system level, you know, what are the protocols to utilize, what are the applications that we want to run on that, and of course, you know, in terms of digital twin, this idea of putting together data from multi dimensions in order to understand the whole. I think we're going to focus today on this joint communication and sensing more on the measurements and the modeling. And we're going to talk a little bit about our program, the instrumentation that is there, the data and the models, and working with the community. Okay, so a little bit on maybe this is not the crowd for it, but just to put it in context, is basically we developed the instrument. They're called channel sounders. We're currently on our 4th generation RF propagation channel sounders. In this case, as an example, we're looking at our 28 gigahertz system that basically includes large bandwidth, about 2 gigahertz of bandwidth. It's up to 256 elements because of how we stack phased array antennas, and provides us very fast speed in terms of processing, in terms of data collection. So in few minutes, we're able to collect a lot of data. In addition to the RF component, we have equipped this sensor with LiDAR and camera. So they're all synchronized in time. So whatever the RF is seeing, it's seeing also the LiDAR and the camera. Why is this important? Because we're able to collect a lot of data, and it takes us usually months in order to process the data after we've collected it. In order to expedite the post-processing, we equipped this with the LiDAR and the camera so that we can use, you guys are experts here, AI and ML, in order to do the extractions for the multipath components. So that we can understand the features of the channel. All right, so several years ago, we started looking with these very advanced systems, we started looking at an application. It's basically human sensing, different use cases, human gesture, vital signs, vital sensors, and human walking. All of these are sort of interesting in the context of joint communication and sensing. And because of our systems that are very accurate, we can actually get very rich data sets to characterize these applications. Again, we're talking about RF propagation. So this is an example of one of our later campaigns for using the 28 gigahertz system and doing gesture recognition. So from the camera system, we have the feed, we have the LiDAR, the point cloud, and then we can extract the key points. Those three streams are then combined in order, and then we can use those to extract the QD channel model. In this case, it could be QD, but it doesn't have to be. Basically, we can extract and get the multipath components to describe this. So that is an example of the kind of stuff we could do. Another sort of component of this program was to actually put the RF propagation data in context of system level, because often people start with the RF propagation, however, they don't want to stay there. They just want to use it to understand the environment and then to build, design, evaluate systems that they're developing. So what we started this initiative in order to put the propagation models in this system level models. So they're composed of different pieces, and they're all available on GitHub. It's open source tools. So we start with the RF measurements. From the RF measurements, we're able to build a channel realization model, sort of an equation that actually uses the measurement data. From that, we then feed that into the MAC simulation, emulation, and also a path to the PHY layer sensing and signal processing component. We've added to that the sensing component since we're interested in the sensing dimension. This tool suite is based for the Mac, and the PHY is based on 802.11. Is 11BF for sensing, as we extended it to BF. We're currently looking at the same for the 3GPP stack. So you can also look at this, and this is an interesting way to sort of provide the measurements in context. Obviously, there are many initiatives today with various folks looking at building more complete digital twins. I believe Jacob yesterday described the Omniverse or the Shiona, which also has this. I believe the RF propagation. In this case, our focus is mostly on RF propagation. For them, it's more focused on everything else. So we actually, are talking with them about how we can supply them with measurements to even refine their propagation validation. Okay, so a little bit more on the channel software, the channel realization software. Again, it's based on the measurements. In this case, because we're interested in sensing, we proposed a novel approach for that, which is to have a characterization of the target and then add that to the environment. Because as you know, every environment and every case is special and different. Instead of if you don't have a systematic approach for looking at this, you're going to end up with many different lots and lots of measurements. It's just I think where we need some creative ways of looking at that. But in this case, we propose this target plus environment approach where we can characterize fully a target and then have a characterization of an environment, and then we overlay both. Currently conducting validation and tests in order to better understand or to sort of characterize any errors we would do or approximation for something like this. And then we extended the PHY layer with the sensing features. So we have an ISAC physical layer model that basically incorporates the sensing features. So different things can be done here. A few words on the data dissemination program. So about 10 years ago now, we established the NextG Channel Model Alliance, which basically we supported. However, it's a true partnership with many collaborators, over 185 organizations worldwide, and many members. We do not expect any, people can join. We don't, no fees, no lengthy process for membership, other than abide by the open data initiative, and basically don't give us anything that you don't want to share with the world. So the main focus here is to exchange notes, information, approaches on propagation measurements and models, sort of the how-to, and also to exchange data. We host data sets for our data set, but also our collaborators. You go to nextg.nist.gov, that's our data repository. And you need an account because we want to make sure that people are accessing it are legit, not the machine. And we basically provide access. And so the main goals, just to recap, are to identify the usage scenarios of interest. We have both producers of data and consumers of data, people who are interested in data sets to use in ray tracing, simulations, in validation, evaluation of and design of systems. And we have people who are just, their main purpose in life is to develop and to produce or conduct measurements. So the idea is that to identify what are the usage scenarios, what's the need, where are the gaps, and to work with the community to develop those. And also to serve as a focal point for data dissemination for this particular area. This is a very niche area. We're not claiming that this can solve the universe, but it could provide perhaps the data sets that are needed in some of these larger projects. Okay, and just a sort of a an example. This is the main page where you see where you access if you have a user account, and then we go through extreme length to describe the data because if we don't know how to describe it or we don't know what the data is, we can't really use it. That's what that's our experience with that. Therefore, for every data set that we publish, we go through the extreme tedious task of describing what it is, what's the metadata basically, what is the environment, what's also the measurement instrument that produced it. Because it's important to understand that and to really capture the data itself and not have any effects of the instrument be part of it. And why we're doing this, because we think that the kind of the data we provide, it includes now LiDAR, camera, and RF, is going to be very important to better understanding the environment, the RF propagation, but also use in these larger initiatives for using AI. So we use AI again for propagation modeling because again, this is an art. Even few decades after doing this, we know that it is. We were still not too long ago using the gold standard, which is, inspection, visual inspection of the data to understand where the clusters are for the multipath components. And using ML is extremely important for us to speed things up, accelerate, and be able to do a lot more. And we participate into multiple projects, collaborative projects. Currently, we're working with in the US, the NextG Alliance, which is an initiative of the ADIS group, to develop a channel propagation measurement and model that it would be for joint communication and sensing and for use in 6G standard development going forward. We work with we participate in the ITU challenge, and we also contribute to several ITUR documents for RF propagation for indoors, outdoor propagation. We work with different tool vendors, including MathWorks, ANSYS, RevCom, others, in order to refine their models. Because oftentimes these models are based on theory, and they don't capture the environment-specific effects. So this is where measurements are important. And I think that is it. So many collaborations, as I said, and there are certain internship opportunities to work with us, whether student, faculty on sabbatical. We do host many international folks that work with us in our labs, and that's it. Thank you very much.
Formative thing, and I think in the future also, it will be interesting for IT to collaborate. Any question? If you want, yeah, Antonio, please.
Thank you for the presentation. Well, I don't know if so. My question is a bit. So what in our team, what we look for is digital twin for networks.
Yeah.
And one peculiar thing of this digital twin with respect to, what I used to use maybe when I started my research career, where we use statistical model, for the 3GPP, as Jaco was saying, etc. So our digital team are location specific. So we want to characterize the network in Geneva or the network in Paris and so on. And I fail to understand. So maybe you can tell me how we can exploit the knowledge that you can have through channel modeling in this kind of for this kind of.
So you're basically wanting to understand how these measurements scale, right? You do a measurement in one location and you want to understand how you can use this to predict a model in a different location in one sense, or even in the same location, right?
So but what we usually do is collect measurement from the real network, not measurement. I mean, it's measurement campaign, but it's more on real network signals like RSAP. No, it's like
And these are very real networks.
exactly, yeah. But we don't extrapolate characteristic of the signal based on those measures. We just I mean, yeah, some. It's a similar process, but
So you do have the measurements, and why don't you use them? That's
no,
my question.
yeah, we use it. But we don't construct the channel model. We directly.
Of course, because you have an operational network and
Yes.
you use the measurements, you feed them back, and maybe you can use AI ML to actually predict, the channel, right? You don't necessarily, and that's another question, right? So in this case, one use for these measurements is a model, right? You need the model when you're designing, when you're evaluating. You don't have a real network. You use measurements when you have an operational network to enhance the configuration, improve the optimization, utilization, all those things. And telcos have been doing this for decades, right? So you don't need a model. You need measurement information, and you need to somehow use them for whatever need you use.
For
right?
another model, to construct different
Right,
model.
exactly.
Yeah.
For your ray tracing needs, or for the digital twin, or whatever it is that we're calling it nowadays, you are gonna take, measurements. You're gonna really, what you have a ray tracer, right? Some sort of something to understand. So where these measurements can be interesting, or some measurements, is to refine the quasi part, not the deterministic part. The deterministic part is physics, right? Everybody understands laws of physics. These ray tracers are very good. They compute lots of things. Thank you to the video gaming industry for producing such powerful engines. However, you still need that effect, right? Is this a wall? What is it made of? How is this how the RF, the signal is gonna bounce back? That's what we're trying to get to. So you don't need a model at the end of the day. What you need is some measurements and how to use them, depending on what you're gonna use them for.
Let's get back. So, hello, I'm Paul. Nice to meet you. Right. So, what do? I'm a researcher. I work in the University of Glasgow. I've got a little bit of background in compilers and high performance computing, and somehow do telco things now. And the dream, right, is to work towards this idea of autonomous networks, things that can do stuff by themselves, right? And not make bad sound. That's bad upon you, right? So this picture kind of captures it. You're there, but you're not really there. Stuff is happening. The system is automatic, and you can relax, right? As opposed to everyone else, I would like to make myself obsolete because I think that would be cool. And the thing is, the bit I'm interested in is a bit different, and that leads to everything we're going to talk about. Nope, that's not my laptop. Oh, that's my laptop. Is people talk about autonomy, you think about autonomous cars, right? So these are great. You can eat a sandwich, you can fall asleep, you can do what you want. It's a mechanism to get you from point A to point B. I'd actually argue it's not autonomous, it's automatic, but that's a conversation for another day. The bit I'm interested in that I think is cool and a little bit different, and a key bit on the path to realizing these level 5 autonomous networks is what happens when the unexpected comes along, right? And unexpected is a very broad definition, from weird errors that you didn't expect, new technologies that have been invented, arbitrary data sets, things failing, aliens coming down that you didn't recognize and were part of your trained machine learning model, right? So something changed, something weird happened. And unless you plan for it, an engineer needs to come and do something. And that's not really the autonomy that we would like to have. So the question is, how do you adapt to the unknown. Okay, telcos are very, I'm gonna go fast, right? I apologize, we're gonna get through it. It's gonna be exciting because everyone wants lunch. Telcos are great breeding grounds for this kind of unknown chaos, right? Because they're amazingly wonderful legacy systems that have been going for a long time. Their mandate has changed over the last century for what it is that they're expected to do. And, you know, they're growing and they're expanding and finding their space is interesting, right? So they're also really interesting because a lot of the problems that they face are not coming from themselves, right? You have a customer base that, oh, it's coming, the next slide's coming, I promise. Hey, they have a customer base that are driving a lot of what it is that you want to see happen in terms of we want more and better and faster and cheaper. Well, at the same time, you have, I guess I don't work in a company, I can say overlords, that want things faster, cheaper, safer, with new, better everything, right? And then you have Indiana Jones trapped in the middle, you know, trying to make all this happen with limited capacity and resources, right? So how do you do it? And hence the pathway towards autonomy. So especially when you think about how we adapt to the unknown, is a very good question. How do we adapt to the unknown, right? And here's an epic picture written by another member of the tribe, actually, where you basically have this idea of we just try stuff, right? We can gloss it up with, you know, content formed, context informed, data driven, and whatever, you know, other isms you want to put in there. But basically, we just try stuff. That's what we do. And then we test it to make sure it's okay. Maybe we use formal methods to make sure it's safe and valid, but we just try stuff, right? So why don't we just do that in the network? Okay, now I'm skipping over 3 years worth of work and lots of participation from many, many different people. But yeah, yes. Good, good. So there we got this, right? So this is the 3061. This is my first standard, very excited, emotional moment again. So this was the autonomous network architecture framework. So I don't want to go into the depths of it. And really what I want to talk about today is how this is a nice way to think about all the other things that we actually heard about today. But very, very briefly. Yeah. Okay, so Leon alluded to this idea of create, validate, apply. It's what we all do every single day, whether we want to ask our mom for money, negotiate with our wife, or how late we can stay out, how to make an egg sandwich or something like that, right? We create some logic. We come up with a hypothesis that we want to have a go at. Maybe if I invite her for dinner next week, she'll say it's okay to go out and play. We then validate it by running some internal models in our head. And then if we think this is probably the best argument that I've got, you have a go and say, darling, is it okay? And of course, then the answer is definitely yes. So if you map that into the architecture, you can kind of see these very clear subsystems that are tasked with handling these tasks and responsibilities. I'm not going to talk about the depths of that. What's missing? What's missing is this really important part. And I think this is one of the kind of key differences that enables us not only to work with others, but to phrase it like this, is what we call the controller. Some people, I think, will call them agents. There's a whole definition in the document about it could be workflows, open flows, closed loop controllers, open loop controllers. You can have an LLM. But the point is, the whole purpose of this architecture is to say we update, adapt, modify, deploy, and incorporate new technologies into the controller. And the controller is then applied to the underlay to achieve the operational control that you want to see. And by doing this kind of nice abstraction and separation, it means we can focus on, well, what does autonomy mean? And then how to realize it without having to go into excessive depth in the domain. And it's really nice, just because we are doing standards, this maps really nicely to what Etsy's doing with the whole ZSM side things for their orchestration and management of closed loops. So it's a nice kind of joining point between what we do and what they do. Okay, let's get to, we'll go through this quickly. There are many nice architectural components that we could talk about. We're pursuing the next new item for the knowledge base, but we don't want to talk about that. Let's talk about the fun stuff. So everybody here is talking about the new technologies, the new things that are coming and how we can apply them. So we have LLMs, the word digital twins came up. The original title for this talk was like the convergence of the spheres and autonomous networks in the multiverse. So if this is the multiverse for all these different technologies, and this is my world, how do these things kind of combine and come together? Me. So here's my pitch. So let's start with digital twins. So this is really nice. This is really nice standards, description, definition even. That a digital twin is a digital representation of an object of interest. And I like it, it's super vague, right? But the thing I like is that it doesn't tie itself to something physical. Most of the twins you hear about in industry and stuff, they say it's a thing, it's an engine, it's a process in a chemical factory or something like that. So I like this because it doesn't necessarily tie itself to, behavior is an object of interest. Yeah, it's good. I'm even worse, right? I went even more vague. I said you have a thing, and there's a representation. I was at JAXA in Japan the other week, a month, and I was speaking to some of the guys, and I was talking to them about this, and they said this very wise gentleman at the back there, kind of pushed his glasses up his nose when I showed him this. He said, "So it's a simulator." And then his friend said, "No, it's an emulator." Right? So I don't want to say that digital twins are especially new, but I do have one bit that I think is interesting and relevant for what they talk about, how it matters to what we do. There are many different definitions and people who are trying to interpret this space. Personally, I think it's a bit of marketing. I think there are some core technologies that I can say I work at university. Models, we've had models for a while of different types. Shadows, I believe they're called dashboards or monitoring systems. Twins of twins, Long's here in the room, so NMRG are pushing this idea of, an IRTF of a control system that's based on digital twins. We disagree with that. I've got my autonomous network architecture. I'm happy, don't need that. Anyway, different conversation. Why do I need this? Why is it relevant?
This is hope not 5G, okay, maybe 4G maybe.
So I guess an autonomous network needs a fast network.
If it was deployed, this would be done. Oh, for goodness sake, come on.
Wow, it's a 12 seconds of delay, 13, 14, incredible.
You can check out the reference here. It's actually very good.
Wow.
Okay, we're done. So why do I need autonomous networks? Why do I care? I, with some colleagues in another university in Glasgow, which is Strathclyde University, tried to build it, right? We tried to, eat our humble pie and say, okay, if you want an evolution controller, we'll use genetic algorithms. You want to apply ongoing adaptation to realize, challenges of the unknown? Sure, let's go, let's do it. So we built a platform and we were doing it. In this case, it's a content delivery network. That's immaterial. But this is the problem, right? You need 30 minutes to generate one controller in this case. You can, right? You can. In the genetic algorithm world, you need to have like 10,000 per population and multiple different generations. So you end up with hundreds of thousands that you would need to try. And it's just simply unscalable for this, right? Doesn't work, doesn't make sense. So will these digital twins make it better? Oh, come on. This is just a suspense, method and tactic just to build the anticipation. Oh, for goodness sake.
Data we use here.
Don't go back to the.
Yeah. Anyone has a USB stick? Now, okay. On the path to building the digital twin, I built a simulator of my CDN system to say, right, we'll test the controller on the CDN system. Let's do that on the simulator. Let's do that. So firstly, as a true software person, seeing 100% utilization on every core is like a joyous moment. This is a very happy time for me. But this was to show that even with this, we managed to get down to 3.5 minutes of evaluating these controllers. Each of the pink dots in this thing is a controller. And that still was not really enough, right? Because you can see, even on just this quite simple example for one controller in fleets or a sea of controllers, we weren't able to get it. So step in or potentially build. So, okay, I'm just gonna keep talking and the slide will appear. So I have a new PhD student who has started, and her topic or title is to say, well, can I automatically make digital twins, right? And why would I do that? Rather than spending time forever building models and doing all these things, can I just do it, right? Can I take data from something and then just try and create a model, right? The, the answer is coming, right? So the answer is yes, you can. So it's a very simple thing. She's only been here for a month, right? But she's already cracked on. And this thing in the middle, this is Shandia, the thing in the middle here is she can get it 50,000 times faster than the simulator, right? And this is cool. And we like this, and we're hoping that this will kind of lead the way up to many different things. Okay.
Otherwise, we have a presentation there.
Do you have it?
We have that presentation there, but I was thinking you want to use yours because you modified it. Yeah.
It's clearly that it's a human in the loop.
Now, the last part
Making
you showed
the
here.
system of the flow.
It's not there.
Not there.
Not there.
You didn't give.
I didn't give it. Oops.
Okay.
Okay, guys, I think what we're gonna do is I'm gonna go for broke. We're gonna abandon the slides that I painstakingly put together, and I'm just gonna talk, right? Because we're running out of time, and that's probably more interesting. Gonna try, okay, Leon, do you have the slide of the architecture? Because that's the only thing, yes. If you have that, I can point at it. If you could help, please. It's in your work. Thank you. Right, okay, so why am I saying that? So in the architecture document, they'll hopefully come up. We have a whole thing called experimental real-time evaluation. And the whole point is to say that digital twins is a nice place that naturally fits inside. And the description that we give is the purpose of it is to evaluate these controllers that we want to create. Therefore, so that's a nice harmonious point where an existing technology being developed in a different place can integrate into this kind of design way that we try to think about autonomous networks. Okay. I'm going to use this for reference to see what I was going to say. Large language model, I'm going to not dwell because way more smart people that are in the room that can talk about this than I can, right? You have interesting things with chatbots and policy generation stuff. But what I do want to say is we tried to do it with, we gave it the architecture document. So I had a student last summer, came along, we gave him the full 60 pages of the architecture document. He threw it into ChatGPT-4. And what we did not try to do is to make a chatbot. What we did try to do was to produce the sequence diagrams. So in terms of all the components and how they're supposed to work together and all these different things, we were able to just use the vanilla ChatGPT, and we were able to reproduce sequence diagrams, which if you could see on this slide right here, is really nice. It's very, very similar. So he's in the process of writing this up into a paper. It's not perfect, but what he did find was the more interesting result was about the different modifications that we need to make, for example, to the standards process, like in terms of how we write the standards documents. Here are some simple changes that we can make that would make it more consumable in terms of the LLM to be able to actually work with it, right? Thank you, Leon. Right. That one. So in terms of how we could use that can then become constraints, right? So we've heard about physics-informed digital twins and data constrained from the RAG, for example, what we heard about before. If we could automatically parse knowledge out of these documents, not necessarily in textual form, but perhaps in kind of graphical representation or constraints, or even in terms of process of how things talk together, then perhaps we can use this in terms of the evaluation stored within the knowledge base to filter what it is in terms of what we do for creation. You guys are amazing. Thank you for staying with me. We're on path. I had a whole bunch of lovely pictures about intent that I want to talk about. I just want to say two things. Number one, if you break intent into two pieces, so there's I say something and somehow it's translated into something of structure, and then the structure is then somehow translated into a series of actions. This architecture is pretty much designed to do the second part, right? So there's loads of work and standards, nicely referenced in the slide that you can't see. It talks about how to do this kind of natural language parsing, how to structure your queries, structure intent, describe, etc. But the architecture is pretty much designed to realize intent, right? Specifically, structured intent. In the, you can see it, in the nice kind of diagram I showed you with all the cores being used and that big graph of purple things, we gave it an intent, we just gave it KPI. the system figured out how to configure, what to change, and what way to modify different things. So in that sense, we just gave it a goal and tried to achieve it. So the architecture can be used to help try to realize intent in different systems in a structured way. Okay. AI native, yes, I wanted to talk about this. Again, more nice pictures that you guys can't see. The key point I wanted to say here, I'm gonna read it. If you look at, so Ericsson are kind of the ones championing this at the moment from an industrial perspective. They're talking about, well, this is what we think intent could be, and this is what AI native could be related to that, etc. They have a whole description, but one paragraph, right? An AI native implementation leverages a data-driven and knowledge-based ecosystem where data or knowledge is consumed and produced to realize new AI-based functionality or augment and replace static rule-based mechanisms with learning and adaptive AI when needed, right? There was a beautiful transition that you won't get to see of like how we start swapping words and things, but pretty much it ends up with, if you replace what they say to say, the purpose of AI native is to realize new functionality or augment and replace mechanisms with controllers when needed, then again, you come back to this architecture. It's not to say that this is the realization of AI native. It's kind of similar to what Leon was trying to say, but more, if some of the functionality that you want to see in AI native is about adaptation and customization, then again, right, this is exactly what this thing is meant to do. And then I had some examples of like reasons why you would want to customize. So for example, we heard about pruning from Leon. If you look at these deep neural models, resource constraint is a big problem for this sort of stuff. If you want to go onto the edge, if you want to go onto someone's mobile phone, you don't have as much capacity as you have perhaps in the core of the network or somewhere off in the cloud. So in these cases, you want to customize what you have to find a trade-off and balance between your accuracy, the space consumed or resources consumed, and the performance, both in terms of trading time as well as inference for the reasons. This is exactly what this is meant to do again. We actually had a paper, which I cited here, it's called Cision, and pretty much Cision was a benchmarking tool where you would take neural networks, chop them up into different pieces, and try them out in different combinations across all the different types of compute infrastructure that you would have in order to find the most optimal balance of for that particular model, right? So again, so AI native kind of fits in here with this idea of we can use this adaptivity from the autonomy engine to drive the dynamic adaptation of the deployed AI model. And I think in one of the documents in the whole script, so forget we actually talked about an example of how you could use this both for a training process as well as for an inference process. Okay. And pretty much that's what I wanted to say. I think claimed it back on time. I'm so sorry for all the technical difficulties. But the key point I just wanted to convey from my perspective, and I'm totally biased, this is a nice way to think about how we can try to achieve the higher levels of autonomy, mainly because it does not focus on solving an individual use case. It focuses on providing a mechanism that can adapt that which you use to operate the use case, which is in this case all about the controller. And I think if you think about it, I have a whole other talk on the scalability of machine learning engineers, right? We went from having individual use cases that had statistical approaches that we used to solve them, and then we went to the whole ML plus use case. And what we did is we said, this is great, we can save time and effort on people. And pretty much what we did was we swapped the human capital to develop a solution to the use case into the human capital required to design and maintain machine learning. So until we address the human in the loop for the design process, autonomy will not be within our reach, and we will be aiming for high levels of automation. So the goal of this thing is to try to unpack that problem, phrase it in a way that we can try and do something about it. And in this, it's definitely not done, and there's definitely more to do. But it provides a nice, let's say, design language to think about this problem and how we might like to try and do something about it in the future. Cool. I would have nice things about my QR code and everything. So I'm Paul Harvey for the University of Glasgow. And my last slide, because someone recommended it, is a single slide with the sentence, a good joke. And that's it, because someone said you should finish with a good joke. So thank you so much.
So, to say yeah, this global chief technologies at Red Hat has a lot of activity at the open source community, the board among our foundation. different project and his 25 years of experience. I know him from his great activities in Cisco system many years ago, but I'm very
Thank you,
pleased to
Marco.
meet it again. And he will talk about intelligent network infrastructure and the role of AI, please.
Thank you, Marco. Marco and I go way, way back. When we were here right in this building across the street and, talking about ByteDot 1711. I don't know if anybody remembers that. This was to do with MPLS OAM. So that was probably early 2000s, 2001, that's somewhere in that time frame. Today I'm going to talk a little bit differently. I've heard a lot of you yesterday as well as today. And thank you for the work that you do, particularly in the research community. It allows us in the industry people to actually model around what you've done and allows us to actually see what is physically implementable and what can we learn from the actual, deployments. So I'm going to take a slightly different lens in my conversation in the context of what is happening in the industry. How can I actually adopt a layered cake model? I've seen some of the proposals yesterday as well as today in terms of the architecture. Paul did a good job in terms of showing what does an autonomous network look like. And he just had one slice out there in his entire picture that talked about infrastructure. Well, there's a lot of detail to that particular infrastructure that I'm bothered about, right? As part of my company, as part of the work that I do in the industry, and as part of the problems that we need to solve in that. So we should talk about what does that autonomous infra look like. I'm not talking about the full autonomous network with services and capabilities. What does that autonomous infra look like? What is that layered cake approach that we can actually try and solve? And then where does it start and what sort of automation models can we do, look and build, and then how do we actually adopt those automation models into translating the behavior of that infrastructure, which then allows you to build the kind of services, the kind of capabilities that you're looking for and that you're researching about. We'll talk a little bit about analytics, predictive AI, generative AI, and we'll actually end up with a quick call to action. Now, from my point of view, again, in that layered cake model of the infrastructure, autonomous infrastructure looks like, it's zero-touch operations that can provide, really compute network capability on the fly for deploying building services, right? Which is self-organizing, self-healing, self-configuration, self-optimizing, self-evolving. Now, all those nice little terms, I've highlighted them in red because some of them are utopian dreams, some of them are reality. But if you actually look at that entire infrastructure, you can characterize them into three main pillars. One is heavy automation. When I talk about automation, I know your concept of automation is the holistic stack. My concept of automation is that horizontal layer, right? So we talk about automation, that's kind of one of the main pillars. The second is the analytics and AI. And we've all talked about analytics and AI for quite some time in the industry, particularly for those who have been working in the SON space for a long time in terms of how you observe data, how you actually model radio behavior, and how you actually tune the radio network. And we saw a great presentation about channel estimation yesterday about cybersecurity and so on in that topic. And the third is about policy and governance. I think this is a topic that we don't spend enough time on, particularly around governance. I believe in some future workshop, we probably should have a set of sessions around exactly what does governance mean. Unfortunately, because of the time frame that we have, I won't be able to cover all these topics, but we'll try to tackle each one of them. This is real data in terms of what we are seeing deployed in the networks today. We have networks, we have telecom networks with the infrastructure layer that consists of 40, 50,000 servers just to serve a 5G core, 4G core capability. Then if you add to that RAN nodes, that adds another 40, 50,000 servers there. And then you add edge compute on top of that. Then you add others. We're already talking hundreds of thousands of machines here that are distributed, deployed in the infrastructure today. Today, in one of my largest networks as a vendor, I'm talking to you about one of my customers here in North America. They have 40,000 servers that run 4G core and 5G core together. They have, another 45,000 servers that run a RAN capability in some shape or form, whether it's RAN CU, RAN DU, or some sort of G node Bs, that are virtualized. And then on top of that, they're augmenting capacity with a public cloud, with their edge compute type of capability. In addition to that, using AWS wavelength or, uh, Outpost and things like that. So that in itself is pretty large. Now, those machines are generating data. There's a lot of data, right? Though, and this one, because of that disaggregation of hardware and software with NFT revolution and data explosion, you're getting enough amount of data, and now that data can be collected, analyzed, and then you can create some realistic models around those to actually operate better. So really, whether it is day 0, day 1, or day 2, automation kind of becomes the key first step in order to collect the right kind of data and then analyze that right kind of data to build those models and to actually then make this infrastructure better and intelligent. So if I look at this infrastructure management closed loop, this is something that I've actually seen people already go and deploy today in terms of this particular closed loop. Now, it's the same closed loop that we talked about for ages, where you observe something, you analyze something, you based on rules, policies, structures, you map it to some thresholds, and then you change that within that particular infrastructure. You use the same model to adopt zero-touch provisioning today for remote sites. Today, we can actually demonstrate and show, and people have deployed this in production networks, that you basically take a vanilla box, literally off the shelf, plug it in, and walk away. Everything else happens after that, whether authentication, ignition OS, configuration, and then, deployment of service, and then, ultimately when it's live, is automatic. It's completely automatic. I mean, one of the presentations that you saw earlier from Rakuten, they've also done something pretty similar in their network. So this is it's becoming more and more common. This level of, automation to be able to completely just plug a device, walk away, and get it to be fully functional and operational is becoming common more and more. Now, and you see that now, but in this process of automation and the closed loop cycle, what people haven't done much yet, and they're still beginning to explore that, is observability. If you enhance better observability in this particular scenario, then you can actually accumulate or collect the right kind of information. When you do that, then you can automate the rules or thresholds on which you apply. And then once you do that, you get the right kind of data, you can build those models and start to do predictive. Predictive modeling and predictive maintenance, predictive operations, and using predictive AI is something where it's just being inserted into that closed loop system now in terms of real production environments data. And when you get into that predictive model, that's where we start talking about, what does that model look like? How do we train those particular models? What's the right kind? Do we need to do? And there was an extensive discussion, and the gentleman who was here was talking about is actually not in the room, but I was happy to have a conversation. Is LLMs are a good start. RAGs definitely needed, but actually beyond RAGs, what we have seen now is you need more what I call as transformer architecture. Transformer architectures are critical, in my opinion, in terms of providing context to those particular models. And if you do contextual based, models, that's actually far better than just applying RAGs. And you have already seen, I think, Antonio, you did that presentation in terms of what was the success of RAGs and how much it can help, or prompt tuning or fine tuning, how much it can help. So our observation, and actually I'll take the example of, I have one slide that talks about the example of, power management. And yesterday there was a question of power management in that. We'll do that. So really, what we are recommending when we talk to our customers is start with automation. Hyper automation is critical. Hyper automation is absolutely necessary for you when you get there, and that becomes kind of the step 0 or the base step. Now, complicate that with an infrastructure that's deployed, distributed deployed, that's across clouds, that's multi-cloud. It's necessary for you to be able to collect the right kind of information from each location, whether it's on-prem or off-prem, or whether it's public cloud or private cloud, and get that. So literally, get to that trusted data, to get to those different types of use cases and validating operations, and creating some level of consistency in terms of that information that comes across that entire infrastructure. Now, this is just a quick example of what an event-driven model can look like. An event-driven model in terms of what we use today, and combine this with generative AI capabilities that we do for automation specifically. Now, you can define any kind of, source capabilities in terms of what are you observing in the observability architecture, right? From there, you can actually take that information using some sort of collectors and some sort of, communication methods like Kafka bus, and then use those Kafka connectors to actually look at and analyze that particular data. Now, in that analysis of the data, you determine, okay, these are some changes that need to happen, right? That you then, based on those thresholds, you evaluate, and then based on those events that are occurring, you actually do this. This is standard stuff that's being done. There's nothing magic about it. The magic really comes in when you actually pair this information with your AI models, with your, the training of that particular model that you need from the data that you collect with respect to this observability. So really, I've worked in this industry for quite some time now. What I've seen is observability can still be better. Observability comes at a cost from the infrastructure layer. It comes at a cost in terms of what are you burning with respect to resources on that particular box. If you're trying to design a RAN DU node, we know CPU cores are at a premium. Our customers come and tell us, you need everything to be done, operating system, whatever, control capability and management capability you have, and observability to all sit in under one. Oh, yeah, no, I can't do that, right? It's hard. So these are some of the physical challenges that we run into when you talk about taking, because all of the assumptions, all of the research that you do, the assumption is resources are available, right? And they're infinite, exactly right. So, but in terms of practical implementations, go to Japan, they don't have, a power space available in those GCs, which are called the local data centers, right? Where the first point hits in terms of where they're aggregating their RAN DU nodes and CUs. They don't have power available to actually rack enough number of nodes there. So these are some interesting challenges that we look at it. So in terms of how do you make this? Now let's space that and say, okay, automation is important. We can get the right kind of observability. Let's see what's the role of predictive and generative AI in that each space to be able to build a better architecture towards an autonomous infrastructure. Now, when you build an autonomous infrastructure first, then you can build an autonomous network on top of that. And then you can get to this AI native model on top of that. So predictive AI use cases are pretty common. I think we all know this. Some of this we have experimented from quite some time in terms of predictive maintenance and network operations, traffic analysis and planning, and a lot of the conversation we've had today and yesterday around, network planning, channel estimation, RF estimation, cybersecurity models, and on and on and on, right? Where you use a lot of predictive analytics and predictive AI as a critical component to actually make that happen. So this is something that we are well aware of. This is something that we have done enough amount of work and research in the past, and we continue to do so because there are still some problems to be solved in that space. That becomes kind of your phase one in the context of your AI ops model, the predictive AI business, right? So what do? Automation becomes a key pillar, instrumentation, right kind of data harvesting, which will allow us to build better predictive models. And then you can actually apply the similar techniques that you're using if you're using, let's say, general models. Now, one thing that I've learned also in my conversations with customers across the globe is that there are at least two initiatives of building telco-specific, language models. There's one attempt in Korea to do that with some of the Korean people coming together, and there is another attempt by a group of telcos, one from Japan, one from Europe, and so on. So there are two attempts that I've seen. I don't know how far they are in terms of building their own specific language model. Majority of the people are still using the standard language models and doing RAGs and prompt tuning and fine tuning to be able to come up with results that they can. But the transformer neural network architecture is something that is actually becoming suddenly within the last 3 months or so, gaining some popularity because it provides better results. We've done some analysis in the context of power management for that, and we can probably talk offline in terms of the data that I have that I can share with you. But it seems pretty promising in terms of the transformer neural network model to be able to do that. But before we get into that, some of those Gen AI conversations here very quickly, these standard techniques in terms of either implementing those different backend systems, whether it's OSS or forward flow use cases using some of the knowledge-based decision-making stuff is something that people do. So predictive analytics, predictive AI is literally, in my personal opinion, phase one. So let's take a look at what does generative AI mean for telco. Now, today, a lot of generative AI is exploited already in the telco space in terms of implementations around the standard content generation type use cases. These are chatbots for customer service, or for some sort of billing and care, those type of environments. It's already being done, it's already being implemented. And there's these co-pilots and assistants that have come up with every product that's out there is also being employed to actually provide better service to the end users and customers. And it's widely being, in my personal opinion. But there are other areas such as things like fraud detection or, more in the software development and engineering where I believe there's still more work being done or needs to be done to make this happen. This picture is actually not mine. This picture actually comes from TM Forum in terms of where they look at those different use cases and when they think will be, and they actually put out a picture. I thought it was interesting. What I'm seeing is they talk about 2 years and long term, but I feel that that's actually being more compressed into a much shorter time frame in terms of the speed at which things are being adopted. We have already seen many of these use cases being implemented today, whether it's text generation, code generation for development, image creation, content personalization. But some of the areas that are really interesting in the context of generative AI is anomaly detection, data augmentation, compliance checking. Those are critical from a telco operations context and perspective. And what we've seen is actually this being adopted. Now, what generative AI does and what it provides, particularly in the context of operations. So for example, if you point your environment to a GitOps model and a repo where you actually store, let's say, your configuration or inventory information. Now, through that, you can actually trigger and auto-generate templates, automation capability to be able to build and manage that infrastructure. So for example, you want to do compliance checking on certain portion of your network. You don't need to go write a compliance check, playbook to make that happen. You can use generative AI to actually go simply say, hey, for set of nodes that are sitting in Geneva, I want to do a compliance check to ensure that I don't have any security holes in my infrastructure. Now, that GitOps repo that holds the inventory information, you can go look at it, auto-generate a template for you, and then it actually can then execute that particular playbook in the automation framework to actually go do that, provide results back. Now, when it provides those results back, now you can say, okay, auto-remediate some of these issues because some nodes are out of version, some nodes are out of compliance, right? In terms of what software that's running, what capabilities that are happening, what firewall holes that are punched through in this, go remediate these. Now, that now moves into a model which is actually now forked into multiple branches because one of them is a network configuration issue, another one is a software lifecycle issue, a third one is something else. So then each one of them need to be implemented or controlled in a way that you would allow your closed loop to actually operate under. That's what is really critical in terms of this. So that's exactly what we can do today, for example, with IBM Watson Watson Assistant, which allows us to actually provide contextual information through that particular GitOps model to the Watson AIX, and through that auto-generate templates or playbooks that you can actually run So now the degree of autonomy, we had actually a conversation in the previous session and the one before that, in terms of what's the degree of autonomy do you want to provide? I think it is really dependent on the comfort of the operations team at this moment in time, particularly for that horizontal infrastructure layer that I'm interested in, right? I'm not talking about the full stack. When you talk about autonomous network, you talk about the entire stack and the service and everything, where a person is literally sleeping on a chair, right? I'm not talking about that. So with some of these serving and prompt tuning capabilities with Gen AI, what we have observed is some interesting things in our implementations and in our conversations with customers. Bringing AI to where data is still extremely expensive. It's not cheap, despite every conversation that happens and every hype that is there in the industry. It's not practical, right? Bringing data to AI also is expensive depending on the volume of data. Okay. So when you create an observability framework for that particular infrastructure, what does that observability framework look like? Where are you accumulating and managing that data? And what's the right, model for each provider? And it actually varies by the type of infrastructure they have and by the type of capability they have. Across the globe, I've seen where there is a lot of fiber, that's not an issue. They can chew up as much bandwidth as they want and throw as many wavelengths as they want on their transport infrastructure. Where that's not the case, it's very hard. So there is this new conversation around small models. Instead of LLMs, you're talking about SLMs, right? And there was also a conversation around, again, using the transformer model to be, instead of 10 billion parameters, you're talking about 1 billion parameters. See if there is an applicability of that, particularly in the telco space. So then the question becomes, okay, how do we as a telco community come together and interact on that? There is an interesting project that Red Hat just kicked off. It's called Instruct Lab. If you don't know, I encourage you to go take a look at it. It actually is based on Granite model that IBM has open sourced. And you can actually go provide context to that. So it's kind of, don't think of it like a RAG. It's more like, a transformer type of model where you can provide your contextual information and pretty quickly learn. And it's a small language model, right? Can pretty quickly learn and actually produce some results. So it's an interesting idea. It's open source. It's worth a try. It's something that we've been doing, and that's part of that particular Instruct Lab thing that you see in the middle there. That's, again, it's part of the open source project, right? Now, when do we not use Gen AI? Well, yeah, there are real, from a practical implementations perspective, there are many use cases for which we don't recommend using Gen AI. This is based on practices that we've actually seen. There is still a lot of hallucinations, inaccuracies, and bias. Until December of 2023, if you ask ChatGPT, who's Azhar Saeed, it tells you that, it told me at least that Azhar Saeed worked for Google. I never worked for Google. I did a contracting work. Okay, but I never worked for Google. So there is still inaccuracies and hallucinations. And now actually when you open your phone, app on ChatGPT, they actually tell you, yes, there are inaccuracies, be careful about it. Right? But there are certain areas where predictions, particularly those predictions and forecasting, decision intelligence, it is not recommended to use Gen AI. You should use Gen AI in combination with predictive AI to be more accurate and to be more, meaningful. And that's exactly where I think my recommendations or my conversations go with my customers in terms of what they want to do. There are some concerns with Gen AI. I think those are pretty well known. I don't want to go into detail on this. So if you look at what that combined architecture for Gen AI and predictive AI look like, I want you to start thinking about, I think, something that Kareem said yesterday was important. We saw in software space, the software modeling world, the whole DevOps type of model. Now think about this whole DevOps model applied to an MLOps type, right? Very, very similar in terms of what you do, How do you gather that data? How do you build on that particular data? How do you actually then analyze that piece of information and be more contextual in terms of what you're managing and what you're what you're looking at with respect to the infrastructure, and then apply that to your infrastructure, to your network, to your systems, observe and then repeat, right? Go through this. So look at this more of like an MLOps type of model where you're using predictive AI for certain things to actually gather that information, build those models, train those models, and then using generative AI in the context of actually performing actions on those models. So that's really what we are referring to here. You can use actually that kind of an MLOps chain, tool chain to be able to build in terms of model building, inferencing, and serving. So I have 3 more slides. Okay, that's it. I'm
Go on.
we're good, right? So so if you look at this one, you can then actually combine those two in terms of generative and predictive AI to actually build these type of DevSecOps type capability with some of those use cases that we had originally started off only with predictive AI, right? And build some really nice customized services, customized capabilities for providing assurance for network configurations, and then of course things like fraud detection, cybersecurity that we actually spoke about a little bit yesterday. So that requires both. This is the project that I wanted to give you as an example in terms of what we are doing in sustainability. One of the areas that we've looked at is exactly what type of metrics hardware produces. It does produce a lot of information. There are 2 projects that I want you to take a look at. One is called Kepler, which is Kubernetes Exporter for power level, this one, and the other one's CADA, which is Kubernetes event-driven automation, auto scaling, sorry. So those 2 projects combined together allow us to actually provide information from that hardware layer, from that in terms of power usage and power capabilities at a hardware server. This one. Now, there's no reason why you can actually inject any kind of metrics from any other device into that particular framework. And then based on that, you can then do analysis. We have a model that we built based on Granite. I talked about Granite a little bit before. And then we actually use that to determine what can we do with respect to the system tuning. So now we can do tunings at multiple different levels. You can tune the hardware, and where you shut down cores, you play with PNC states and things like that. You can tune the nodes. You can say, okay, I want these nodes to be evacuated because the workload is actually distributed sparsely in my cluster, right? And you shut down those nodes. So that is at a system, at a cluster level. Or you can do actually a whole domain level, where you're saying, okay, I'm going to be redirecting traffic and making changes to the east-west paths and north-south paths inside my data center or even outside my data center and influence that. So one of the questions that you asked yesterday was, when you have such a distributed deployment model of these clusters, these nodes, are you doing something, to actually manage that? The answer is absolutely yes. So through Kepler, you get that information. By applying these type of models built on Granite, IBM Watson X, you're able to now actually say, okay, I can reschedule these workloads to a certain time where it doesn't impact the service or the service SLA that's actually given to the end customer. So that's really why I wanted to share this particular example on sustainability and carbon-aware scheduling. There's still a lot more to do. I did not spend any time on governance. It's a topic that I believe we need a dedicated session on governance. I think maybe it's a topic for the next workshop that we have here, but it's something that would allow us, and that's really in a direction that we want to go into, right? Which is start with phase 0 automation, phase 1, predictive AI, phase 2, generative AI, and then combine that whole thing together. Now apply governance on top of that to ensure you are actually building an autonomous infrastructure and an autonomous network to drive that. So again, a set of pictures, but this kind of picture captures the whole story that I wanted to talk through right from the beginning to the end. Observability is key, automation is important, predictive AI is something that we know of, we can actually apply. then generative AI is actually where we can introduce, and then how you actually then close the loop in terms of automate configuration management of that particular infrastructure in building that autonomous infrastructure overall. So that's really the whole cycle that I really wanted to showcase here. So that's my last slide, thank you, Marco, and I'm pretty much on time. So in summary, really a fully automated zero-touch, deployment and operations for telco platform is what you have in the context of self-configuring, self-managing, self-evolving infrastructure. And it is possible to do that by creating those closed loops and by intelligently introducing components within those. What are those decision engines? What is that decision management capability and criteria? I think it's a conversation to be had. You're all still working as researchers in this space. As an industry, we're closely following that, and we want to be able to continue to provide real world information into that so that we can build this better and we can make this better. So my call to action is a number of points here that I want to really close it on. Data quality. Data quality is critical, right? Data quality management. There's a lot of synthetic data now being used and generated for model training, which is good and bad. I mean, I've heard a lot about digital training in the last 2 days, right? In terms of how you use, why you use that. It's true. It's helpful. It's absolutely useful. But it also comes with its own challenges. And you have to really make sure that you're aware of it, right? That's really critical. Data governance. Who stores that data? How long is it stored for? What are the privacy concerns, particularly if it pertains to user data? Now, imagine you're getting user location information on your app, right? What do you do? It's great. You need that. You need that to be able to provide some different kinds of services. You need that to be able to understand what the call flows are. You need that to be able to get a better picture of what does your radio network behaving like, looking like under different conditions. But how long do you store it? Who owns it? Who manages it, right? Human in the loop is a conversation that we often ignore, particularly in the context of autonomous infrastructure, and what's the degree of autonomy do we provide? Runaway AI is a real danger, right? We need to be more cognizant of what is that closed loop. That's why when I started this presentation early on, I talked about that management closed loop. That management closed loop is critical. Now, if you think of this as different contexts of operations, the smaller closed loops, right? Then it is critical to have in that decision-making engine a human in the loop in that particular conversation, right? That's really critical. The other thing that I'm always against, and this is Marco will agree with me on this, is standardize what's necessary and leave the rest of the innovation. Please. There is, sometimes we oversteer on defining every single interface, every single, API. And we do that because we want clarity, which is a good thing. But cloud operates on an eventual consistency model. It's pretty successful, right?
Good afternoon. Lunch is served. Golden Leader Pass holders can go to room 14 inside the Leaders Lounge on the second floor for their buffet lunch. All other pass holders can purchase lunch at the ground floor cafe or the first floor cafeteria. Bon appetit.
And it's literally the last two sentences there, right? There are many open source communities. Join them, work with them. There is a lot of work that's going on similar to the research that you're doing in the university, in the industry, in the standards bodies. Love to get your input into those open source communities, contributions into those, because ultimately we believe we can create a groundswell to actually build that mountain analogy that the gentleman from Putin had, and make that happen. And please, please, please adopt cloud native principles. It is critical because that will eventually get to the nirvana that we want, which is native AI native, right? And that's a nice term I learned yesterday and today, but it needs to become the basis, cloud native. Thank you. Very good.
Very much, Dar, for a clear presentation, logical. Actually, we are really late, but if you don't mind, we go to lunch later. So we have another speech. Okay. please.
Should I, or, I mean, it's okay, we can also discuss it.
Okay, go if it's not very long. please.
No, it's okay, we can discuss in the break.
Sounds good, thank you.
Thank you very much, Zarigan. Last speech, but not least, sorry, that we thank from ZT Corporation is Director of Study of Resource Planning and architect lead if they like engage in different research and development. So we talk about programming and AI and programming, please.
So thank you. So thank you for having you here till now. So I will make a little quicker for your lunch. And firstly, so many colleagues talk about the AI applied in network, but now I would like to talk something new about how AI and the large language model transforming programming. And my name is Waymo. I'm from ZT Corporation, and I'm also in charge of the governing board of Linux Foundation AI and Data. And firstly, I would like you to do a funny quiz. What can you see in the picture? Coca-Cola. And what color is the Coca-Cola showing in the picture? Red. Red. How many people think it is red? And how many people think it is not?
I know that.
You know that. Okay, let me zoom out of the picture and you may find the true color of it. So, what is the color? Black and white. Yeah. Yeah.
He's white.
Can't see it, it's inside the can.
Yeah.
So I also asked the same question to large language model, and the first I asked the GPT-4o, and what is the color of the Coca-Cola bottle, and the GPT-4 said that it is difficult to determine the actual color of the picture. And next I asked the question to Cloud 3, and Cloud 3 even didn't identify that this is a Coca-Cola bottle. And I also asked this question in Chinese and in Baidu, a large language model developed by a Chinese company. And what is the color of the bottle? And Baidu said that there is no Coca-Cola in the picture. So this piece said I would like to show that the human being is stronger than AI so far. So don't worry about AI surpass human beings. Okay. So let's move to the large language model path to the industry. And this is the ZT large language model strategy. And it is short for 1 plus M plus X. 1 means 1 series foundation large language model, including NLP, CV, multimodal, and M means and 3 scenarios, including R&D, manufacturer, and government and enterprises. X means the applications based on these 3 scenarios. And today I would like to talk about how to build your own large language model based on open source models, such as Llama 2 and etc. So this picture shows that the typical 7 steps in our R&D center. And including project establishment, requirement, design, development, test, industrialization, and O&M. And in each state, we will deploy the large language model. And the star in the item shows that these scenarios, large language model, has been deployed in ZTE R&D progress. And this is the typical paradigm for how to train a large language model based on foundation model. And firstly, we need to choose a foundation model, and we may choose Llama or we may choose GRM. And firstly, if we would like to train a industry large language model based on the foundation model, we need to, firstly, we need to prepare the data set for the industry. And then when we pre-train the large language model for the industry, we also needed to do the general knowledge pre-training during the industry pre-training data set, because the large language model, if you inject more about the industry data set, it will be maybe forget the something of the general knowledge. So we need to inject a little general knowledge into the large language model when we do the in-house pre-training. And then when we finish the pre-training, and we will do the fine-tuning. And we need to connect the fine-tuning data set as well. And it will be cost a lot of time to do that. And then we after the fine-tuning, we need to do the assessment to evaluate whether the large language model is meet our requirements. And we also needed to connect the data set for assessment. And then we will deploy the large language model to the industry. And in R&D scenario, we will deploy the large language model in our own data center. And here I would like to talk about the optimization for the deployment and for the deployment, because after the fine tuning, maybe the large language model is too large, and how to compress the model from a big one to the small one. I think it is very important for us, because it can save our money to do the deployment. And then we will do the monitor. We'll deploy the monitor when we after the deployment. This is a typical pipeline or workflow for large language model application development. And next I would like to share some experience for how to choose a basic or foundation large language model. And there are 3 principles for us to choose a specific large language foundation model. And first, we need to select the model, and the model should have the ability in programming. And then the second principle is that we need to consider the number of model parameters, because the too large parameter will cost a lot of GPU resources, so it is very expensive. And the third is that so many people in China and in ZTE are used to use Chinese to ask a question, to do the prompt. So we need to consider the large language model has the ability of Chinese and other languages. So here are some large language model. For example, GPT-4. I think it's too large for us, and the cost of the resource is very expensive for us. So we give up GPT, and then we have many backup the models, and finally we choose the Code Llama, and the Code Llama is responsible for for coding. And the ability of the coding is very good, and the parameter is not very large. So finally, we choose code llama. And next, we will do the enhanced pre-training. And so far, we have just limited resources and some, well, in our data center, because the GPU is too expensive. So we have to resolve the problem in the pre-training since we just have a limited resources. So we use three technologies to optimize the pre-training And the first is 3D parallel acceleration, and it can reduce the requirements of the video memory. And the second is the zero technology, and we can find it in some open source projects. And it can save CPU resources, and it can and then the third one is flash attention, and it can reduce the transfer between SRM and HBM. And flash attention is not only used in pre-training period but also in the fine tuning. And then we want to select a fine tuning method. So the same problem is that we just have limited resources. We just have only 4 GPU A100. So how to use the limited resources to do the fine tuning? So we use LoRa's algorithm, and the LoRa algorithm has many advantages, and it just use 23% of the pre-training requirement, and it can, and for the calculation resource, and it only occupy 66% of the pre-training requirements of the computing resource. And then when we are rich and we have so many more GPU card, we are going to do the full fine tuning, and I think it's better. The effect of the full fine tuning is better than LoRa. So, and then the next is about the model evaluation method. After the fine tuning, we would like to do some assessment and evaluation for to check whether the large language model will meet our requirements. And not only we use the natural language understanding data set, but also we use some coding data set for the evaluation. And here is the some metrics we would like to introduce the data set to the model evaluation period. And for the coding, we not only use the human eval as the data set, and we also collect some excellent data from our R&D center, because every year we have prepared some excellent code from our company R&D center. So these are the certain data set for the evaluation. So next is about the model evaluation pipeline, and we generate a pipeline for the evaluation. And for example, in our company, there are not only one running time environment. We also have the not only Hugging Face FT, we also have VLM running time environment. And then we will prepare the model repository, including NAMA, OPT, etc. After the pipeline of the model evaluation, and we get the report and to tell us whether the model will meet our requirement. And then this is the final eventual effect of the model after fine tuning. We have three versions. We released three versions, and version 1 is based on the large language model Llama, and the parameter is 65 billion. And the version 2 is based on the star coder, and the version 3 is based on the code Llama with the language with the parameter 34 billion. And we use 4 to 6 cards and several days for the fine tuning. And this here is the result of the fine tuning. And for the version 1, the value is from, and the value is based on the human evil assessment. The value is from 27 to 34, and the version 2 is based on the star code, and it is better than the first one. The value, the score is from original 32 to 57 after the fine tuning. And it is amazing that we use code Llama for the as the foundation model. And the score is from 48 to 75. So we have the very good experience on the when we use the code Llama as a foundation model after our fine tuning. So here is the score of the version 2 vs GPT 3.5, and especially in the coding area. And I think it is very similar and very the same. The version 3 is the very similar with the GPT 4.5. And in Chinese language support, I think V3 is the score is higher than that, than GPT 4.5. And after the assessment, I think the model is very suitable for us to deploy it in our data center. But we faced two challenges, and the first one is because the model is very large. The 15 billion models inference requirement requires more than 30 GB of the window memory. So it is a card with 40 G memory card GPU can support a single card inference. So it is too large. And how to compress it? It is the first challenge for us. And the second challenge is the throughput of the large language model is only 30 tokens per second. But if we would like to let 1,000 developers to use the coder, and it will be 4,000 token per second needed. So how to improve the throughput from 20 tokens per second to 4,000 tokens per second? That is another challenge for us. So we use many algorithm and some from open source, and we developed from the first operator layer, we use the flash attention AWQ, and in the engine layer, we use KV cache and page attention technologies to optimize. And in the service, we use continuous batching to optimize the model compress and acceleration. And here is a typical optimization solution flash attention. And the original model with a PyTorch standard attention, the forward part is about more than 500 microsecond. The backward is more than 700 microsecond. And if we use flash attention to do the optimization, and the forward path will reduce to 130 microsecond, and the backward path is about 473 microsecond. So the when after we use a flash attention the performance will both the training and the inference by more than 4 times in performance. And with the end-to-end acceleration, the resource occupy reduced to 30 to 40%. And here is the effect after the model optimization. And here is the original throughput of the only 30 token per second. And after the optimization, it reaches to 1,500. And at the beginning, we need more than 100 GPU card to support the research and development. But now, after the optimization, we just need at least 2 or 3 GPU card to support the assisted programming requirements. And at last is the demonstration about the assisted programming. And this is the hungry snake. And please use Python to write a program of hungry snake. And the generation, the speed of the code generation is so quick.
Quicker than ChatGPT.
Yes.
Yeah, much quicker than ChatGPT 3.5.
So we'll paste the code.
That's it.
Paste it and run. So this is the Python game. Hungry snake. So our question is about that, why we should deploy the large language model in our own device rather than use the public, for example, public large language model, for example, such as GPT-4. So I think there are many security and compliance in every company. We don't want to expose our code to the public, so we have to develop our own large language model and deploy it in our own devices. So that is the reason. Yeah, great. Thank you. Yeah.
Good afternoon, and sorry again for the short break. I hope everybody's fine enough. And started this last part of session 3. The first speaker is Dr. Badulescu from Ericsson. She's a standardization project manager in the research area of network architecture protocols. She has also a long experience, including standardization and more recently HCL and FAG vice chair position. So should we talk about trustworthy AI, please?
Thank you very much. Do I need a microphone?
Yes.
Thank you very much. So we're changing a little bit the topic from what we've been discussing yesterday and today, and looking a little bit into the trustworthiness aspects for AI. And this because I can't think of one single operator that I know of that is willing to deploy AI-enabled systems in their networks as long as they don't understand how the decisions are made by those AI systems. As long as they're not sure that they're safe and they don't open to cybersecurity attacks. As long as they're not sure that they're safe and they're fair to their users, the data is properly protected privacy-wise. Because I don't think that anyone would like some lawsuits coming up due to data leakage. And then as well, there's also the fact that we have currently the openness aspects, the multi-vendor in the telecom networks. And then if you have multiple, if it's a network of AI-enabled systems, and there's some system degradation or service degradation at some point, who do you blame, or who's where? Not necessarily to blame it's a network, but how do you pinpoint what was the algorithm that actually took the wrong decision? So accountability, liability, all these are aspects that need to be resolved before actually AIs can be deployed on scale. So starting with that, I would like to go to outline. So I was planning basically to highlight today why trustworthiness for AI is relevant for telecom. And then crossing the lines between the two main factors or aspects in trustworthiness. One is regulation, the other one is standardization. So without both of them, I think AI would have a hard time to actually become a trusted technology. So starting with that, let's look at why trustworthy AI is important in telecom. So there's a few things actually to consider here. There's the innovation and enhancements that 6G systems are coming up with. Quality of enhancements in simplification in the quality of service processes, in the user experience, in terms of providing higher network reliability, optimized performance. Of course, new technologies and usually including AI in the system changes the way we look at security. So there's different security threat models. There's different security methodology that we have to put in place. Automation, I mean, we've been discussing about it these days quite extensively, and it's been around for a while. It's nothing new for 6G. We've been doing work for years now, 4G, 5G for sure. And a lot of the automation mechanisms that we have today are also technology independent, except when you start including AI in the processes, then of course we need to see how that plays around in closed loops and all the typical technologies we apply for automation and resource optimization. And here, autonomous network projects that we know exist in many standards bodies, IGT has them, Chin Forum, SA5 has them. So there's a lot of things going on in the space, and they would evolve also to incorporate properly AI moving forward to 6G. Now, looking at the ethical considerations, of course, there's legal obligations that come actually around handling or dealing with the AI risks. And this is, there are several aspects to it, and I'll go a bit into more details, but this is where regulation becomes important, and it's something to consider. And so quality of experience, service and user experience. So here we have a lot of enhancements in the services that come with 6G, ultra low latency, high bandwidth applications, verticals that are driving a lot of the requirements on the networks in 6G. And then there's always, higher bit rates and new services that they would like to have, and then the network has to provide them. Now, in order to reach that level of augmented capabilities to offer, to verticals. That's something that can be supported by AI. Now, the AI algorithms as well are essential, of course, when you look at the automation optimization. However, that evolved considerably. So they started initially with plain policy-based or rule-based automation, and then now evolving towards full-blown AI-enabled logic that makes use of different AI enablers, machine learning, knowledge-based, machine reasoning, just to name a few. One of the things that I would like to highlight here is also the tendency or the intention towards simplifying interactions. And when we say simplified interactions, they're not just towards the user, but they're also as part of the automation processes. So closed loop automation is between entities that would actually have to have simplified interactions, separation of concerns, and all of these, for example, assuming you would use intents and intent-based interface, and that can be used toward the user, but can also, in majority of the use cases, at least that are dealt in industry today, are between entities in the network. So, and there's quite an extensive framework already in place. TM Forum has stage 3 REST APIs, RDF-based models for intents, providing a common model and also guiding how to do the extension model. So there's a lot in the industry to actually play around with. Generative AI, the new kid on the block. So now we're talking about that, has a lot of potential. So just to name a few when it comes to telecom, there's a lot of applications, of course, beyond telecom, but also when you look at the automation, sustainability, things that are related to telecom network evolutions. For example, use generative AI to translate between a user textual input into the proper sequence of API flows. Just an example. So, but all of this in order to work, we actually need a full data infrastructure in place. And I remember yesterday, one of the presenters, I think Jose from West Scotland University, pointed out the gap on the data infrastructure. And I think that's very important because without data, we have no AI. That to be very clear. So we need, especially in telecom, where it's an open network with multiple vendors, we really need to make sure that we are capable of actually collect and expose and process all the data that can be available between different vendors. So that's in incipient, let's say, stage currently in the standards. And I think there's more work to be done before we actually can leverage it properly. And then last but not least, of course, ethical and responsible AI. So energy efficiencies, for example, is one example of the societal well-being impacts of AI. So of course, something to look at when you consider how to use AI in the network. But also fairness, just to make sure that the way AI processes or has its logic, it's fair to a wider group of stakeholders, and it doesn't discriminate between any of them. So now, looking at the network reliability and performance. So that's, of course, very important. And as we go towards HG, higher reliability is expected. That with that increases also complexity in the network. So there's also, besides the increased complexity, there's a zero-touch automation targets. Just to maybe be clear, when we say zero touch, we don't really mean humans are nowhere in the loop. Humans are there to input requirements and to read the reports, but everything else is actually an autonomous network, as we saw. And I think there's different autonomous network levels defined in the industry, unfortunately, and then there's not just one. SA5 has them, TM Forum has them, ITUG has them. But I think we all converge on the idea that at level 5, that's the top goal to achieve. So if we want to leverage AI in, again, the openness and the multi-vendor comes in, interoperability requirements. So of course, there's the aspect of explainability and accountability that needs to be there. There's a lot of industry initiatives currently. It's true that a lot of them are studies, not so much normative work about the network for AI and AI for network. So both are important, and they're giving a holistic view of how this could be applied in CG. among that, we have a work, for example, explaining what AI native is, what cross-domain AI is, and how to actually realize it in a network that puts together AI-enabled systems from run, from packet for transport, cloud. So a full ecosystem. So of course, all of these can be applied to many things, and some examples are there: optimization of performance, predictive maintenance, reliable delivery. Nothing is new. You've seen that before, but that just shows the use cases and the applicability, the higher applicability of multi-vendor AI-enabled systems. Security and threat detection. Now that's a very important one. Of course, there's new technology, so new security models, the cyber attacks, the network intrusions. We have interconnected AI systems, and right away, I think the question that comes up is how do you detect malicious AI? So if there's one AI system that is doing something that would disturb the network, how do you find it? How do you trace back what it's done? And how do you quarantine it? How can you fix it? Gen AI now, of course, comes with all of its challenges, right? We all heard about the deepfakes, the copyright issues, just to name a few, licensing. So how do we apply that in a right manner? Out of the security for AI, for example, now there's many aspects around mostly data privacy, model protection, so model encryption, obfuscation, anonymization of the data, methodologies that are being applied like differential privacy on the data, and that's applied by Google, Apple, Microsoft at large already. Secure aggregation. So how do we aggregate the data in a way that you cannot actually trace back the original user from which the data was collected. And in general, protection against adversarial attacks. I don't think anyone would like, for example, when we talk about Gen AI, to open up their network to cyber security attacks and make it easy for anyone to become a hacker, because it really facilitates that. So, sorry. Automation resource optimization. I think we've been discussing that to quite a large extent. And of course, at the same time, the automation gets more complex with the cloud nativeness in the game. So it's the aspect of doing the automation of the network, pulling in also some of the cloud resource optimization and planning, and having like an overall view in the network, and also dealing with solutions that are de facto on the market. For example, the AI as a service offerings from the hyperscalers. So how do we actually take all of this into consideration and try to apply it into telecom in a way that allows us to do optimization automation cohesively? There's a lot of work already that is being done in the industry, and I think you have heard already IGUT work. There's SCZSM. There's a lot of automation done in 3GPP SA5, for example, closed loop automation, machine learning, mostly machine learning, and I think this is something that I notice in the industry. There's always called AML, but they only focus on the ML part. There's not much more in the AI. Then network digital twins, they start getting attention into standards. So SA5 is looking at them, ZSM is looking at it. In Oran, there's a research stream that's focused on AI, and they've been looking at also digital twins. So there's a lot of TM4, not to mention, has quite a bit. So there's a lot of activity in the industry looking at all of these. So with that now, of course, it begs the question of the ethical implications of having a responsible AI logic, and then making sure that the network resilience is not impacted, and as well as we have the liability aspects and explainability handled. Ethical consideration, regulator compliance. Now that's a very interesting one. And that's mostly because existing regulation doesn't seem to cover property. The technology went rather fast and evolved quite a bit. Regulation is not actually up to par. So there's situation like copyright, intellectual property, licensing that would need to be solved. Now, in telecom, compared to the other technology fields, you don't seem to have a lot of unfairness or, equal, handling from the, when it comes to the humans. And that's because it's just a telecom network. It's just subscribers that be at the end of the receiving service, and they would not see actually how the networks operated. But one exception still, I think it would be, let's say, generative AI, where we need to make sure that it doesn't really, again, open up or make it very easy to everyone, it doesn't open up to cybersecurity attacks. And then, of course, the implementation of generative AI, again, we need to be careful with the bias, to avoid the bias, respect the data privacy, and that's a big thing. Nobody wants data leaks. And then ensure adherence to some ethical guidelines and laws. And that's important also for interoperability. Regulatory aspects, if we look into that a little bit. So why is that important? It's because we answer to both regulators and operators. Now, when we talk about regulatory aspects, the intention, at least from the governments, is that for the consumers and for developers and for the users, it's important that they trust the AI. So having confidence that it does what it's supposed to do, and it's fair and it's robust and it doesn't do any harm to humans in general. Now, there's a lot of regulations that have been done. Problem is that they're not all aligned. So there's the European Union AI Act. Now, that's the most comprehensive one that we've seen so far. And it's risk-based, where it actually classifies the AI based on the risk, and then also has provisions as to what are the obligations, how to handle, what you need to do if you have AI systems that are qualified as being high risk. You're obliged to have transparency to provide information on data sets and the benchmarking, tell how much computing power they take, and so forth. So, whereas if you have a lower risk AI system, then the obligations are much lower as expected. Now, the thing with the AI Act is also that it looks or it focuses on what they call foundation models and high impact foundation models. And then, of course, general purpose AI. So based on all these three categories, they have different ways to handle things. US has an executive order as well, but they took a bit of a different approach. So they do provide requirements, and they direct the federal agencies so that they would actually do the provisions, the regulations and practices to be used for AI. So they focus on safety, cybersecurity, preventing misuse of AI, risks of data privacy, and so forth. But in the end, they have very few technical provisions, so they leave it all to the agencies to do it. However, what they consider, while it's in effect now, it's already approved. What they do, they mandate and they apply directly to the companies that are considered to have very large foundation models. And that's usually tied up to very large computing clusters. So it's very narrowed down applicability, unfortunately. Now there's Canada Artificial Intelligence and Data Act, and they aligned a little bit with the European Union in the sense that they do follow a risk-based approach. But they also took a little bit from the US in the sense that they don't specify themselves the regulations directly either, but rather, tell agencies this is what you should be doing. There's UK, and UK took a completely different approach. They are much more lightweight and more let's wait and see. With the ambition to actually allow more innovation and less kind of constraints or regulations. They do have the ambition to have a leading role in AI. So maybe this is also one of the reasons. There's China AI regulation that's been going on for a while. It's in the works, and I think they're one of the ones that are very fast reacting to the new technologies. So ChatGPT, for example, they took it in right away, took European Union. I think they reacted to it after a year and a half when they started the AI Act drafts. So, but they do take a different approach. They come up with a negative list in the sense that these are the AIs that we recommend the companies to not incorporate. So as you can see, they're very different, and that is a bit of a problem in the sense that when you have to do a standard, when you have to implement, if you have different regulations that you have to follow, it's a bit of a problem, and that is costly as well. So for example, if you have an AI model that is considered high risk in Europe, but it's low risk in China, I mean, you have different obligations, you have to handle it differently. So it's globalization for the regulation that would be awesome. But in general, the other thing or considerations I would like to highlight is the fact that it would be great if they focus on regulating the AI risks themselves, the misuse of the AI technology, but not the actual technology, because that would kind of, prevent, advancements and innovation and AI evolving as it should. And also to try to have a neutral registration legislation in a sense that it would stay future-proof, so that we can actually work on the technology while controlling the impacts. So yeah, I think that was kind of the message I wanted to relay here. So this is just to give you an example of the risk-based approach to AI Act. So the range of the risk assessment evaluation in the models that they give. So it comes from high to low. And this is just an example for you to see what it means in terms of, you have a high risk AI system classified as such. So what do you need to do? So you have to do risk and quality management, logging obligation, data governance, human oversight, and all of that. Whereas if it's a lower risk, you have some transparency requirements, and then, and that's basically. So in general, it's considered to be AI in critical infrastructure and digital infrastructure, and that's considered a high risk. So there's a bit of limitation in the way this is applied as well. There's, of course, if we would have a global alignment and we would have the same classification and the same obligations across the world, that would be the ideal situation. So if we move on to the standardization part. Yeah. So multi-vendor landscape, I'm going to go a little bit faster to some of the slides. Already there's a lot of initiatives, 3GPP, IGG, ORAN. We saw the open source LFAI and data, which has a ton of projects in many areas. Etsy, which comes up with their own TM4 AI Run Alliance. I didn't mention telecom infra project with the telco. With telco AI that just came up, but again, the same thing. In order to have an alignment or international standards, we also need to be based on aligned or global regulation. Go faster. So I think the other important things to consider is while having trustworthiness aspects, and that includes all of the ones that I mentioned about before, the safe, robust, and explainable AI is, when we talk about standardization, we only focus on certain things, or we should be focusing on certain things. So of course the designer benefits from that because it likes to debug and have more information, or the user, but in the end it's the operator and regulator that actually impose requirements that translate into something in standardization. So for example, the causality, the responsibility, the safety, the impacts on the society, and all of that. These are factors that are for which the regulator operator would be the main persona to benefit. So if we look at international standards, what is it that we would need global alignment, and ideally we would have that on the ethical and responsible AI, and to provide transparency, accountability, fairness, privacy, everything that comes with it. Data governance and privacy, very important, and that's because we need to make sure we protect the data that's used to train the AI. We need to know how it's collected, how it's stored, how it's processed, and that is in a privacy preserving manner at all times. Sorry. We'll go back. How do I get back? Yeah, okay, sorry. Sorry about that. Yeah, so in terms of then explainability, of course, that's important, especially in frameworks that would have a generic way to express accountability, liability, to clarify the responsibilities of the different stakeholders. And then make sure that they're not open up to potential harm or unintended consequences. Interoperability, accountability, and liability. Of course, here it's important that we have seamless integration, so all is interoperable in terms of interfaces, protocols, interoperability. And I'm not going to go into more details, but I think we need also following as to I think my previous speaker from Red had mentioned, we need to be careful to not over-standardize things and kill innovation that way. The other aspect is security resilience. So we know it's critical to protect against cybersecurity threats and make sure that the system remains robust. Regulatory compliance, we do need that, and we all need to abide to them. That's basically that. So now standardization versus fostering AI innovation, I think that was important. I wanted to get here. First of all, global alignment of the technology, that's important. But we do need to focus on enabling the mechanism and make sure we have requirements on explainability, basically to give an idea to the operators or the regulator how the models are used and how decisions are taken. But not specified actual machine learning models and algorithms, not going to that level of detail where we standardize some models, or this is not useful for interoperability, but on top of that, it's problematic because it can create stagnation of the algorithm development and stifle innovation that way. Then evolution towards a native architecture, that's an active research topic still. It's not very mature, even if we've been talking about it, it's still not there. Problem is that if we jump and we do things too early, then we're going to have to redo them. So some people, getting started with this, they'll end up with non-backward compatible implementations that we have to completely reinvest to redo. So just a few words of caution. And I would just get now to the takeaways. And here, I think, as I was saying, it's important that both regulation and standardization are addressed for trustworthiness. There's a few areas in the telecom and I'm listing them there where AI is relevant and trustworthiness for AI is relevant. And then also to make sure that we do have some kind of frameworks where we have a standard way to express accountability, explainability, and liability. And that would be very helpful for the interoperability. And global regional alignment, ideally, if that's possible. There's some national regulators, and NIST is doing their share. Let's say they have an AI risk management framework. But I think if we look at it at the global level, like EU, US, China, and like bigger regional regulators, it would be ideal if they can get together and agree at least on the same terms, the same risk definition, and the same set of obligations for the risks classifications that they identify. And that's it.
Thank you very much. It was quite inspiring from the point of view of what you have to do, standardization, and what is pertaining to other domains. I see many questions. Half an hour.
Okay.
Yeah. Paul is the first, he deserves the question. And 3 questions, but please be quick because we will eat the break.
Thank you so much. It's a super simple question. It's a very naive question. Based on the description of how the regulation is going, what is the difference between AI and a software application that may or may not contain AI, because that also has risks and things. So what's the uniqueness of AI in this space?
I think the focus is mostly, it's not working.
You have to, the bottom again. You have to activate the button. Now it should work.
So I think the main focus of the regulations is on AI developers, AI users, AI deployers. So it's not any software. I mean, of course, there's a distinction by the fact that there are certain AI technologies that are specifically kind of targeted. Let's say the AI models and the classification of the race. These are AI. It cannot be just any software. It's true that, you know, that begs the question. I mean, for any software, you should have all of that, right? That's where you're getting it. And probably they do. I just don't know enough in general about the regulation in software that's not AI.
Thank you.
Totally fits.
Okay, so I have one particular question as the rapporteur of question 16 over study group 13 in IQT. So this question is in charge of trustworthy networking and services. So currently we have very good stage to consider that the study period, the coming 4 years. So whenever we consider this kind of a trustworthy aspect, particularly in the context of networking, no one think we do not need to standardize trustworthy AI. So AI technologies is not the scope of the standardization, but how we properly use our trustworthy AI is really essential component. In this context, we are thinking about the type of question like trusted or trustworthy networks instead of mentioning trustworthy AI or trusted data, etc. So in the context of the trustworthy network infrastructure, I believe you have already well identified so many important elements. The my question is related to the security aspect. Particularly 6G context, if we want to consider trustworthiness aspect in the networking domain, who really need to take the responsibility for developing larger technical solutions? I mean, security guys or traditional networking guys. These are very important critical points. So what's your opinion?
I would think that they need to work together. Because they need to understand the specifics of the AI technologies that they are trying to develop a security mechanism for. They cannot be done in separation. And as 6G evolves and we know more precisely as to where AI is being incorporated and used as part of the system, then we also understand how we need to adapt the security methodology, the threat model that we're using to match those. So I would think it's a joint effort.
Please.
Yeah, thanks for the presentation. So on the slide where you had the different personas,
Yes.
there was the requirement subject to standardization, right? And it wasn't clear to me what was being referred to on that picture.
So what I was trying to kind of point out is that there's many beneficiaries in the network from the trustworthiness, the different aspects of it. Now, the ones that we actually need to focus on the standard side and receive requirements from when we standardize things is the operators and regulators. Then, I mean, for obvious reasons, one for interoperability, accountability, liability for the different vendors that they have in the network, also to make sure that their users have a fair treatment, and then sustainability society.
Receive requirements from them as a vendor?
Or the standards.
Or
No,
standards.
in the standards. So from
Okay.
standardization perspective, I don't think we want to regards from designers because they want to debug things. So we don't care. It's mostly, it's not that we don't care, but we don't need to standardize it. We do care. Strike that. But when we look at standards, we need to understand what the operators need, what are
Yeah.
and what regulators need, because it's like a vicious triangle. Operators need to respect the regulations. We need to respect the regulation in order to make our
Okay.
customers happy to do so.
But it doesn't mean, it still means that these requirements that are gonna come will probably be requirements on everybody in that image.
Yeah.
Maybe depending on what the.
For
operator
sure,
wants,
yeah,
right?
they might be actually split out when we actually look at how, what's the details of how to apply those, but primarily what I wanted to highlight is that, yeah, there's many benefits to trustworthiness, and that's not just what we see in standards. It's also in the network, but in standards, we should leave it to, what is it that we really need to focus on in terms of interoperability.
One mini last question is on the pyramid of risk. Is it settled where telecom networks are?
No, I don't think it's settled. That's a good question. That's something we would need to look at. But if you take, and now it depends on who you ask. So is it by the European regulation or is it by the US regulation? But in general, I mean, let's say US regulation, they are focusing on infrastructure. So if it has massive critical computation impact on infrastructure, that's a high risk for them. So something that needs to be right away has a set of obligations, things that they would like to see. European Union, as far as I know, they're a bit wider, but they're also focusing a lot on technologies that have immediate impact on the human. Now, telecom doesn't have as much impact on the human, if we think of it. It's a service and you provide a service. How you provide it, what you do in a network to provide it's not really affecting them as much as the other, like medicine or, HR hiring system, or things like that.
Thank you.
Okay, thank you very much. I think there is a lot of questions. Gas and secondary standardization will play a role. Professor Chiwang, so he's the next speaker. He's a full professor in energy relations, bioenergetics and services, University of West Scotland, and on the board member of the EU has been on 5G PPP. A lot of papers on 5G, more than 200 best paper. I know him from participation at UT Study Group 13, 182 and 3183 about slicing manager orchestration. Pleased to see him here. Thanks for your presentation in advance, and you will talk about the network slicing or more general network management and optimization control for 5G and 6G. Is there? You said that you gave. Because I asked you if it was there.
Thanks very much, Marco. It has been a pleasure to be collaborating with you and all the other colleagues. And it's a real pleasure to be here today. Well, Jiayin is trying to find my latest version. Just trying to start briefing everybody about the outline of the talk today. The topic is basically AI for 5G and 6G network management and control optimization. So this has been the focus of our group over the last few years. And in today's talk, I'm going to cover, first of all, the classical AI pipeline for data-driven approach with a target to achieve optimized network management and control. So there will be several stages involved in this pipeline. Especially the data creation part, which is usually the major and the first barrier for many projects. We have been in a number of projects recently, especially for EU 5G PPP projects, for 6G IA projects. All of them are concerned with how we leverage AI, machine learning to improve the performance of the networks in the future. And in the second part, I'm going to try to outline some of the recent EU projects we have been involved with and trying to identify some areas, directions for future standardization.
You don't need slides.
Yes, of course. If it's so difficult to
The last one.
is a previous version, I think it will do.
Nobody's down. I mean,
Already done.
so I was thinking it was up.
No, this one, too.
Thank you. I'll go to screen up here.
Right, forward USB. See the difference in the car page? So, I've been trying to leverage the efforts from Jiaying. She has done excellent work. Okay, so you have already seen the outline. The first slide I'm going to present is the background in terms of the autonomous control loops. So we have, with the help of the colleagues, especially Marco, Olivia, Leon, Vishnu, Thomas, etc., with the ITU groups, the focus groups for, machine learning for 5G and also autonomous networking focus groups. We have managed to standardize our work from, a few EU projects, SliceNet, SelfNet, and Cdifference. Okay. The result are two ITU recommendations highlighted in this slide. So essentially, we have standardized this closed loop for different use cases. Could be for smart cities, smart e-health applications, smart grid, etc. Okay. So this is following a pipeline of monitoring, analysis, then decision making, then orchestration to enforce the different policies or rules to the data plane of the network. Okay. What you're seeing here are some examples of sensors in the data plane and also actuators. Okay. So we are coming to the end of the loop. The challenges I want to highlight for today's talk are the following. Hopefully we have sufficient time. I know we are running a bit of behind the schedule. Okay. The first one is the data set creation. Christina already highlighted this as well in her talk. This is a major obstacle for all the data scientists facing the different real-world problems. So we really need to have some high-quality data set to enable us to actually achieve the data-driven approach. Okay, so this is the precondition we are facing. Especially sometimes we are facing challenges in imbalanced data. Okay, so we have more data for different category, but a few for other categories. So we need to achieve a good balance among the different categories of the data set so that we can train the model in a fair way. The second one is the features. So there are usually numerous features available from the monitoring system because we are deploying numerous sensors for different purposes. So there's always a challenge. What are the most important metrics we should use? What are the most relevant features we should apply to particular machine learning use cases? Okay. So this has been, I think, to a large extent, covered by yesterday's discussions, for example, using different clustering technologies to filter out, the less important ones, focus only on the real impactful ones. For example, choose the 6 out of the 100, for the competition demo presented yesterday. Okay? So I'm going to be quick for that part. The next one is the dataset extraction, visualization, and labeling. So we have developed some tools. So I'm going to show you quickly these tools. Okay? And finally, to follow the logic presented by Leon in the morning, to create, to validate, to apply, right? So the final step here is to actually how we leverage the facilities in a lab, for university to do some preliminary validation, testing, application. This is the proposed overall architecture. So you can see on the top, we have actually an intent-based networking approach. So this is, again, compatible with the architecture produced by the autonomous networking group. So I hope, for example, Marco, Liang, etc., can see some potential to further deploy, this architecture as maybe an instantiation recommendation to follow up the architecture presented in the morning. Okay. So for this intent-based, first we have an intent profiling. So basically,
the end user, for example, administrator of a network, need to define your use case, your intent, right? For example, to create a network slice with a gig bandwidth, to create a EMBB slice, or to create a URLLC, ultra low latency, ultra reliability slice, okay? Or to apply a particular application for security, as Jose presented yesterday. Okay, so there are different use cases, and the use cases we will actually define the intent. It's a high-level expression of my use case. Okay, and then it's down to this intent-based network to translate the intent into policies. Okay, and then the orchestration part will actually find the resources to enforce policies, and then it's down to their controllers. Also, I think Paul highlighted the controllers in the morning's talk. So we'll have a group of controllers to actually allow the controller to further map the policies into implementable rules. And then the rules will be actually enforced by the selected technologies of controllers. So this is the idea of the top part. Of course, to the left, this is the added value from this talk. If you compare this architecture with the standardized architecture, okay? So it's the data creation, the data extraction, labeling, and then to generate the labeled data for the training of AI models. Okay? And the downside, the bottom side of the figure shows an example infrastructure from 5G. But we hope the concept will be applicable to 6G networks, if 6G network is still an infrastructure-based architecture. Okay? So first, data collection. So we have been running different applications of flows over our data plan in the lab. Okay. So as you can see, what we have done is to have already designed and prototyped a set of enablers. You can see in the service layer, in the compute layer, we have the different agents. Okay. So currently they are automation based. Okay, there's always a potential they could be converted into AI-based ones in a later stage. But we have been focusing on autonomous network. For example, the cognitive policy manager, this will help to achieve the policy, the mapping from the intent to implementable plans of policies and rules. Okay. And then we have the resource inventory agent. Okay, to basically store, monitor, all the instances of the resources. So currently, we are focusing on the topologies. I'm going to show you the next slide. You will see a very complicated topology. Okay. And we also have a service monitoring agent, a resource monitoring agent, so we can monitor resources and services at different levels. The output will be a database containing all the collected, the metrics, features, etc. So this is an example of the topology. Okay, imagine this. This is not the whole internet or even a local area network. They're just from a couple of pieces. So there are two physical machines in our lab. One represents the edge of the network. The other represents the core network. You can see how many virtual machines, containers, Linux containers, Dockers are inside. Okay, to represent the different network functions required to operate the edge and the core network. And also the different interfaces from the different levels, physical layer and also the virtualized layer, the SDN controllers, the ports, you can run from L1 to L5, all the different, controllable points in the network, which can allow us to first to see them, and then we can apply policies to enforce, our machine learning driven enforcement of particular configuration, particular optimization of network functions to address the different challenges in the network. This step is optional because it's synthetic data. So if you have managed to create a really good, high quality, balanced data set in the previous step, you can skip this one, right? Unfortunately, for many of the use cases we have tried, we usually encounter this problem. It's not sufficient for particular categories in a data set. Okay? So that we have proposed this architecture. So you can see there's a model training part. So in this part, we are leveraging some of the generative AI as many other colleagues have explained, okay, to create synthetic data, learning from the real data. You see, the real data is the input, okay, and then the machine learning stuff will actually learn the patterns, the metadata of the real data, and then create the synthetic ones. And then in the conditional sampling building block in that module, we'll actually check if it's still imbalanced. If it's still imbalanced, we try to create more data for that category. Okay, so there's a loop. And then the identification of the network features, as I said, in this largely covered by this talk, so I won't go into further details, but you can see in the figure the different layers of the network. But it's so complicated from 4G to 5G, and then we are moving from 5G to 6G, considering the different technologies, virtualization, the SDN, the software-defined networking, the cloud, the data center in the core network, the edge, the computing, and then the fog, for example, the IoT, etc. All of them are adding complexity. Okay. And for the controller side, you can see we have a short list here. So we are considering 3 controllers in this prototype. Okay. IP tables, TC from Linux, and also the OVS, Open Virtual Switch. So they are the target controllers we try to use for different network management and especially the control optimization tasks. Which one is the best for a given use case, or even during a use case for each of the different steps, for example, which one should be applied for particular control points along the end-to-end network. Okay. So it's a big ask from us. These are some examples of the features. So again, I'm not going to explain them one by one, but you can see they are divided into different categories already. The green ones from device, yellow ones from different interfaces, blue ones are the technologies of the controllers, and the red ones and the green ones are not orange. Ones are for the policies. Okay, they are over 100 already. Okay. And then combined with some of the domain-specific knowledge we have from our group and some clustering technologies, we have an example here, the different use cases you could have. So these are correlated to the intent we have. Okay, for example, I want to do something about the traffic engineering. Okay, to redirect traffic, to drop traffic, or to mirror traffic, or to optimize the traffic through load balancing, or to configure flow to be prioritized for slice. So these are the examples. Okay, to guarantee the QoS, guarantee the quality of experience for users, to achieve optimal resource allocation, etc. So you can see the relevant features are listed there. For example, for the traffic engineering, we have defined, in the previous slide, the features for number 4 to number 49 are the most relevant ones. Okay. Of course, these are the preliminary studies. Data extraction, we again define the architecture. So you can see a lot of architecture and framework in my presentation, because the intention is to identify potential areas for standardization. Because from an empirical point of view, we have encountered all the different difficulties as an academic. So we can see, we really need some tools and guidelines, recommendations to guide us for the different pieces. Okay, for example, in this architecture, we have defined this extraction engine to connect to the database, which stores all the features, the data set, the balanced ones, to actually derive the data set. Okay. And at the end, we have the unlabeled data set. So this lead to the next step. So we need to do the data labeling. The data set is in the format, it's human readable, but it's very difficult to understand each of the components, the columns, right? Some tabular representation. And the file is in a CSV format. Okay? So to allow an expert to actually do the labeling, so we have developed this GUI. So it's instance by instance, we can launch the different instances, and then the different parts in this GUI can show you the details of the instance, and then we can do the labeling, which should be the best the technology in terms of controllers for this particular instance. And then the test bed for empirical evaluation. So we used a few PCs in our lab. We are a university, not a big industry. And then we tested the ideas. Okay, So what we have done is we use the synthetic data we generated together with the part of the real data, train the machine learning models. Okay, so the model will understand to predict which should be the best controller to be applied for particular use case. Okay? And then we have done the testing using the remaining of the real data. So we're not testing using the synthetic data. We'll talk in the morning, give the warning how best we leverage the synthetic data. And then we have done some empirical experiments running the different flows over our infrastructure. And then we have tested 4 different machine learning models. Of course, this is extensible. So you can apply more, you can plug in more machine learning models to actually validate and test our approach. Okay. So given the initial results, as you can see, it shows very promising results. So across all the different scenarios, we can achieve over 80% of the prediction accuracy. This is my first part. I promise the second part is much faster. Okay, the different EU projects, therefore, first is CG Brains. We are focusing on edge and the core network. So this one is focusing actually on the RAN. So you can see this is trying to leverage the capabilities from reinforcement learning, especially multi-agent approach in this CG project funded by the EU. Okay? So in this architecture, you can see we have infrastructure in the bottom part. We have a management or transition to the right part, and we have the rest are their components needed. We think they're needed for reinforcement learning, okay, including the training phase, okay, and generating the simulated emulated traffic for testing for validation, okay, and also all the let's see the classical components from reinforcement learning, like the observability, based on the monitoring, and also the reward function definition, and what are the actions to be applied. Okay. Second project is called the CGPass. It just started this year, so it's ongoing. I'm showing some project website links. Okay. So the basic idea here is how we leverage AI to support vertical businesses, different use cases, especially focusing on AI as a service approach. So we can on demand plug in any AI models pre-trained by others to help different use cases. So it's not develop once and then use only once. Develop once and use many times. Third project is called 5G Induce. It's going to be finished. So we have already actually included this as one of the use cases in the supplement ITU standard presented in the morning. Okay. So here you can see there's actually a use case. We call it a network application to deploy the different components from a use case and distribute it into different segments in the network. Okay. And then we plug in the AI into the edge of the network. In this case, it's a corrosion detection AI model to allow the drone fly, over infrastructure of, for example, electrical power grid, actually detect any problems in the infrastructure. For example, any corrosion on the surfaces of the pipes. The last one is called Encode. So again, it's another platform we are trying to achieve. It's more concerned with the continuation of the cloud resources from IoT, which is the fog, if you like, to the edge, and to the transport to the data center in the core network. How we leverage the resources available as a pool and reassemble the resources on demand to support the different use cases. So again, the AI can be plugged into different segments. Okay. This is the final slide. So I try to summarize and point out some potential standardization opportunities. Okay. So the overall reference pipeline architecture has been presented, cover the different stages of this data AI-driven approach. Hopefully, it will be helpful for CT, although our experiences so far have been focused on 5G and beyond. And the different frameworks, guidelines presented for the different phases of this pipeline, especially the data collection, including imbalanced data set handling. Okay? Plus, the other steps, extraction, rebuilding, etc. And finally, the different projects, most of them are still ongoing, so we hope try to further identify areas for standardization opportunities. That's all for me. Thank you very much.
And he talked about the possible standardization, also extending the architecture framework, so you are welcome. Anyway, any comment? Yes, please.
Thank you, Professor Wang. And I have a question about the data labeler, labeler. So, as you know, in our wireless network, the data, how to give the data label is a very difficult problem. You know, everything is uncertain, and the throughput is uncertain, and the ISRP is uncertain. So how do you give the data label? And you have a letter labeler, right? Is it need human to involve in?
Yes.
And even human don't know the accuracy data label.
Of course not.
No one knows that.
We appreciate this insightful question. It's a big challenge for all of us, especially for the radio access network. That's why I'm trying hard to avoid that part, because it's really tricky. And also I want to focus on the general approach applicable to different networks, 5G and 6G. There's no, to my knowledge, no established solution to resolve this problem. Okay? Our net labeler as a tool can help the expert to visualize the different elements associated with different instances, to allow you to actually see what's going on in that instance in terms of resources, in terms of topologies, in terms of how the resources are distributed, across different versions. And then based on your expert view, you give the ground truth labeling. Okay, so this will not resolve your problem of lacking of knowledge, especially for the radio access network. Actually give the ground truth label.
Okay, got it. Thank you.
Thank you. Any other question for the break? Tony, please.
It's more a comment than a question. What I want to highlight, let's say, typical pain point that we usually deal with when treating data. So what I can say is that every data set is actually very different in terms of labeling. I mean, our data set are already labeled, but the label are always different. And I mean, it's very painful to when you wanna automatize all the process. You need to check everything. I mean, you need to identify what label is and use the same information that you have used in the past and so on.
I can't agree more.
It's also
and must go down for the kind of challenges, and also the maybe sleepless nights of part of the teams trying to distribute the developing work across different team members, try to achieve a high quality data set.
And another thing which is quite let's say painful is actually the KPI. No, you also mentioned different. I mean, different operators maybe have different targets. This is obvious, but they maybe even the same target, like you say, energy efficiency, for instance. I mean, you can measure it in.
Yeah.
There are so many different metrics that actually are used or could be used to optimize the same thing, and this is also very challenging.
Exactly. Thanks very much for your comment.
Thank you. Thank you. Antonio. So we close. Thanks, Professor. Okay, colleagues, we started this session 4 before the panel. We had 3 speakers and we had 75 minutes. Now we are 5 minutes late. Hopefully it's fine. And the first speaker, so this session is about green AI, sustainability, AI, CG. The first speaker is Dr. Piovesan from senior research in Huawei Paris. And he has worked after his PhD as assistant researcher at the Catalan Telecommunication Technology Center. Also had a fellowship from the European Commission. He worked in European MSCA scavenge project. And now we focus on large scale network model optimization, grid, and machine learning for wireless. You will talk about the specific data-driven model optimization of grid of wire networks. Nicola,
I need the mic.
you need the mic.
Okay. So hi everyone. I'm happy to be here, part of this workshop this year. And today I want to try to answer one question. And the one question is if we can use machine learning, AI, data-driven approaches to the big data idea to make our networks greener. And the reason why I want to look into this is because today around 3% of the energy that is generated in the world is used by the ICT industry. And at the same time, the ICT industry is responsible for around 3% of the total carbon emissions in the world. We had some forecasts, pessimistic one, I would say, that tell us that by 2040, if nothing is done to address this issue, this number is going to grow till 14%, which is a huge amount of carbon. Well, this is not only a problem in terms of carbon emissions or in terms of power consumption, it is also a problem in terms of monetary cost. Because some people is paying for that electricity and that people is mobile network operators. This is a nice figure that I took from GSMA. GSMA computed an average over 65 different networks. And what we see is that for the average operator, 25% of the OPEX are spent on network costs. And what is interesting is that 23 out of these 25, so basically more than 90% of the network cost is spent into electricity. So I guess we have some operators here. I don't know how much they spend in electricity, but I checked numbers from Vodafone last year. Vodafone spent $1.3 billion in electricity bills in 2023, which is a huge amount of money. And if we look at where specifically in the network is energy consumed, we find something interesting. Most of the energy is spent in a very well-defined part of the network, which is the radio access network, that accounts for 76% of the overall consumption. And if we dig even more into the details, the radio is the most energy-consuming component of these base stations. And we also know that networks are evolving. Yesterday, there were at least a couple of presentations with these nice figures, 1G, 2G, 3G, 4G, 5G. And a great characteristic of 5G is that it's the most energy efficient technology version of the radio network. And this is true. Some people may think that in some way the problem is going to solve by itself as we deploy more and more 5G networks. But it's also true that 5G consumes more energy. So here I took this table from a paper in which basically they compare 4G site and 5G site. And it's clearly faster. 5G is faster because it operates over larger bandwidth, and also because we all know it's massive MIMO, large number of antennas, 16 times faster. But at the same time, more bandwidth means more power, and also more hardware means more consumptions. So we have a 4 times increase in power consumption. So 16 by 4 divided by 4, you have a 4 times improvement in energy efficiency, but still you have a 4 times more energy that you need to use. And the good news is that 5G was thought since the beginning with the idea of energy efficiency. The first releases were mainly focusing on the user side, but the latest releases are starting from 5G Advanced that focus on the network energy savings. And we can use different techniques to save energy in 5G. We can act on the time domain, switching off components when of the base station when the base station is not transmitting data or transmitting functional signals. We can act on the spatial domain. We have many antennas. When the traffic is low, we don't really need all these antennas active. We can operate the network with less antennas and save energy. And we can also operate on the frequency domain. Usually in the real network deployment, you have a coverage layer with the lower frequencies that are there to provide coverage to the users. And then you have an upper layer, in this example, 1.8 gigahertz, that is there to provide the high throughput, the capacity. Well, when the traffic is low, we can switch off the higher frequencies and save energy. And then we can also act on the power domain. We can reduce the transmit power to save energy. Well, here in this presentation, I will take as an example the one of frequency domain. So carrier shutdown, basically we switch off carriers. And because it's the one that provides the larger savings among the others. And also because this method is quite intricate, the activation is autonomous, but it depends on many conditions that needs to be verified. In particular, condition on the traffic load. There are thresholds that tell us, okay, if the traffic in downlink is below a certain level, if in uplink is below a certain level, if the number of users is below a certain number, then this carrier can be shut down. Well, as you can expect, if you want to optimize all these parameters, we need to have a good understanding of what's going on in the network. And in particular, we need to understand how these thresholds, these parameters, affect the energy efficiency of the network. Also, we need to understand how the traffic load affects the activation and the deactivation of this mechanism. Not only this, we also need to understand how the user moves. So I switch off a carrier, the user of that carrier will need to be served by a neighboring carrier. So there is a sort of redistribution that happens that impacts the other base stations. And also, real networks are quite complex. There are multiple different types of base stations, different architectures, but also different products that can be configured really in thousands of different ways. And the different products, the different configuration brings different power consumption behaviors. So we need to model all of these effects. And we can use different approaches to solve this problem. We can look into drive test, but as yesterday Antonio was saying, for example, when showing the demo for the NERV, this is very expensive. It already costs $1 billion to do drive test for operators and vendors. And of course, this is not a suitable approach. We want something more dynamic, able to really learn from the data that we already have from the networks. And also, we can use system level simulators, but here they mostly rely on statistical models. We will need to adapt them to the specific radio propagation environments. And of course, these approaches are mostly based on looking at capacity or coverage. They are not really looking at the energy efficiency, because to understand the energy efficiency, we need to understand the energy consumption, right? And here I want to open a small parenthesis, because energy efficiency is a single word, but may have different meanings. And in fact, if we look at a representation of the radio access network and we look at the definition that we have for energy efficiency, what we see is that there are many. For different parts, we can have the energy efficiency for the network as defined by ETSI, the one for the site as defined by ITU, for the base station, again from ETSI. Some of them are scalar values, like the energy efficiency for the site. Others are in bit per joule, or bit per watt hour, as the one from ETSI for the base station. And all of them, I would say, suffer of a problem. And I guess people that try to optimize network using energy efficiency metric may have faced these issues. And the issue is that they can give easily misleading optimization suggestions. And here I decided to plot the energy efficiency measured in gigabyte per kilowatt hour for different sites in the network. And I plotted with respect to the data volume that was serviced by those sites. And you see that something interesting happened. Basically, the sites with a larger data volume, so they're the one that are transmitting more data, appears as the most energy efficient one. And the question is, are they really the most energy efficient ones? So to see this, I took two sites, site A and site B, and I want to switch one of them off to save energy and move all the users to the other side. If I ask any of you which side to switch off, I'm pretty sure that most of you will tell me to switch off site A, because it has an efficiency of 15 gigabyte per kilowatt hour, and to keep site B active, because it has an efficiency of around 20 gigabyte per kilowatt hour. But if I measure the energy efficiency of site A at the same level of site B, what I see is that actually it is the most energy efficient one. So the optimization suggestion was wrong. And actually, this is an effect that was observed by operators in the early days of 5G deployments, because there were few people with a 5G mobile phone, and so the networks were lowly loaded, 5%. And in their measurements, it looked like 5G was less efficient than 4G. Actually, we know it is not true. I'll show you the table right before. So how can we solve the problem? To solve this issue, we recently submitted a paper, and we used a theory that was initially developed by Professor Ted Rappaport at New York University. And this is called the waste factor waste figure. So all these theoretical framework that I will not go through, I just pointed to the paper, is based on the duality, I would say, with another popular metric, which is the noise figure that was developed by Aaron Fries in Bell Labs in the 40s. And as the noise figure allows us to measure the noise in any device or cascade of devices, the waste factor allows us to compute and find the power that is wasted in any device or cascade of devices. And we applied it to the case of the radio access network, and we show in the paper that how we can allow to solve this issue, because we can identify cases in which energy efficiency metrics as defined into the standards tell us something that is contradicted by the waste factor. And actually, a great characteristic that it has is that the waste factor is not impacted by the level of data that is transmitted by the base station. So we can take a site, measure the waste factor at any different possible transmitted amount of data, and we will always find the same value of the waste factor, which is telling us how much energy is wasted by that site when transmitting data. So in our work, we focus more on singular individual KPIs, exactly because we don't want to go into the issue of the energy efficiency metric. And in particular, what we want to do is to take a large scale network, carrier shutdown energy saving policy, so all these parameters for all the carriers in the networks, and also the mobility management policy, so all the handover parameters, basically, and a traffic profile, that is the traffic serviced by all of these base stations. And then we want to use this data to predict 4 different KPIs. So the amount of time in which the carrier will be turned off, the cell load, so the load of these carriers, the energy consumption of the network, and the downlink rate for the users. And there are some challenges that we need to face. We go briefly to them. The first is that it's a very large scale problem. We have 50,000 cells in a typical city, and we have different parameters, at least 10 to configure, which means that we have 500,000, sometimes also 1 million parameters to tune, and we cannot tune them individually, base station per base station, carrier per carrier, because as I was saying, there are these mutual effects. As we switch off one carrier, the user will move to the neighboring one, the load of that base station of that carrier will increase, so it's quite complicated. Also, in the real network, we can observe through the data a few energy saving policies, not all the possible policies. So this means that if we learn from the data, we need to learn from a few examples, from few policies, and the models that we want to develop must be able to generalize to every possible policy. And then finally, as I said, these mechanisms depends on the traffic load, which means that all the work is quite stochastic, right? The traffic fluctuating time, space is difficult to predict, so we need to use a stochastic approach. Well, this is the representation of the framework that we designed. They call it the digital twin for the network energy efficiency. It's a simplistic representation, but I think you can get all the important points. In the first part, we have the types of data that we use. Could be measurements reports data that are collected by the user and reported to the base stations. For example, information about the RSRP that allow us to characterize the propagation environment. It could be cell level KPIs, like information about number of users, number of physical resource blocks used by the base stations. Of course, the energy efficiency policy, configuration, and also the handover parameters, and some engineering parameters like frequency, the bandwidth of all these carriers. All of this information goes to a first part, a first block, which is composed of an agent-based model. Basically, every carrier is represented by an agent. The system basically try to converge to the most realistic configuration of the network, given those inputs. So I will find which base station is off and which base station is on. And of course, this block needs to interact with another important block, which is the user transfer model that tells us if I switch off given carrier, where the user are likely to go. Again, we have a probabilities here. And when we convert it to a solution, the relevant KPIs are output to be the input of two blocks. One is responsible of computing the power consumption, and one is responsible of computing the rate of the users. So the last ones are machine learning based models because they are challenging things that we want to learn from the data that we have. In the first case, we have what they call expert knowledge models because we know how endover parameters and which are the endover conditions. We know the conditions of the carrier shutdown policy, so we want to leverage those conditions by hard coding them basically in the first block. And here you have an example. For example, the power consumption model is an artificial neural network that takes multiple inputs related to the configurations of the carriers and the traffic scenario, and it outputs basically a probability distribution of the energy consumption that allow us to have both an estimate and a degree of confidence for the estimates. And of course, what we did is to take real data from a network of around 1,000 cells, and we trained all of these models in that network. Those measurements were collected in November of 2020. And then what we did is to look at different scenarios, where each scenario is a different energy saving policy. So basically what we do is training in November. Then we take the energy saving policy that is used in December, for instance. We input to our digital twin that policy, and we see how much energy is consumed and which is the user rate. And then we look at the data and we try to see if the accuracy of our digital twin framework is good. So if the estimates match with the reality. And actually, yes, the first block is able to estimate the activation time of the carriers, the high frequencies with an error of around 10 minutes. The ADM, the agent-based model, is also able to estimate the load of the cells with an error of around 6 percentage points. Then the rate model gives us an error of around 4 megabits per second. And the base station power consumption model gives an error of around 16 watt to 18 watts, depending that we are talking about a 4G or 5G base station. And of course, what is the usage of all these framework? Is a representation of the network. We have seen that the error is quite low. So what we can do is to put something on top of it, which is an optimizer. And we can ask the optimizer to output an energy saving policy. So all these parameters, alpha million parameters for this network, this policy will go through the digital twin framework, and it will output a rate for the user data rate level and the power consumption value. And this value can be reinforced through the framework by the optimizer to try to find the best energy saving policy. And then that is the policy that we want to use to configure the network. Well, what we did is to try this framework, and we tried it over an area of around 130 sites. And we had 4 different testing phases. Now, the first is the case of not using any energy saving policies. So basically, we don't use carrier shutdown. And we check how much energy is consumed by this network. And this network consumes around 2,600 kilowatt hour every day to do its work. And then in phase 2, we use the current approach. And the current approach is basically very expert engineers that have been working for like 20 years in optimizing networks. And they do the configuration of all the parameters, not only the energy saving parameters, but also they can configure the tilt, for example, of the antennas and many other things. And we ask them to configure these parameters for the carrier shutdown. So this is our baseline. Is how things are done basically today. And they were configuring the networks, and their configuration is able to save around 10% of the energy consumption. And then the question is, can we do better than them? So we go back to the Is somebody going to lose his job? And the question is, yes, we can. And the framework was able to save an additional 5% with respect to the phase 2 test. And then, since we are using a digital twin framework with an optimizer, we can also give it more flexibility instead of something that is done manually. So we can look at the areas in which the traffic demand is lower than usual, than in average, and we can allow that area to have a lower user data rate constraint. And if we do that, we are able to save an additional 3%. So we go from 2,600 to 2,100 kilowatt hour per day. So wrapping up, yes, I mean, this framework was able to estimate quite accurately all the KPIs that are relevant for the energy efficiency problem. And it is generalizing well to different policies, and we didn't require any major fine tuning when looking at different energy saving policies. And yes, it can allow for energy saving in addition to what we can achieve through manual configuration by expert engineers. And it was able to provide a gain of around 9% in energy saving, which is quite good. And it answered the question that I raised when I started. Yes, machine learning, AI, big data approach can allow us to make our networks cleaner. So with this, I thank you. I hope I stayed in time. And if you have any question, I can take them now. You can write me an email. Thank you for listening.
Mike, you have a mic?
Sure, okay. So thank you. It's a very simple question. How does this relate to SRCon?
Yes, it is related to SRCon. It's a very similar approach. I would say that some of these blocks are, for example, the power consumption block and also the rate model is part of SRCon. And here we were mainly looking at the energy efficiency. So we had this first block that is computing the possible configuration of the networks, but the entire framework is, you can consider it as a sub-part of the SRCon framework. SRCon goes also into optimizing tilts and is more complex. But
you can say a word for those.
SRCon is basically simulated reality communication network is a framework that Huawei developed. And yes, the main idea is, we are looking at, yesterday we saw ray tracing, for instance, to characterize the network in SRCon. What we try to do is to use data that is available, that are cell-level APIs, MR data, and we want to construct what we call a statistically indistinguishable representation of the network, which means that all these metrics are able to create a system in which you can compute averages, medians, whatever, and you have the same values that you will find if looking really at the network data. So maybe the representation is not what is happening in the reality, but the entire metrics represent statistically what happens in the reality. And this allows us to leverage this information without going to more complicated approaches like heavy ray tracers are computationally heavy. If you want to run them in an entire city, this can be a big burden. Please?
Question, so is the digital twin here, is it in a closed loop or is it in an open loop? Meaning you constructed it, you fed all the data, and then you did the optimization, but is it pushing information back in the test bed or network?
So what we do, all of this is basically offline. We collect the data, we run the optimization, and then the things are basically manually configured, but we are looking into automatizing all of this and to have a framework that basically collect the data, send the configuration back, observe what happened, and so we can close the loop.
So I guess for you, it's a digital twin, it's sort of flexibility, convenience, but for right now, it's sort of a very accurate simulation.
Yes.
Okay, maybe in the interest of time, there is another question. No?
We have time.
You have
Because you're using reinforcement learning, so.
if it's not long, okay, yeah, please. We have done all day. So.
You're doing reinforcement learning, so I'm curious, how do you deal with the challenges of convergence times, which is always a problem?
But we are not doing reinforcement learning.
That's what I understood. So then.
Okay.
Thanks.
But I have some These slides will be shared, and there are many references in which you can find all the papers that describe this much more into details. Okay, thank you.
Okay, thank you very much. Our returning Professor James Sagaggio is a professor in the University of Federal University of Technology, Minna, in Nigeria. He's very active actually, and he's professor and head of the Wireless Communication and Intelligence System Research Group in this electrical engineering school in Minna. He's also a lot of article awards from IBM, different certificates, and he's actually pleased to be here. He's active also in the different focus groups that you mentioned, including his AN and his students also in terms of challenges. Please. Yeah, it's ready before to check.
We also share on the bridge.
It's normally should be shared. No? You should. No? Please share. Yeah, you have to share again. You have to share again. So one, yeah. Last one. Yes. Yeah.
Yeah, thank you very much for the time and the hard work too. Listen, I discovered the no convention, whether you want to sit down or stand up. But I love Doctor's presentation, to which she was moving around, presenting ease. I think I take it from you. So please allow me to stand up. Thank you very much. So my name is James Sagaggio. I'm going to be presenting principles of AI, a framework for energy optimization in future networks. Yes, I'll just take a look at this old stuff, my point. Yes, we're talking about the impact of AI and the ICT, the area of energy consumption. And the last week I just give us an analysis of what is expected of the consumption as a result of the impact of the penetration of these devices in everyday life. Now go to Moore's law, which is on his observation, where he said that numbers of transistors in an integrated IC doubles every 2 years. So we know the impact of that. And somewhat, when this thing completely aligns fine, something in this is the resemblance of this is what's going to be seen. Whole lot of chunks. So I made it clear to tell us that the most sophisticated iPhone is going to end up the junk years later. So, and when they end up in the junk like this, what happens? It's an incineration case, and what happens? They're going to add up to the atmosphere as greenhouse gas. So that is one. Then let's come to this one, right? That's where we are. because of the impact of AI, have much more available compute power. We know what that means. Then decreasing costs because these things are becoming more sophisticated, compact, smaller, and to this extent, we're trying to see how to decrease cost. So it will be readily available for everyone. So you're adding more pressure to what we say. Then AI integration into most of our systems, and this leads to increasing demands. A lot of persons need this thing. I think way back in my country, there was this time when some of these devices were looked at sophisticated devices for the exclusive, maybe the exclusive right of the rich. And there was a time where a certain man in government said that the phone, years ago, that the ordinary phone, way back, before the era of mobile phone communication, says for the rich, so nobody should be complaining. So, but presently, things have changed now. Down to the useful to make that better. So all of these are going to pressure on our system. Media. Now I have some case study, which will probably be examining. Energy optimization in data centers, green AI application in smart cities, energy efficiency, machine learning models. Now, what does it our SDG? What is it actually in this area? We have green AI for SDG. Green AI energy optimization aligns particularly well with several SDGs. It emphasizes sustainability, innovation, efficiency in energy use within the context of artificial intelligence. Green AI, very simple. In simple terms, artificial intelligence that is environmentally friendly. As simple as that. Application of artificial intelligence in energy conservation. The goal of AI is optimizing energy efficiency, reduce greenhouse gas emission, and promote sustainable practices. AI has emerged as a powerful tool that can help optimize energy consumption, reduce waste, and promote use of renewable source. Now here we have some opportunities we can explore: environmental conservation, energy efficiency, sustainable development, innovation and competitiveness, economic opportunities, and resilience to climate change. We have some use cases here we will talk about: healthcare industry, fintech industry, agricultural industry, education industry, data centers and IT services, energy sector, manufacturing industry, and transportation industry. Okay, mine here is a framework. So it's actually, to me, I don't probably call it this a conversation, I call it, calling this a presentation, I want conversation into it. We're having a conversation. Yes, it's a presentation, but we're going to have a conversation. Now, what are we trying to do here? We're trying to look at a framework that will make green energy a way out towards energy optimization that will be very, very beneficial to future networks. Now, energy consumption, I call that so one, energy consumption in AI. Current trends in AI energy consumption, that environmental impacts, need for energy efficiency, efficient AI solution. This is what we're trying to look at. So we're taking this slide, in this order, to be able to actually get a framework that we're going to be working on, because it's something that's going to be continuous and something that all of us are talking AI, but we're not talking about the end effects. And this is what we are into. So it's something that's going to be continuous. It's going to continue. Principle of green AI, key principles. We're to study and understand the efficiency, that's reducing computational requirements, sustainability, minimizing environmental impacts, transparency, making energy usage visible and accountable, collaboration, sharing resource and knowledge. Then three here, we have framework for energy optimization. Now, these are very, very key. We need to know this very well. That's component of this framework are hardware optimization, software optimization, data management, algorithm design. This is quite key. And why this is key is not far-fetched because if we were to actually talk about optimizing energy, our device will still probably need to be worked on. How? All of us here have, with the what device we're using, we have, they're all hardwares, and these hardwares are being operated by the software. So what is it we can do if we can kind of decouple part of these hardwares and probably throw them to the cloud, so we don't have too much of energy demand from collective number of devices we have. So these are key issues. Now here, take a look, principle of AI, key principles. I said efficient, energy optimization. That's hardware optimization, energy efficient hardware, low power processors, specialized AI chips, hardware, software, code design. So all of this will actually have a role to play. There are players in this proposal. Now, coming to energy optimization. Optimizing energy for energy efficiency. Now, we probably will be needing lightweight algorithms, energy aware scheduling. Of course, you know what we talking about here, where you don't just misuse energy when you need it and when you don't need it. So it should be a system that can carry the energy aware at any point in time you need energy, it should be available to you. And when you go to sleep, that energy should be stored somewhere or given to something else. So I can optimize the use of energy. Then code optimization techniques too. Then here, yes, some people will contend with key challenges, balancing performance and energy efficiency, integrating green AI practices in administrative system, overcoming technological and economic barriers. 7, data management, efficient data handling, reducing data redundancy, efficient data storage and retrieval, and data compression techniques. These are all ways out. So beyond that, it's going to continue. Future research direction, innovation in green AI, more innovation in green AI, potential breakthrough in energy efficient compute. So here are some areas where we probably taking from energy some key points from energy optimization. Here we have a green AI to promote fewer hardware, so green AI to increase the longevity of hardware. Green AI powered system can analyze vast amount of data from sensors and other sources and make informed decisions about how to optimize energy consumption. So we're going to have a system that's AI driven that's going to come out with meaningful insights on how best to redirect and manage, effectively manage energy consumption. So not leaving everything just open for the system. Green AI can be used to optimize the placement and operation of renewable energy infrastructure, such as wind, turbines, and so on, like we have. Some of the existing systems, not even in the field of electronics or whatever, will benefit from this, so as to maximally impact on them, so that it will last longer and equally perform more better. Green AI can be used to optimize placement of finally, AI can play a role in promoting sustainable consumption and waste reduction by analyzing consumer behavior and preference. That is it. Consumer behavior can equally be analyzed and meaningful insight can be made, better decision can be taken on how to make energy readily available. So, some key solution and architecture. Now, addressing this standard gap between developed and emerging nations from Africa, especially in 6G. Now, we're actually trying to see how we could bring this into our domain. And I'm going to talk a little bit about the domain where I come from, because as a matter of fact, we all have our peculiarities from different regions of the world. So, so just okay, I come and describe myself. What you doing here? We all have our different peculiarities. So that's why we come in here. Advanced analysis of AI native techniques, which will be driven by this scenario. Yes, it will actually interest you to know that at the moment we're actually pressing on how to see that focus group on AI native in 6G in future networks is actually giving birth to, and efforts have been made in previous parts to see how this thing can work out. And I think the efforts actually came back to a correspondence group that AI AI native in future networks. That's the name. So, and it's actually working. So I said, see justification for a focus group to study the integration of AI native techniques in future networks, which is MG, AI, 6G. I think we're going to be discussing that in our other sessions. So here we have why we need energy optimization in future networks based on the background from green AI. So we have environmental impact. So I made this a little bit wordy. Why? Because I want a situation where I can get hold of this slide, so you can easily connect to my slide. So reducing energy consumption network helps decrease carbon emission, cost efficiency, lower energy consumption translates to reduce operational costs for network providers. Resource management, efficient energy use helps in managing limited natural resources more effectively. They have scalability. Future network are expected to handle an exponential increase in connected device and data traffic. Then regulatory compliance is very important. Let's take it very seriously. Network providers must optimize their energy use to comply with these regulations. Now, technological advancement, global competitiveness, and so on. So, energy optimization in future networks. In summary, energy optimization is essential for sustainability, cost efficiency, performance, scalability of future networks. Now, we didn't just emerge or just came up overnight. We've been coming from a time where we actually came up conceived an idea to come up with a group, a research group. In my university, I have a research group which was giving birth to YNest, and we've been working on some of these challenges. So I must actually appreciate ITU, Professor Leon and Professor Lee. Some of these platforms we created actually build the gap for us to see us up the game of our research group and equally measuring up with our contemporaries in some of the challenges that are put together. And these are some of the challenges taking place that took place and the students participated in. ITU focus group ML5G student project, more than 3 contributions were made. ITU news magazine for ML5G articles highlighted. So here they are. I might not be able to be all of them because of the work of time. So here we have finalists and third position. And this is how we work. We form a team of scholars and students that set weekly meetings, brainstorming on relevant problem statements. 3, wider conversation in IG meetings and submission. This has actually helped us a great deal. And this is just a scenario of what we do over here. Pushing some of these young stars together and look at this take a look at these use cases and the weekly meetings help out. And I think that has actually led to winning, to getting certificates and equally winning award. And I can actually link to that physically now. That just now we're giving another award from on this one, which is Innovate for Compact, which we came out as winners. I think some of the research group members were invited. And one of them to represent the research group, this certificate. Maybe you could see me a couple of minutes ago. I was up and down. I had to go to the other room where they actually holding this, and just one day. So this is a result of some hard work and encouragement from some of you and the IT yourself. So these are some of the key takeaways. We've had the opportunity of being featured in very high media interviews, and on this account, most students have actually enjoyed a scholarship and this high visibility. So it's actually important that we continue to advance the course of what we're doing. So I'm not going to tell you of our success, but tell you our challenges. Yes, our region is still evolving. We still do have problems with electric power supply, connectivity, then low sector penetration when it comes to AI awareness. So we do a whole lot of work to see a whole lot of persons. So I have a responsibility trying to train the trainer, mentor many other mentees come up and be involved. Then lack of proper mentorship. Then of course all of these need funds. So some of us are actually have to make sacrifices from our own pocket to see how we can fund students to develop their capacity. So using AI to reduce G standard barriers. So these are feature works. So at the moment, this is a use case, and it's on the account of this use case, we're given this award. That's using AI to reduce G standard barriers for African contributors by adopting green energy, increasing contributions to ITU to impact to LDGs, seek collaborations with bodies for support, plan demos, and plan workshops. So I want to say thank you to some, though sponsorship is very quite difficult, quite challenging in my region, but as some interval, from one or two, I've actually showed love by showing concern and appreciate what we're doing. So I'm using this opportunity to appreciate Nigerian Communication Commission in Nigeria, Ministry of Communication, Innovation and Digital Economy in Nigeria, and the ITU for actually taking us this far. Thank you.
His speech, really, we have to thank Professor Gage for his really big effort in introducing a lot of people in the technology, the participation, standardization. I think IDU has done his job, but you have done a lot of work, and I hope this will continue. He mentioned focus group opportunity, but actually IDU is offering also regional groups, entities in which regional requirement can be brought in, you can be helped to advancing the directive standardization, not only pre-standard, but that's another topic. I want to say that Professor Gajari has been one of the RD people with this team since long time, and really is greatly appreciated. I hope this IDU and other organization can help satisfy the requirements. Any question before we move to the last speech? Dr. Ravi, please.
Thank you, Professor, and I really appreciate what you're doing and very thoughtful class and presentation. I just have a reflection on what you're saying because ironically, when we talk about green AI and the use cases for AI, that AI can contribute to improve the energy consumption, energy efficiency, while AI itself, on the other side, is actually contributing to a lot of things that are related to power consumption. Even there are some graphs saying that the power consumption of data centers are going to having 60% increase in 2030 because of AI movements. So this is the dilemma that we need to work on. I mean, we need to optimize our way of deploying machine learning models and application, and then
Once we do that, that will be like a pilot that we can maybe replicate to other industries. But if we don't do that, we will all be bankrupt, not, not doing that, because we are contributing heavily to this problem.
Thank you. I call this more of an observation and contribution, aside the question. This topic is actually a two-edged topic. As you are looking for how to use it, get solution, the act on its own is equally contributing. So we have a lot of responsibility to look at the middle point. What is it we should do? Like I was saying, I saw someone some couple of years ago who was so excited in my community. He's that he's so fortunate. Maybe he's got money. So when the latest iPhone came out, he bought his and was flashing it everywhere. He's going to make call, hello, want you to see the logo. Hi, something people just make call, want to see him. And I told him, call. In a couple of years, it's going to be an old one. The one I'll buy will be a new one. You understand? So what I'm trying to say here is that the discussion is evolving. And certainly, well, that's why for this is just a procedure. I'm not coming up with measurements, results, or anything. No. We're looking at a framework to see. So maybe as we go forward, these concerns will be accommodated and we'll look for a big plan to handle this. Thank you.
Thank you very much again. Last speech of this session before the panel is Dr. Patras. Paul Patras is a co-founder and CEO of NetAI and is also associate professor in the School of Informatics in Edinburgh. He has 10 years experience and working on deep learning to solve different problems about networking. And today we will talk about, sorry, I missed your title, but I leave to you directly. Very nice. Yes. You need to stop the sharing. Talk about turn off the 5G lights without servings going blind.
Okay, so there should be a video down there, but you might not get the sound, then I can talk to some, there's some subtitling. So obviously this session is largely about sustainability, about how we save energy in telco and so on, and we heard a bunch of interesting ideas right now. So saving energy is only one part. So I did this kind of cheeky thing, like you can save energy, but if you switch out the lights, people are not going to be happy. So like similarly, if you don't have proper coverage or proper service availability, you lose customers. So you have improved the energy footprint of your infrastructure, and you save some costs, but you're also halving the revenue because some of your customers will churn. So what I'm trying to do today is just talk a little bit about how you can actually save energy without impacting service quality. And with the risk of repeating some of the things that Nikolai has mentioned earlier. So obviously we do sort of live in a sort of crisis. I mean, sparking costs, a lot of energy being spent on infrastructure. 5G is more power hungry than 4G. Telecoms is responsible for 2-3%, give or take. There's a 20% year-to-year increase in mobile traffic, which means we need more infrastructure, which means more energy consumption, and so on. The vast energy in networks right now is consumed by the radio access network. So most of the savings that are possible or like viable will be there. And aside from the saving, I think this was mentioned as well. Basically, the spending on energy is actually outpacing the sales growth. So people spend more on energy than the rate at which their profit is growing. So that means that, unless operators are doing something immediately, they risk becoming irrelevant very soon. And we're not going to be seeing prices that are below the levels we've seen in 2020. And then you're here, you probably went to some other talks. So there's pressures from all sides now on carriers as well to become net zero by 2030, by 2050. It depends on which country you're coming from. So, I mean, the problem is clear. I think there's no debate. So now the question is, what do people do right now? And you saw some potential solutions presented already. I mean, sort of, I mean, this is not a new problem. People cared about this for a while. And one approach was to switch off some of the cells when there is no traffic, and this is typically done at cells, yeah, which is kind of good. You switch off some of the capacity layers, you keep coverage, and it's for happy days. It's kind of safe, you can schedule it, and so on, and you keep some decent availability. The problem is you don't stand to save much. I think I'm more optimistic than my colleague earlier. We think you can save up to 15%, but depends on the deployment, depends on how many users you have, and so on. So give or take, yeah, averages can vary. But that's not huge. So initially those slides had company names, but I know some of those employees. I don't want to kind of create any sort of debate here. So we are aware of some commercial solutions that go further and actually do a better job. So there's people looking at ML already, understanding, for instance, what demands look like on a specific day of the week, hour of the day, and so on. To me, I mean, there was a talk, and you probably saw that talk, you know about it. People say, hey, we're using ML to learn that behavior. Honestly, to me, that's statistical averaging. You don't need machine learning. Actually, you can just collect the data and compute some statistics and use those statistics. So this can actually work. So if you just take it at face value, don't do anything about it, you can potentially save up to 55% energy. But that brings me to the second problem with which I started, is that if you just do that without any consideration of what's happening with your demand onto your network, that may lead to under-provisioning, which is up to kind of 17%. So that means there will be degradation. If you have enterprise customers, that means SLA violations and so on. So churn and unhappy customers. Other solutions out there, they use some AI-based dynamic thresholds, which is a little bit better for cell sleep and so on. But of course, they have some limitations. So how much you can save with this is the range is between 10%, at least to my knowledge, to the amount of reverse engineering we've done, because not everything is public knowledge. And some of the stuff I will show you will not be so. I'm not going to open up the box completely, because some of the things we're doing is also sensitive. Everybody's working in this space at the end of the day. The problem with this is that you can do that, but what we've seen is that the amount of carrier control is relatively coarse. You don't really do partial switch off, so you just switch off a complete carrier and that's it. You don't switch like portions of the spectrum and like keep some of the stuff on. So you leave some of the value on the table, in my opinion. Okay, so what is the challenge of actually using ML to drive this problem? So obviously, what do you want to do? You want to anticipate the demands and then respond to those demands. Control your radio access infrastructure in response to what you think the demand will look like. So yeah, ML can be really good at that, but you can't just take off-the-shelf models and expect them to work magically, because they will not. So I'm giving you an example here, which is a city-scale deployment with over 200 antennas. Obviously, it's kind of scattered. It's not like a Manhattan view and so on. You normally get information from the management plane, which represents, for instance, aggregate traffic that you sample anywhere between 5 and 60 minutes, depending on how you configure the network, depending on who sold the infrastructure and how much flexibility there is and so on. And you would like to predict the demands, for instance, for the next 30 minutes up to 3 hours. So give or take, depending on the resolution and so on. This is a multi-step prediction. Okay, cool. So what do you do? We'll say, well, I'm just going to go take Python, take some off-the-shelf libraries like LSTM, train on LSTM, which is a long short-term memory for every network element, and predict that demand. That's fine, but that doesn't really capture any specifics of that demand. Or you could do something which is clever, build a neural network from the ground up that actually tries to learn the specifics of that network, which is something that we did before we spun out NetAI. So we were looking with one of my former PhD students at how you can tailor a model to such a deployment and do point cloud forecasting. So forecast directly on that with a new dynamic convolutional operator. And we looked at, okay, what is the prediction accuracy? What's the average MAE as you increase your prediction step. And you would say, well, yeah, the difference between the two is like, it's non-negligible. Like, why would you care? Well, actually, you do care because the difference as you increase your horizon is 50%. So if you now translate that into some control, that means different savings that you can achieve. Okay, so what's the second problem with deploying ML here? So the other is like, okay, so there's this trade-off between complexity and scalability, and accuracy, right? So what I'm showing here is that, you might have different models that more or less perform the same. So you're looking at, performance loss as a function of the number of parameters that you have per antenna. So performance loss versus like the best performing model. So we took a series of models. We thought, okay, which one is the best performing one? And then we looked at how worse off are the others one we consider. So obviously the first one is great because there's no performance loss, but also it's very scalable. I mean, we train a single neural net for the entire deployment instead of training an LSTM for every single element. So what does that really mean? Well, that means order of magnitude fewer parameters, which means great scalability. If there are changes, it's much better to update the model. You don't have to retrain hundreds of them, or if the deployment is the size of, I don't know, daily, you don't have to train tens of thousands of new models, which is great. So then we said, okay, and there's a final step. The question is like, how do you train that model now? Do you just take an off-the-shelf loss functions like MAE, MSE, and so on, and expect it to work as you want it to, or do you do something else? Well, I mean, you need to think about like, all forecasting will be subject to errors. It's inevitable. You will have spikes, you will have drops, which are notoriously hard to predict. So the question is, how do you want to go about it? And how do you want to kind of avoid certain types of mistakes during training, and which mistakes are more costly than others? So point is, not all mistakes are created equal. So if you underestimate, for instance, that means you will take a prediction, translate that into some number of resources, being the compute or radio. And if you underestimate it, you will have fewer resources, which means your service will be below par, which means your customers will have problems. So what we do instead with this foresight technology that we have is when we do forecasting, so you see the serving demand is the light bar at the top, and the prediction is kind of riding that wave of the demand. So we slightly overestimate more or less all the time. But what we try to do is not overestimate grossly, because then you don't save much. What we try to do is reduce the number of underestimation errors, which is what you see on the bottom. So every time you see like a tiny red spark, the errors are pretty small, but you want almost eliminate them, which means you want to reduce the number of instances when you translate the forecast to under provision. So we have a clever approach to this. We have a clever loss function. I can't tell you much more about it, but you get the gist, like, where you want to get to this with this. So then the question was, how do we package this? How do we deploy this? So this is an example of a deployment we did recently with VMware in the context of Open Run. So basically, we take all these KPMs that have to do with traffic, well, the volume of traffic, throughput, basically at the level of an antenna. We feed that into the forecasting engine, and then we take those forecasts into Energize, which has a decision logic that basically converts that into a number of RF carriers that have to be active at any point in time at any location. And then, based on that computation, you have a command that you send to node. That typically can be an RU or whatnot. And then you basically update the carrier configuration, and in the end, that results into energy efficiency, some reductions in CapEx potentially, and better quality of experience. Now, that's all good, but not everybody is doing Open Run. So the beauty of this is that everything is a microservice. So Open Run for me is like, you travel from the UK to Switzerland, you don't buy a new laptop, you just buy a travel adapter. It's kind of the same. You just wrap a different API around the microservice, and you plug it into 4G, 5G, or whatever network you have. So this is what we try to do. What I'm trying to show here is exactly the point that I made at the beginning, is that You can save energy, so you have always on, you don't save anything, you have best availability, your service is always on, and then you can start playing around with all sorts of things. So you do overnight power off, you save 15%, you lose marginally on availability and so on. But if you look at all the other sort of approaches, yeah, you don't do great. You would do great if you had like some perfect oracle, which of course you don't, that will know exactly at any point in time how the demand will look like and save energy. I mean, I guess AI should get there, but we're not there just yet. What we are doing with Energize is to attain an energy saving in on average about 35%, while compromising only 0% of the accessibility, which is pretty great, right? You're not really impacting service quality. So as I said, integrated with VMware. And we have colleagues from Red Hat here. We also did integration with OpenShift recently. So just to demonstrate that you can actually deploy in any type of architecture. The other point I wanted to make before I give you a demo is, all this saving is like great, but you can't save 35% everywhere. It depends on the load of a cell. Some cells are more loaded than others. So if you have an area, let's say it's a residential area, people go to work and it's kind of quiet, then there's opportunity to save up to, maybe even more than 60%, depending on how much accessibility you want to maintain. But imagine like an extreme scenario where you don't want your accessibility to drop below 0.5%. In that case, you can save in a lightly loaded cell 59% energy. However, not so much in a heavily loaded cell, which maybe has, I don't know, tens of thousands of users at any point in time. However, there's still a bit of a margin, it's like 4%. So if that's, that's power hungry, you have a lot of cooling and so on, it might not negligible, it might not be negligible over the course of a year. Yeah. So I said, maybe I show you this in action with a tiny demo, which actually we prepared ahead of Mobile World Congress recently with Red Hat. This video demonstrates. So maybe you can hear stuff, not I can think, and I can explain. Let's begin with looking at how we begin forecasting. So what we can see here. Below here, I can go through them. And we are able to do traffic compensation. Very high. So this is we forecast the evolution of traffic behavior. So services. To see the focus, not forecast, but single series of points with forecast confidence bands, meaning that very high confidence that the traffic expressed in the forecasted service is due to lie within this particular line range. Okay. And then the other thing we can do is add the distribution across the program. So for example, histogram should be those cells. So one traffic exceeds 30 gigabytes. It's visualized. That's probably when you don't say that much. But as a byproduct, capacity flow is when you can show this location. So what can we do? So one application that we have, one application is improving the energy efficiency of access residents, which about 80% of the total energy consumption. And we built a tool which uses the forecast to decide how many radio frequency carriers should be on
any location, any specific time, we should be able to meet the expected in traffic demand from our customers. But importantly, we don't want to too few resources because that can lead to service degradation, which passes user experience. We also built a small visualization tool for that purpose that itself runs on OpenShift with all the cloud platform deployment. What we've done is also create a visualization tool that communicates with the tool via the REST API, visualizes information. Things that get spent up here because the frequency of the measurements that we use to drive these allocations are 50. So we kind of create this one fast forward. We're also showing some benchmarks here. So at the top is the legacy power consumption, meaning that all cells are all the time. And then the bottom is the so-called optimal power consumption, meaning if I had this more. What you see is what is our function, which effectively uses then on the right hand side, what you see is what that you see at 140 cells. What is the energy consumption if everything is on versus the two approaches that I mentioned? Importantly, we have the spark choice. So let's understand a little bit why this is such a drastic, why what is actually consumption. That's because the way we forecast here is like a select with different antennas and visualize basically count of information. It's not if I had information about how I think we fall into the future, which actually have. But the way we do forecast is it's kind of unique. Because we're trying to minimize the number of events like this one where we underestimate, meaning we will slightly overestimate, like most of the time, not by much, because then we have missed opportunity to save energy. But we try to avoid events with basically this gray line again, which we wouldn't have information about this impact, doesn't cross the forecast. What does that translate into? Well, on the right hand side here, you can see how those forecasts are being translated, number of areas that are allocated. Here I'm using this optimal carrier allocation as a benchmark. If I had put as the information and the bars are. So you can see most of the time we're a bit conservative, but we get it right. So we get it. Perhaps this is more obvious when there are measurements, we have a container of information. So everything that you can see here. But almost always on par with optimal carrier allocation. Bias to the left, right. So that that's one thing you can hear. That's and I hope to see you and how you can deploy this.
So maybe just one observation there, which I didn't make here. So if you see, for instance, we do estimate and we overestimate, but the number of carriers that we allocate is almost the same as the decision of what the take. Because sometimes you overestimate, but you still need to decide on a discrete number of carriers. And that overestimation might actually translate in that number, which is the same as what the Oracle would be. So slightly overestimating is all right. Underestimating can be problematic. Okay, so I'm finishing. So just wanted kind of closing the theme of the event. So what do we do at the end of the day? So we're targeting one of the important SDG nodes of the UN, which is climate action. So this will basically play into targets of achieving some that's like this.
Or you can just
to stop this.
yeah. Okay, so go back. I'm finishing, by the way. Okay, so I was saying, okay, so I mean, this is probably targeting climate and so on, but it's not this much. Of course, of course, of course. Just to finish that. Okay. So aside from that, I mean, the fact that we are able to provide sort of real-time and predictive insights into network usage and performance allow us to kind of tap into a bunch of other SDG challenges. So one is basically making it a little bit more affordable for operators to bridge the digital divide, to be able to kind of allocate resources when and where they are needed. So deployment, kind of return on investment for deployments in sort of sparse populated areas becomes a little bit more feasible. And then you have a bunch of industries that emerge now. So if you're able to kind of customize your network according to the specific demands of one certain application, then you're able to kind of, cater for new applications. So I'll give you an example here of autonomous transportation. I mean, road traffic gridlock now is expected to sort of hit almost 300 billion by 2030. So that's a big problem. Yeah, so that's why actually at the demo, what you saw is that we're able actually to do actually first thing that we do is decomposition. So we break those aggregates into the individual services that make them. And then we can also forecast at the level of individual services. So there's far-reaching implications of what you can do with AI-driven network insights. So even with that, I just want to acknowledge some of the support we're getting for that. So part of the work we're doing in this framework is in the context of this Horizon Europe project called Origami, which is partly funded by the European Union. In our case, underwritten by Innovate UK, because the government dragged its feet a little bit with association with Horizon Europe. And if you want to speak with me beyond this event, you can scan the QR code and that will allow you to kind of book a meeting with me, maybe while I'm here, and if not, over Zoom, Teams, whatever. And with that, I'll thank you for your time and I'm happy to take any questions.
We are 10 minutes late, but actually later we recover 10 minutes for the panel. So at the same time, because we have the panel until 5:30. Any question before we close? You want the mic? This is no problem.
Thanks for the presentation. And I think in the earlier slide, probably slide 2, you did mention precision. You did mention precision step. Do you mind throwing a little bit light on this? Does it mean the number of epochs, or I would say measure the complexity of the algorithm or of the models? Also, the two models that were compared in the graph, I also noticed that as the precision step increased, the loss also increased as well. Can you explain a little bit on that also?
Yeah. Thank you for the question. So there were 2 points there in that question. So one is to do with the granularity.
Precision step, if it is the epoch or it's a measure of the complexity of the models.
Yeah, so I think there's probably a bit of misunderstanding there. So what I was referring to is the fact that your input data might come every 5 minutes, every 15 minutes, every 30 minutes, or every 60 minutes, or whatever. So what you will do when you do multi-step prediction, let's say if I do 6-step prediction and my granularity is 5 minutes, I'm going to forecast for the next half an hour. But if my granularity is 10 minutes, then it's the next hour, and so on. So that's the point I was trying to make. Now, if you have very fine measurements, you can do 30-step prediction, because that's going to allow you to look at,
a number of hours ahead of time.
Yes.
Just because maybe you want to do some handover management, some traffic steering. So there's a bunch of other things you can do in addition to just switching on and off radio frequency carriers. So, but to do that, to kind of expand your horizon for your forecast, then there's a question of like, what sort of models do you use? You can use an off-the-shelf model, which will work fine, but as you extend that horizon, I mean, it's natural, like the precision, the accuracy will degrade with the horizon, right? If you have a model that is able to understand spatial and temporal correlations that are unique to mobile traffic because people move for, I don't know, on wheels and so on, then you're able to reduce that error. So that's what I showed, that there's a model that is trained to do just that, to learn all these abstract spatial temporal correlations. And the second point was about the training. So what kind of loss function we use? So I think this is I would say a grossly overlooked aspect in our in the telecom space, networking domain. People don't really think about, hey, maybe the traditional loss functions that I use for, let's say, time series model prediction are not good enough. Because the point I was trying to make is like not all errors are created equal. So that means my loss function would have to have a different shape than an off-the-shelf one. And it would have to satisfy some properties, it has to be different shapeable and so on. So there's a couple of things that you need to think about to do that.
Thanks.
Thank you. I'm sorry, we are obliged to close to start with the panel. So Leon, please, take the floor. Sorry for some minutes. At least, yes, we thanks to all contributors for these sessions. So now, please, the floor is yours. With I don't know if the other colleagues will join here or not. You want to give 5 minutes?
Thank you so much, Marco. So now we have panel sessions. I'm trying to figure out how we do this. We have our panelists. Next time we invite the panelists to lunch. And no, really, there's no movies, there's no trailers or anything this time. Yeah. Sure. It's against that. Fine with it. The important part. No, I'm sorry. I didn't mean that. Yeah.
Okay.
Go get it. I'm not sure how to share, maybe share anything for the students. Yeah. Okay. Yeah. Okay. Thank you so much, everyone. I think this is one of our last session for this workshop itself. So we're trying to conclude the workshop with this panel session itself. So I really appreciate everyone's participations for the workshop for the last 2 days. Hope you all enjoyed a lot of sharing from all the experts to the field industry itself. So this panel session is basically like to conclude what we had or what you had been listening for the past 2 days in terms of what's AI native and what's the future towards the itself. So we have the privilege of having 4 very important, very knowledgeable people, same like you all sitting down there as well. So I will go straight to the questions while I introduce the people. So as I was saying, the panel section is about AI native future. So first, I would like to ask the very, very basic questions of what does AI native means at all, and what does it mean to you all, and what role do you think AI native will play in future next? The first one I would like to ask research is the advanced tech R&D, next generation R&D engineer of itself. Floor is yours, but maybe if we can have one more mic, I think that will be.
You want to look for a battery?
Do we have one more mic?
We're gonna share. Okay. Thank you, Liam, for the introduction. Actually, this is one of the most favorite question for me. The AI, what is the AI native? Because it is not an easy question, actually. We had a really good session about the AI native, and we hear a different perspective about the AI native. Actually, with the new development on the large language models and the generative AI, we see that the AI models has a different capabilities. So, but still today we are using them as additional components of anything that we are doing. So we are using them for replacing a capability into our the technology or the platform. We are using automation, we are using the different vertical application, but especially I think the first time that we suggested the AI native studies, it was harder to explain because we did not have this like the ChatGPT 4.0, the crazy, the Gen AI stuff. But right now we see that the AI models has the capability that can manage the different AI models, that can create the codes, that can understand, that can even detect the diseases sometimes better than the doctors. So the things that we want to reach with the AI native, actually, we want to create a framework that each and every components, including AI, they are self-aware, they have an AI capability, they can connect with each other, collaborate with each other, and they can also evolve each other if it's needed. They can upgrade themselves, they can call their other AI friends into the scene and solve other problems. So we are trying to build this kind of approach. And actually, since I am working in the telco, this is coming from one of the problem that we are trying to solve in the next generation mobile networks. And it's just the answer of your second question. Because the 6G, we see a couple of times, we are saying connected intelligence. Actually, we are saying that we are targeting to connect the AI agents or the intelligent agents and try to create a solution on top of it. So in order to connect them, and of course that we are just talking about right now the AI and the capabilities, but there are other aspects, the plugins that we are discussing right now, like the reliable AI, right? The different plugins that we try to integrate the AI platform. So in order to have a trustworthy, connected intelligence that we want to achieve in the 6G, that is connecting a billions of devices, and that managed from the edge to the cloud, is really the complicated architecture that we don't have in the 5G. That's why we need to work on the different and novel framework, so that we are saying that AI native platform. So it's really the one of the core technology that we will probably see in the 6G architecture. Yeah, well, thanks.
Thank you so much. I think we have one more mic, and with one more mic, we have one more panelist.
Yeah, we go.
That should be up here. Dr. James, would you like to? Yeah, because Dr. James, you're supposed to be part of this as well. Apologies.
The second mic had no battery.
Oh, it's okay.
Are you just saying now? Yes.
Oh, good. Thank you, Jeremy. Good. All things comes in five. All good things come in five. All right. I wanted to ask the same questions to Abdurrahman. Abdurrahman is the senior research specialist from Lanka Standards. What's your view on this?
Thanks a lot. I'll try to be brief on this. So you asked for what it means, and I can give you a clear definition, right? I think the definition changes from one person to another, but I think what Usa's tried to put in an explanation way, I'll try to kind of briefly summarize it, right? But before I do that, we need to look at why actually is AI native now the topic of choice forever, right? So if we look at the evolution itself, we started from suns, right? We went to cognitive sun, then we went to autonomous networks, and then we said, okay, why doesn't AI come and play with us in the sun bursts? And then it became AI powered, AI assisted networks, then it became AI powered networks. And now we're talking about AI native networks. And during all of that, AI was being used already. It's not that AI suddenly made an appearance in the game. My brother did a PhD 10 years ago, or 12 years ago on computer vision, and he back then was already doing it in a field that is already 10 to 15 years old. So it's not a new technology. I think what happened recently is that it became a topic of the mass, that everybody was aware that AI can do something, even if they didn't understand how it was being done. That's why now it became like everybody's talking about it, not only us technical nerds, but it also became everybody else in the street. So now coming back to the evolution of the network itself, what Uzo was saying about how the network, how we were introducing different components to replace legacy components in the network using AI. Yes, unfortunately, that's what happened when we started talking about AI. And this brought us now to the current, and I'm a standards specialist, so I talk from a standards perspective. This brought us now to the current status, which is a fragmentation of what is being standardized everywhere related to AI. We have not only fragmentation in the same organization, but between different organizations, but even fragmentation in the same organization. So having said that, so what is native AI and what is it different in comparison to 5G advanced, 5G, or the normal AI usage that we've already been discussing during the past 10 years? What is different is that now instead of us using AI for the network, we're actually looking at the network for AI, which means that it's not anymore about using AI to optimize your network. That's last year's work. What we're talking about now is that how can the network enable AI? And this brings us to actually the meaning of native AI. The reasoning behind it is that it's like saying Native American or Native Australian is that it's a person, that's an entity that is in its natural habitat. It means that any AI component should feel as if this network is its natural habitat that provides for it all it needs. So a clear definition would be that a native AI network is a network that is designed, deployed, and operated with AI requirements in mind. That means that the full life cycle of the AI component is supported throughout the network, throughout the life cycle of the AI component, across all layers in a consistent and aligned way. That means you don't do it in a different way in one domain and a different way in another layer. No, it's aligned across the different domains and layers. This is very important. When you really have the mentality of a native AI network, it means that network sustains AI as a life form consistently across all domains and layers. That's my understanding.
Very interesting view on this. Anyone else want to have a view on this? If maybe I'll ask Professor Lee. Professor Lee is a professor from Liverpool John Moores University. Maybe can give some thoughts on, your point of view from academic point of view, what AI native means to you, and then what are some of the emerging areas in AI native that the academia is currently or should be focusing on?
Okay, thank you. So my perspective is regarding several different technological solutions for networking, etc. AI native is not really a new technology. So AI native is a kind of a new technical approach, a kind of a new design concept. So firstly, when we consider AI solutions to the networks, without considering AI native concepts, we just simply consider to use several AI and machine learning models to support many different purposes for controlling and managing networks. Now I'm thinking about very fundamental issues. For example, around 10 or 20 years before, we started to investigate development of huge networks. At that time, there are two fundamental different ways. One is evolutionary approach. The other one is language-only approach. AI native definitely evolutionary ways. We already consider so many number of technical solutions to use AI techniques. But AI native is a kind of a new approach to best utilize so many number of emerging technological solutions to support AI enabled networking or applications. So in this context, AI native might be very fundamentally used in the new networking technology solutions like 6G, but current networks also need to adopt this kind of new approach. Then in evolutionary ways, we can support this kind of new technical solutions. And the very interesting point is AI for networks and the networks for AIs. Very traditionally, we already consider mostly AI for networks. Now we are talking about so many AI-enabled applications. So the networking roles should be fundamentally different. So in this context, we need to think about how we fully support so many number of AI-enabled applications. So then network's role should be different. So we need to facilitate to interconnect various kind of different AI models, including available data sets, and interconnect so many different stakeholders to building up various kind of AI-enabled data infrastructure. So this is a very fundamental ways to consider various kind of new networking technological solutions for the future. Thank you.
Thank you, Professor Lee. That's a very interesting aspect as well from that. Yeah. So given that what Professor Lee says, AI is an approach, but it's an approach how we want to integrate new technologies to the network, the emerging technology itself. I would like to ask Professor James, you have presented very well on how you have incorporated your students to participate in such global forums and prepare them for this. And so what steps should academic institutions like you and academia take to prepare the students for such kind of new directions of technologies such as AI itself?
Thank you very much for that question. With regards to the topic in context now, as someone in the academia who found AI very, very useful because it's actually breaking barriers as we're talking now. And I just told you a while ago that we got been issued a certificate as winners. And what is it we presented? We presented a use case on using AI as a means of bridging gap, closing barriers for future collaborators in Africa. So what it therefore means is that you have an opportunity to access very easily some of the things you probably feel are quite difficult to access, because most AI functions and applications are now readily available some of them could be online. You closing these gaps. And as a matter of fact, the emergence of AI need, like the other colleague has talked about, is actually making things much better. How? Now let's take this example. Now, when you try to integrate more systems and make sure that the core aspects of these systems are integrated with AI, the core features of system are integrated with AI for better performance. Now, it therefore tells you that AI is not going to be seen as a buzzword, but something just like a normal word, because even if you go by the name, the word AI native, it's going to be kind of a native language to everyone. Let me just use that analogy. So we're going to use this one to advance the course of learning and bridging gaps. The go between that we suffered before is actually not going to be there. And that is why I made mention during my presentation that presently we are actually making efforts. At the moment, between the interval of, let me say, 23rd October 2023 to 6th of November 2023, I think there was this effort at presenting, making contributions, about 5 contributions were made, all in pursuance of what? Trying to see if a focus group on AI native for feature networks be instituted. And I think the effort was not lost as we're able to get the correspondence. So these are opportunities to open up these frontiers, and hopefully we feel that the proposal for the focus group will be given back to. So at this point, my university, and the side group of my university, YNS, is actually available, and everybody looking for supporters, both whatever, to see how much we can drive this course and eventually get to realize this. Thank you.
Thank you, Professor James. As I do believe academia can play a very big role in this this kind of new technologies emerging directions. I would like to ask the same questions to Paul. Paul is the very producer of Glasgow. What's your view on this?
Thank you. So we made our way to the end of the line, though. I thought what you said is really interesting. I really like the way you characterize it, because I think we all collectively agree that there's a lot of technology out there, and there's a lot of stuff that's already been done, and we don't need to reinvent the wheel. And it, especially because this is about telecom, right? It's about practical stuff. How do you actually do it? How do you actually leverage it? How do you incorporate things? I'm going to split it into 2 parts: the undergrads that we train and then the research that we do, right? So from the undergrads that we train, and I think Paul's Petras's presentation captures this quite nicely. We need to teach people how to do statistics. You know, we need to teach them how to actually look at data and smell it. Does it smell good? Does it smell bad? And we need to couple that with practical training. Right? So Paul had that nice graph about LSTM versus customized LSTM, and you know, it's good enough to get going. But if you actually have a use case you care about, what do I do about this? Can I do something? And so we need to train in the fundamentals. It's a boring statement, but I think it's a consistent and timeless statement. And then from the research side of things, the other thing to say is about practical things. I'm a big fan of not just doing mathematical calculations or even just simulation studies, but go build something. Set up a little Kubernetes cluster and play around with it, grab some data from an open data set, or play with something. So if you can couple how to understand the statistics of the data that you see, coupled with some practical, you know, I'm a computing scientist, I believe it's a practical subject, right? There are theoretical. From the research side of things, partnering with the people that actually understand, looking at real data sets, looking to some extent at the standards, but as a good colleague of mine often says, just because it's standardized doesn't mean it's right. And, you know, challenging this is an important part of it. The complexity with all the different things that we see is coming out. You know, our colleagues here are talking about needing maybe a new focus group to look at this. Whatever venue it takes, we need to study it. We need to understand it and to be able to explore it. And I think research is a nice way to be able to do that, influenced by standards, but not necessarily adhering to or following standards, because just because it's what it is today doesn't mean it's what it's going to be tomorrow. I'm in a university, so I can say that.
Thank you, Dr. Wall. I really liked the last statement you said. Fortunately, I'm not from university. But very, very interesting inputs on this. I would like to, okay, let me just transit to the next questions then. Given the interesting aspect of like everyone agrees, yeah, it is not new, but yeah, basically it's a way of how we approach the new technologies, how we incorporate it to the network itself. But you see, we have seen the presentations. There's new LLM models coming out every morning. I don't know. Every time you have in future, maybe every time you have a cup of coffee, there's some new models coming out. So given that kind of fast changing pace of the so-called AI technologies, the constant change of this AI technology itself, I mean, how can, this is where the solution providers come in, how can the solutions provider, not the academia, adapt their offerings to cater for this kind of evolving needs? Like, let's say AI native is a different way. Like you have song, you have now the AI assisted song, and then so how does a solution providers adapt their offerings to cater for this kind of evolving needs for you? May I ask Dr. Rahman? Yeah.
It's a difficult question. My answer is you're not gonna like it, but it's hard on every single solution provider to keep up. It's not, I mean, you can't deny it. Even the people in the solution provider business are already aware of that. The only issue is that people measure the progress and the evolution with what they can. I mean, if you measure the evolution looking at large language models that are provided either in the open source community or in the non-open source community, and you see, okay, this is the evolution of AI, why are we not getting solutions on par from the solution providers? Then it's an unfair comparison, because if you measure the amount of hallucinations that these models are doing, you wouldn't want to put it in your network, right? So it's easy to make a new solution, but it's not easy to make a new solution that is dependent, you can depend on it. So it's a big difference. And if you just want a new solution that is based on state of the art, maybe I can give it to you next week. But if you want a solution to deploy in your network and actually depend on it, on its performance, not to completely mess up your operations, then you have to wait, because it's a process. And this brings me also to the topic that a lot of people are currently, and I'm a standards specialist, so I participate in these standards discussions. And a lot of people have the understanding is that the evolution is plug and play. I'm gonna give you like, I'm gonna put an application here, and you're gonna bring a model from somewhere on the Google Play Store, and then you're gonna plug it in that application, and the application is gonna make energy efficiency in your network fly through the roof, right? It's not how things work in practice. If you've attended any contract signing of a single SON module, you'll understand that this is not how things happen in practice. There's a data exchange under NDAs, and based on this data, you design solutions that are extremely tailored to that specific use case. The understanding is that you can bring an off-the-shelf model to do the same is, for me, understanding the current technology evolution is crazy. So just having a high level understanding that technology is evolving, things are advancing very fast, yes, but there are a lot of other parameters that you need to take into account.
Thank you so much for the very, very nice insight on this. Maybe I'll ask a follow-up question if that's me, if I may. So in terms of like what it's saying is like how can we actually trust what you're trying to implement? But like we cannot just take off the shelf models, put it in network. So how, since your background as a for in terms of the standard itself, how do you see the regulations or how do you see the standards can help in these aspects?
Yeah, I think Christina presented a very good overview today. And the topic of trustworthy AI is very important to us. And even more important in the light of current large language model hype, because it's very hard to get explanations from a large language model. You ever interacted with a large language model, asked him something, and then you told him this was wrong, he changes his mind. So if you tell him to explain why you came up to that conclusion, he may also be as well hallucinating, right? So you need to have a balance, and this is in your own solution design. You need to have a balance between performance, scalability of the solution, as well as what you can actually explain. So back in the computer vision days, like 15 years ago, it was the easy solution to train a neural network to do your classification. The really good people were the ones that actually came up with a closed form solution, mathematical model. So training a neural network to solve a problem based on a data set, that's actually the easy part. What's hard is to make sure that your solution can explain, or you're able as a domain expert to explain why the solution is behaving a certain way, which is not possible with the current generalizations made by large language models. The bigger your model, the harder you can explain yourself. So the second half of your question about what regulations and standards can do is that, again, like Christina said, the requirements that come from operators, these are requirements on everybody in the complete chain, the solution providers, the operator himself, the application providers, and they should all abide by these requirements. If the requirement is on the fact that there should be a minimum threshold on explainability of AI decisions in the network, then it should be so. Of course, it's going to limit innovation, but at the same time, it provides trust for the operator in what is running in his network, right? The operator runs a module, and this module takes a random decision, and he can, like Tesla went for back, I don't know how many years ago, when they had this, I think it was the self-driving cars in California, when they made some form of bad decision, and they actually had to retrain it from scratch because they can't really know why it made that decision, right? And it's a similar. Yeah, thanks.
Thank you for taking that very difficult question. But I like your answer that you split in two parts. Like the first part is like, the really good people that really knows the mathematical models behind it. I'll say it from the academic part. So I'll jump in on the academic part in terms of that. So sorry, let me ask the question. So how can the industry, knowing that, how can industry collaborate with academia to ensure the practical feasibility of the AI research itself? In a sense, because you need to know the reasons behind it. So how can the industry collaborate with practical AI native research? Maybe I want to say on this, since you work on the research part as well as you're in the industry design.
Yes, it's actually I can say that it is something that we must do. My team in Turkcell, actually, we are really not me, but the rest of the team are really academic. They have the PhD, and again, besides me, every the person's name is starting with doctor. So actually, the problem from the industry perspective, the academia is bringing the solution there to the scientific. Sometimes it's impossible to integrate, or sometimes it's just not necessary. They're overkilling it. So, and also in the industry, we have some more other problems like the budget, the energy efficiency. So, or we don't want to, deploy the solution into GPU. They're expensive, this kind of stuff, and the operational stuff, the security. We're of course. The academician, for example, the bringing some cool algorithms, they're really cool, but they ask us to, put all of the personal data into the cloud, which we cannot do. So that's why I think this collaboration is really important because the industry needs to really define, of course, not all of the academia needs to work on the solution that will be directly integrated in the industry. We need to have some academics working on the crazy stuff. But if we want to solve the current problem in the industry with the help of the researchers, the bridge is really critical because the industry needs to define the problems, the KPIs, the needs, and in the industry, the problem is we are for-profit companies. The best one, the Bell Labs, the Bell Labs is the really the one of the most I don't know, important research institute, even they are the product companies. So that's why we have the R&D perspective. We cannot try the different aspects. We don't have this much experts that can bring the different perspective. So it's, this collaboration increase our knowledge drastically. That's why it's the mutual benefits. So the industry needs to explain explicitly what is the problem and what kind of solution is needed. And academia and researchers can bring the different aspects that can be a better solution for the problem. So yeah.
Thank you so much. With that, I would like to listen from the viewpoint of the academia. And Professor James, yeah.
It's always good to listen. When questions like this are asked, it's always good to, first of all, take a listen to those in the industry. Because it's the industry that attracts academia. So I'm probably collaborating, seeing how we can solve problems. So she has spoken marvelously well. But what I just want to open up is that without the industries, if the academia embark in research, what eventually comes out is not what you actually what you expect. So it's always good to actually get this background from the industry. Then the academia coming to collaborate because it's a problem. They identify the problem and then we look for how to bridge that gap. Yes, as she said, not all of these problems are actually meant for the academia. There are some which might, she's correct what she said, it's not necessary at some instance, but when it becomes quite necessary, the academia could come in. And in coming in, there are key parameters that will be set for the academia. You see, sometimes when we discuss in our environment, people tell you, please don't be too academics about this. In our normal day-to-day life, don't be too academics about this. And so you probably want to ask, what is it? Is it as if you know to what academia gives? No, it's about looking for the academia actually comes up with a framework that can be acted upon because the algorithm designed for problem solving most often come from the academia, and the industry will collaborate and gaps will be bridged. Let me put it to us that if I've actually come to that conclusion that if the industry does not make a request and academia embark on problem solving, most often survey has shown that the results is not as always good as when the academia, the industry meet that demand. So it's very key. So the collaboration is quite necessary, is needed, and we've seen results, practical results in most from most experience derived when academia and the industry collaborate. Thank you. Maybe
No, thank you, Professor James, for the very applied research kind of point of view on that. But I would like to hear from Dr. Paul as well.
It's not complete.
Yeah. Not complete without the system engineer that yeah, keep saying that he's from Canada.
And so just to make sure I'm okay, could you repeat the question?
So, okay, so I'll repeat it. It's very, so how can industry collaborate with academia to ensure the practical applicability of AI native research?
Okay, so I think all the good answers have been taken by this side. I think that your point is excellent. It's that if you, so yeah, ivory tower, come up with, hey, look, cats that can fly on the moon and still breathe, or whatever insanity they're gonna come up with. Sure, we can do that. We like to do that. It's fun. But if you want something, if industry actually wants something, they need to spell it out clearly. Data, very nice. Data is always a challenge from an academic perspective to get what it is. I'm not even going to talk about funding because that's a whole other seminar series or something else. But yeah, from having done it from the industry side, talking to academia, and having done it for the academic side, talking to industry, actually, it's the relationship. We're all people. And the AI native is, let's say, a defining area that hasn't quite emerged yet, and we're all going to try to substantial things or whatever you want to talk about. So I think finding the people that you can work with in the right sides of different things to actually come together, so that you feel confident to send your students off for internships, so that they can work on targeted projects to do different things, so that maybe some confidence builds with some smaller projects that then build into bigger projects. Because half the academics in my university, you walk up to them and say, yeah, sure, right, I want £5 million because you're at Intel, and we're going to have a 5-year collaboration, and you give me the money, and I'm a genius, and then we'll give you results at the end of it, and that's the way it works, right? Because that's what research is, right? And so, no, right? So I think beyond finding the right form, building the relationship, working with different people, it's also about building that collaboration and finding that community of trust that you can actually work together, so that you can begin to confidently and freely talk about, well, this is what I think AI native means to me. This is what I don't think it means to me. This is a use case that, oh, I never thought about that use case before. You can be accepting of all these different things. But I think the best answers we can take it here.
No, well, I think you gave a very, very nice answer to this. I think, yeah, we have the spectrum of things on how this collaboration works. And you have the pure industry part that is highly applied. Have the bridging part where it's like applied research itself. And then you have not ivory tower, but really the cutting edge part of the research that actually push the boundaries of this topic itself. Without that, I think the industry will be always left behind as well. We can just talk about fully apply, and then means it's too practical and you don't evolve. So I think the answers that given by Trivial, I think it's a very nice spectrum from one end to the other. So thank you so much for that. So on the second part of what we're saying, in terms of the keeping go the time, maybe this might be the last questions. I think very important questions at this venue itself. I think we're trying to figure out. So what role do you all see ITU can play in the standardizations of AI native itself, and why is it so important? May I ask Professor Lee your view on this?
Okay, so actually I was from academia, our middleman of the standardization of the activity. So I would like to express my views. Actually, from last year, we started to consider AI native, particularly in activity study 13. I would like to ask you one fundamental point. What is the reason to consider AI native? So we really need to identify the strong necessity. So most of the papers participating in the standardization meeting, they agree to consider AI native. So when they started to consider this kind of new technical solution, always they request what is the dimension of scratch. So we also follow the similar approach. However, rather than just the definition aspect, the most important thing is identification of the requirements. From the requirement perspectives, it's not just only for network operator. So currently, there are lots of different roles there's no particular barriers. Network operators can use service providers lots of different roles. In this regard, we need to clearly identify why this kind of technical approach is necessary from so many different perspectives from different stakeholders. So in this context, rather than just indicating one particular domain, we need to think about a new ecosystem. So long time ago, network operators just provide high bandwidth and then wait best kind of applications. But now so many demand from the individual users, they just want to consider so many different kind of applications. Network operators need to timely support lots of strong demand from individual users or individual service providers. So in this context, first clearly identify so many number of different requirements. This is really fundamental important things. And then another point, so how we haven't yet considered, we just simply borrowed, for example, we have requirements that we can directly go for specifying lots of technical solutions like architecture viewpoints, specifying functional models or some functional blocks, including interfaces. But in the AI nature, from this kind of requirements, we should develop our own design principle. It means that we need to fundamentally differently consider to support AI native. Because rather than centralized approaches, etc., nowadays so many technical solutions, particularly AI technical solutions, will be embedded a kind of standalone solution. Just individual small devices or equipment also want to use AI solution. But important thing is collaboration. So collaboration is really, really fundamental issues in order to support interoperable solutions globally. In this context, from standardization viewpoints, how we facilitate this kind of collaboration from so many different kind of entities, some small devices, some small edge or base kind of distributed environment, and even traditional centralized servers and clouds. There are lots of different elements. It's not just only networking elements. Most of these kind of technical solutions will be integrated and composed. So in this context, we need to clearly identify how we correctly define certain particular functions in a different ways to accommodate this kind of different demand. If we have a clear view regarding this kind of very fundamental design principles, then all of the participants to these standardized meetings can appropriately bring relevant solutions. Otherwise, different ideas, so many different opinions, it's really difficult to reach a consensus. So in this regard, I really want to promote to bring some common understanding and very important design principle issues. After getting these kind of key ideas, we can split based kind of different roles and then stimulate the relevant activities. I believe this is really important steps for the future.
Thank you so much, Professor Lee, for the very precise insight on why IT can play such an important role for this kind of technology itself. I think that's conclude our panel sessions. I think everyone agrees that AI native is important for the future. It's part of the roadmap as well to incorporate this as part of 2030 or 6G itself. And I think we have discussed how various entities itself can come together and collaborate together, from solution providers, the operators, the academians, how everyone can work together, as well as how ITU can play a very crucial role.
Can we take some questions?
Okay, so,
I have a question.
yes, Marco.
More than a question is a comment, yeah. I fully share this discussion. Also, Dr. Kader said the nice things at the beginning that we need to create a humus, right, where this AI native cutting. I think an important point will be anyway, because the requirements come from the operator, right? So we talk about academy industry collaboration, the requirements from the operator. So in this path, which is an evolutionary path, we can consider new design. We can consider the requirement for this and so on. We will have also always to think about, but it's not a criticism in the sense that operators are not going to change from one day to one network to another one, right? So in fact, when we were talking about this, I was thinking, but really personal consideration. AI native, when we talk about autonomy, L1, L2, L3, L5, maybe we have an AI native, partial AI native, fully AI native, and so on, because we need to think a way to integrate these things gradually, right? So some function may be AI native, some other function will come later. But I think in the discussion you're preparing of this focus group, these things are there. I want just to say that obviously the operator always the key point in terms of deployment. Thank you.
Thank you, Marco.
Yeah, I mean, probably on spot, right? But I think not a lot of people understand that network evolution is not going to happen overnight. Yeah, obviously. But I think a lot of misunderstanding is on the. A lot of people think that autonomy is a synonym to native AI. Native AI is not going to bring level 5 autonomous networks. Let's all agree on that. And level 1 autonomous network does not mean full native AI. They are in parallel or orthogonal or different planes. You can have a medium adoption of native AI as you define it, and a medium adoption of autonomous networks. They're kind of course, they're intertwined, but you can have one without the other, and you can have the other without the one. So you can still have kind of a native AI network without achieving full autonomy, so having human in the loop. You can achieve full autonomy without relying 100% on AI, because closed loops, because policy, etc. Right? So, but I totally agree with you. The evolution is not overnight, and it's going to take probably a few generations to get the full autonomy level.
Maybe I can, maybe. Since you mentioned operators, actually, you're totally right that it's a really important, actually it's important for every AI-related integration into the network itself. And the adaptation, the transformation, something in the network with a more the intelligent one, it is the important issue that is discussed in the operators. And there's the subgroups under the GSMA, for example, how we're going to do it, how we're going to measure the success, that everything is problematic. And right now, everything is a really big question marks. And also the other thing is that, let's say we have an AI native system, or the autonomous AI system, or just an AI algorithm, doesn't matter, or this, how we are gonna sure that it's not gonna affect the customer. So because we are touching the customer itself. So when you say it, for example, any or the engineer working in the operation, okay, we're gonna replace it with an AI model. They say, yeah, you are. And then if something happens, then what? Because it's a really big problem. It can create some catastrophic impact on the network, because the network is a really grift architecture. So it's not cause sometimes the effect in one node, it can affect the city itself. So that's why it's some of the part is really important, and we need to define the transformation of the, and it's not probably the general transformation. We need to discuss what we want to transform in the network itself, and we need to define the success. It's probably it will not be a probably general definition, but we need to the handshake first, the success, and then design the transformation and then integrate it.
So just tiny little comment because we're running out of time and, good conversation. So Marco knows how much I hate the 5 or 6 levels of autonomy. It's too linear, it's too tiny, it doesn't capture everything that goes on. And just to open the box a little bit. So AI is a field of different approaches and technologies and different things, right? So I think it's even worse than to just, the levels of AI nativeness. I think it's, if you're really thinking about networks as distributed systems now that have to be provisioned with sufficient capacity for data telemetry, which we're hearing from our Red Hat colleagues this morning is, well, how much do you need? How much can you actually sample and pull? Which then depends on which type of AI technology you're trying to use. Then it becomes this massive 3D dimensional matrix per technology in whatever use case you want to have. Because do you provision AI native for every possible scenario you could try to think about? Do you have a subset of scenarios that you want to consider based on the technology that you want to use? So you get these kind of cross products of use case of technology coupled with infrastructure, and then how far along the spectrum you are in making that possible. So I think it's even worse than a linear 6 levels. It's even bigger.
Yeah, can I ask a question? So I want to ask a very fundamental question. I don't know whether AI is a functional aspect or it's a operational or management related concept. So I want to ask your opinion. The reason I'm asking is a functional concept, in my opinion, is something which creates a new function. A new network function or does something which is new, which is not there in the network right now. I don't think so, at least in my opinion. AI native does not create any new functionality in the network. It's something like softwareization or cloud native, which has happened, few in the last recent times. So there is the analogy that I can think of. Now, however, if I use the same analogy as well, that transformation, that is the softwareization or cloud native itself has made operational changes and management related changes. The way we manage the network, way we operate the network has indeed changed because of cloud and DevOps and MLOps. Azure just came in the right moment. Karim is already here. So we had a lot of discussion around that. So in my opinion, this is an important distinction to make. I think to answer Professor Lee's point about how do we explain this to people, I think this is an important concept to distinguish between what is new here. If you ask me functionality wise, I'm not introducing any new functionality here. But at the same time, that's the same answer which I can give for cloud native or software native, if I call it. So I want to ask your opinion. What is it? I mean, do you think it is functional? If it is functional, what is that function? Do you think it's operational or management? If it is, then how do we characterize it and answer Professor Lee's previous question about defining? Yeah, exactly, design principle. I mean, if you ask me, if you consider this as a management aspect, if you consider this as an operational aspect, then to answer this question is fairly easy. I mean, it's possible. It's possible to answer this question. But I want to ask, the experts are here. So what is your opinion, please?
Yeah, so the short answer is both. Because like I said in the definition, it's a way how networks are designed, operated, and deployed that will change, that has to change eventually to accommodate for the new pervasive presence of AI in the network. However, if you look at history, this also resulted in introduction of new functionalities. From a 3GPP perspective, we have NWF, Network Data Analytics function. We have Management Data Analytics function. Even when we go to the cloud domain, we have cloud orchestration functions that are a result of the cloud native approach, the cloudification of the network. So just because the design, the way we operate the network is the one that will change, doesn't mean we're not going to introduce new functions. Maybe the way we operate the network when it changes requires that we introduce new functionalities. So I'm not saying that we have to introduce new functionalities, but I'm saying that we may need to, depending on how in the end, the design principles are defined.
Yeah, Abdul, I want to counter your argument a little bit. I want to say that I mean, just taking the devil's advocate here, I want to say that is like saying that, I will first invent the problem and then you invent the solution. That's, it's not my opinion. I am just telling you that there are.
That's probably how 3GPP does it.
Yeah. That's a good way to put it. But yeah, that is the counter argument for it. But yeah, proceed, please.
Yeah, actually, there are too many different perspectives. Particularly, if we concentrate on functional aspects, it's really difficult to differentiate so many existing AI-related functions. So in this regard, there are some different approach. So many times I mentioned approach, such as tiny ML. It's exactly the same ML, but different ML, tiny, lightweight, so that kind of things. In terms of implementation point of view, it's totally different approach. Although we can provide a similar function, so we need to first think about this point. Secondly, rather than just a functional point of view, your point was operational aspect. In terms of operational aspect, I would like to more focus on process, the particular workflow. This is operational aspect. Because so many number of AI-enabled solutions, right? AI-enabled or embedded this, embedding so many number of AI functions. The role of the network is to interconnect so many different available resources. AI models are resources, data are resources, so many number of resources need to be interconnected. And then on top of this kind of interconnecting environment, we need to build up so many number of applications. So there are lots of good things to support this kind of point with a bad manner, so many number of ways orchestrating the innovation. When we are talking about this kind of keyword, resources locations are totally difficult and then geographically different locations. But we want to build up a kind of logical networks to work together. This is very fundamentally important. So if we successfully implement this kind of a new way for harmonize so many number of resources and then best utilize this kind of resources to support so many vertical applications. So then this is really AI native approach.
And this may need a new function.
Do you take comments from? Thank you. So I guess now industry stands united. I would like to agree with Abdul. It is both, and to complement what Abdul just said, it's also think about the AI as a service, where we actually start giving some machine learning tools or registries, all kinds of performance assessment of the models. Now this is functionality that you can expose, you can sell. I mean, it's not just a means to an end anymore. So it is both.
Thank you so much. This has been a very interesting panel discussions from everyone, the panel themselves, as well as from the floor itself. So I really want to thank everyone sharing their expert opinions as well as the experts' comments as well from the floor. So thank you so much for joining us for this panel session. Again, a big applause to all the panelists. With that, we have pleasure of having Dr. Bedell, the director and chief of TSB's policy department. And kindly can ask Dr. Bedell to give us the closing remarks for the workshop.
Thank you very much. I know you've had a long day and the team prepared the long ending remarks for me, so I'll make them very brief. Hopefully you enjoyed the workshop. Unfortunately, I haven't had a chance to really be with you earlier today. It's been a really busy day with the AI for Good Summit. And today we reached the capacity of the building, 3,200. So people had to line up outside and we had an interesting problem to solve. But certainly the topic is growing in interest. AI for Good is something that the world now converges on as a platform. And your workshop is part of that important conversations we're having. So I think you've looked at a number of areas of compatibility, scalability, and twin networks, the concept of GIMS, training, network creation, in the sense of application-driven networks, the important topic of cybersecurity. We've really covered quite a broad spectrum of work and topics. And this was in session 1. And then in session 2, we looked at the how these could be expanded, foundations expanded by examining the requirements and architecture aspects of generative AI, AI native systems, integration of AI and machine learning in Wi-Fi networks, deeply integrated and distributed AI, the KPI requirements, AI native communication in 5G or RAN, back towards 6G, quite a diverse set of topics. Some of the takeaways from the day was the importance of AI native concepts, but I still heard there's a discussion to be continued. Hand-picked solutions from the AI machine learning challenge, especially with partners such as Zindi. By the way, Zindi has been an amazing platform for capacity building. Because in this summit and across the conversations we've been having on governance of AI, the standards of AI, capacity building, of course, the AI for Good platform is a catalyst. I think the capacity building has been tremendously enhanced through the challenges and through the Zin platform. I think we have more than 22,000 students, and programmers and coders and challengers that have joined that for many challenges, 5G, machine learning, tiny ML, and so on. So that has been a tremendous asset in capacity building for experts from developing countries or people who are trying to learn. And open source, as you might have heard yesterday, we had the panel on open source, and it's a certainly an important element in our discussion on AI. Karim also mentioned it today in our roundtable on standards. There is a complementary nature of open source and standards. And on Monday, our Secretary General and the Minister of Switzerland announced this new collaboration between ITU and the Linux Foundation on the Open Wallet Forum. It's called the Open Wallet Forum, which is really to bring digital IDs and other things that we put in our physical wallet in the digital space. So stay tuned for more on that. And then I think you discussed all the large language models, autonomous networks, joint sensing, general AI, some of the 6G, and I hope you didn't go too much into the radio sector domain, because our PR colleagues and ITUR study groups are very jealous for their space of work. So hopefully we can keep the lines clear between the T and the R sector. The energy efficiency, of course, is an important element. Really going forward, I think it sounds like there is more dialogue to be had to try to find consensus of what exactly study group 13 and any structures within IQT could help in solving real industry problems and looking forward into the future within the study group construct. So I thank you all very much, all the moderators, the speakers, the participants, for your hard work throughout the day, and look forward to continued collaboration in the AI for Good and in study group 13. Thank you.
don't forget, there is a nice reception at 6:30 to 7:30 for all participants. So, if you want.
You should remember WTO, they asked me to say it. WTO dinner.
For the, yes,
o'clock.
the VIPs and speakers, I think there is dessert as well afterwards. So there is a reception from everyone from 6:30 to 7:30 here. And then for the speakers and VIP badge holders, there is a reception at the World Trade Organization, which is by the lake, from 8 to 11. Thank you. Enjoy the evening.